everyone. All right. Morning. Good morning, Riga. I hope everyone's enjoying the city as much as I am. It was unknown to me until this week, and I'm finding it absolutely lovely. I want to start by asking everybody to pay attention to the emails and the signs you've seen up asking for feedback. The team that puts on this event, they put a lot of work into this, and one of the ways we can repay them is to give them our thoughts, our ideas, even if it's a critique, to help us make it even better next time we do this. So we really appreciate that. I also, while I'm in front of you all, want to give you a few hints about this evening. I will remind you at the end of the day, of course, that we have the closing party. It looks like it's going to be awesome. Getting there is pretty easy. You leave the hotel through the only exit, you make a right, you walk a block. It's very straightforward. It's a place called the Digital Art House. I think we'll all enjoy that. You do need to remember to bring your badge, so that will make it even easier for us to find. Just follow the people with the orange lanyards. So I think we're all good there. And with no further ado, I will hand over the mic to Graham and let you do your thing.
Oh, thanks. I was going to give it to the, okay. I don't know, do you guys want to come up on here? Do you want to sit down at the, yeah, I think so. I think this is it. That was slick. Thanks everyone for coming on a Sunday morning after the Saturday night. Really appreciate it. So this is a conversation we hope about the future of AI. My name's Graham Morrison. I'm a writer here at Canonical. I've been writing about Linux for a long time. I think my first experience with AI was Eliza on a Commodore Amiga. And I think 30 years ago at university, we were talking about assumption-based truth maintenance systems and neural networks. And I think the proliferation of capabilities in compute have really pushed things quickly in the last few years. And I think that's the kind of thing we're going to talk about. I actually asked ChatGPT what you would ask a panel of AI experts to introduce themselves. And I also added that suited to an audience of Ubuntu Linux users who may have a more critical or skeptical view about AI. And this is what ChatGPT says. Welcome, everyone, to this exciting discussion on the convergence of open source and AI. We know that Ubuntu Linux users often have discerning and critical perspectives. To kick things off, I'd like to ask our panelists to share their personal journeys into the world of open source and AI with a focus on the challenges and ethical considerations that they've encountered along the way. How have you navigated the intersection of open source principles and AI landscape while addressing the concerns of users who value privacy and transparency? I think that's a big question, but I thought maybe we could go through each of you and you could introduce yourselves, tell us a little bit about how you got into AI, and we can take it from there. Maybe start with Craig here at the end.
So hello, my name is Craig Lowen. I'm a product manager at Microsoft. I'm the product manager for the Windows subsystem for Linux, and my team's charter is making development great on the Windows operating system, and a key component of that is infusing AI into developer workflows. So a lot of the work that I'm doing nowadays is how we can build AI tools to make developing software easier. Thanks, I'll pass over to Frank.
Thanks a lot. Frank Karliczek from Nextcloud. We are the open source alternative to Microsoft 365. Sorry for that. And I think AI is something we do for a long time, but of course it's accelerated the last 12 months. So like a year ago when ChatGPT came out, I was a bit depressed because I thought, okay, this is nothing where the open source community can compete. But actually it turns out a bit differently now, and there's a lot that open source can do. And nowadays we have all this nice open source AI systems integrated into Nextcloud, and yeah, I'm happy that there's still an alternative to big tech.
Hello, everyone. Good morning. I'm Paolo. I'm CEO at PenPot, an open source design and prototyping tool for both designers and developers. And my journey in open source starts in 1997. That's a long journey. In AI in particular, I think it was 2015 when I was building computer vision, ML-enabled products, and also signal processing, also ML-powered signal processing. Now, on Pampot, we're actually having open source AI challenges because we understand that this dual nature between a visual artifact and a code artifact, which is a design using open standards, is quite a challenge for AI these days, but it's also an opportunity if you use open source AI.
Hello, everyone. I'm Andrea Monteanu, MLOps product manager at Canonical. I started with AI in university. Everyone told me it's not going to fly, so I was quite stubborn, and here I am nowadays. We're looking after infra to build AI projects.
Hello, everyone. My name is Juan Luis. I'm product manager at Quantum Black, which is part of McKinsey & Company. But I've been a developer for all my life, and I've been very involved in the Python community, especially in Spain. I co-founded the Python Spain nonprofit, organized the first 7 PyCon editions in Spain. And I came to AI just by chance. I've been working with intersection of Python, data, open source for a very long time, and I've been teaching students how to apply machine learning, the classical type. And I spend too much time on LinkedIn and formerly on Twitter as well. So I'm very exposed to influencers and things like that. So I've been starting to grow a little bit critical of the whole AI movement and so on. So looking forward to participating in the panel.
Thank you. So this question, actually, we've shared a document between ourselves, and we shared some questions that we'd like to cover. The idea is that we try and have an informal conversation about AI. But to start off with, this is actually a question that Pablo proposed. And it's, how can open source streamline the benefits of a surge in academic research? So maybe you'd like to start off with your thoughts on this, Pablo.
Yeah, I think a lot of people underestimate the enormous pressure there is at the moment in academia to publish the research. Like universities and research centers all around the world do need to show off what they are building. And that, by design, has to be open to the public. So if you know that, you're aware of the fact that not only big corporations, but actually universities and research centers have this enormous pressure for PhD students or just anyone really in the research field. Well, there is a natural link there with open source. It always will be, right? So how can we do that? And I think it is important that we are very, very close to these communities, making sure that they have the right open source tools to also to build what they are doing, and understand that sometimes, just sometimes, the quality of the software that they're building might not be excellent, but the vision and the ideas behind the research are. So we have to be very empathetic about that. But yeah, this is a very important topic because it is probably one of our few advantages at the moment.
Pablo.
And if I may add to what Pablo just said, there's a number of very interesting initiatives that try to embody the open source way of working in academic research. So for example, the Journal of Open Source Software is run by volunteers, basically, and all the reviews happen in the open on GitHub pull requests, basically. And they do a great job at moving this research software forward and try to make a positive impact at a very low cost. So there's some blog post that runs the numbers that are needed to run the journal, and it's possibly the cheapest journal in the world at the moment, which makes the other academic journals pale in comparison.
I mean, I was going to ask as a follow-up, maybe Andrea is a really great person to answer this. Linux famously was able to bootstrap itself by people working on computers on their own. The hardware was relatively accessible. That accessibility is really difficult with AI in terms of the infrastructure that's needed. How do you think we might be able to, as an open source community, accelerate and get the experience that we need to become experts in this as just normal open source community people?
I think there is a bit of a misconception. In order to get started with AI, you don't need that many resources, and nowadays just a laptop can be enough. And I'm not saying that you'll run your project in production with that, but to get started, to begin your journey, to see if you like it or not, you don't need that many resources. At the same time, if we look at the core of open source, which enable us to contribute to make things better, I think we actually save a lot of resources, and we benefit from having different people bringing different angles and doing different parts of the machine learning lifecycle in order to actually accelerate or leverage more the capabilities that each one of us has. And it goes into hardware, infrastructure, capabilities, like skills that we have as well.
I mean, I don't know if there's anything you can say about what Canonical might be doing or what we might be doing at Ubuntu to help people get access to AI resources.
Sure. Even if I don't want this to be a...
No, but I mean, it's interesting. I mean, we were talking about this with Pablo and Penpot, how it's interesting to know what it's open source at the end of the day, and it's accessible to people.
And it's quite nice because I was at the summit yesterday when someone told us, hey, I watched your webinar and now I'm like playing with large language models using also your tools. So in Canonical, we package open source tools that are designed for MLOps in order to simplify their activities, but also to run the entire machine learning lifecycle. Why does it help? Well, on one hand, because it's easier to get started. We have some analysis that we deploy the Kubeflow, for example, in 10 to 15 minutes, whereas the upstream can be more difficult. But at the same time, we enable capabilities such as upgrades and updates, which in the upstream are not there. And if I look at how much you can run on a laptop, well, it really depends on what laptop you have, but I do have colleagues who do that as well, and it's their just work laptop.
Oh, thank you. I don't know, I mean, Frank's discussion yesterday about Nextcloud, you were talking about setting up the APIs for accessing ChatGPT, and was it the University of Helsinki's?
Yeah, yeah, we have integrated like SaaS solutions, ChatGPT, but this is actually more like a, I don't know, like a demo. We're really betting on locally running, completely open source, independent AI systems, and we put a lot of resources into it. We have a dedicated team working on that. And this is something which just really was interesting the last few months, because as I said earlier, like a year ago, everybody thought, well, it's ChatGPT, it's just this proprietary bubble and no one knows what's going on. And nowadays, a lot of tools, or most of the tools are available, packaged for Ubuntu, of course, from the software perspective, but also training data. There's a lot of training data freely available, a lot of models can be used, and you can really do a lot, like locally on a laptop, as mentioned. I mean, the only thing that is a bit critical, if you really want to build your own large language model from scratch, then you probably need, not probably, you need a lot of GPU power. But even that is getting easier all the time. So yeah.
But I would like to add something here. We should not all aim to build our own LLMs. It makes no sense and it's a waste of resources. So we would rather take open source LLMs and optimize them for our use cases, not to build our own.
And just a quick addition to that, I think it's important to know that the OSI, the open source initiative, is still figuring out what open source means in the context of AI models in general, right? Because for code, it's very simple. Like if you can see the code with a license, then it's open source and that's it. But for models, what if you don't have the training data, for example, or if you don't know how the reinforced learning was conducted and so on? So there are like many other factors, and I think they're actively, as we speak, trying to figure out what open means in this case. So we're talking about it very broadly, but the definitions are still in progress.
What do you, I mean, do you see many people on WSL, for example, experimenting with, I don't know, Linux-based AI?
For sure, we do. And a lot of Linux tools are used for AI development, for fine-tuning, et cetera. And so I think tools like the Windows subsystem for Linux allow it to be able to be used on Windows. And then also when you talk about access to AI models, the other cool stuff that Microsoft's done we've added Llama to. So we worked with Meta to open source the Llama large language model, and you can actually download that and fine tune it exactly to Andrea's point of you can specifically modify that for your application. So I think that there is an industry trend of open source as a powerful tool of getting these LLMs to people to be able to run locally, no matter what platform you're on.
Going back perhaps to, sorry Frank, do you want to say something?
No, I just want to add something quickly. I would be a bit careful with calling Llama open source, because it is, for me, it's like free as in beer, but not free as in freedom. You can download it and use it, but it's like a binary, basically, right? You can use it, but you cannot really look inside how it actually works. So that the training data would be needed in other things. So, yeah.
I was actually going to say, following up on what Juan said about licenses and the OSI and still investigating things, how fit for purpose do you think the licenses that we have are for dealing with, well, firstly the training data, but also the data sets that you've got when we share them and where the data, the sets have come from?
No, they're not suited at all. Actually, I do believe that current open source licensing is not suited at all for open source. So, I think since I have this perspective of that we need a new social contract in terms of how we share our data and how we contribute to the training data sets and all that. And I don't think the solution is just licenses, but it does help. It's a social contract that has some legal foundation. So unless we get something that is very clear, very obvious out there, we are going to be using like the old regime framework in terms of licensing and expectations, and it's not ready. It's not suitable. It's just okay for the transition period, but I think we need a new framework, and that includes, for this new social contract, we do need new licenses. Yeah.
And on the topic of licenses, I'm very excited about the work that Hugging Face, the company, is doing, because they're pushing these Rails or responsible AI licenses that somehow embody the open source principle, but not quite, because they restrict for what things you can use the AI. So they have like a set of limitations on use cases and things like that. And I think that puts us in a very interesting debate. You know, like do we want to make the AI only for the good, so to speak, or we want to preserve the neutral freedom that the open source licenses embody? You know, I think that's a very interesting debate.
I think that as much as we like to think that AI is going to be used only for the good, and as much as there are many people who say AI is, I don't know, taking over the world, the truth is that it's very difficult to control what's happening and how it is being used. And at the same time, it's so quickly evolving that I think that regulations and even guidance on the topic feels a bit slow. However, that is not something that is the first time when it's happening in the world. Any new innovation came with exactly the same challenges, and in the end of the day, society found a way to make it work.
And let's not forget that technology is not neutral. Technology is not neutral at all. So why AI should be? It's what you do with technology, it's what the technology you build, the technology that you don't build, that has an agenda. But technology is not neutral. It's that's something that we sometimes think as people coming from science. Science is neutral. Technology is neutral. Not really. You know, what are you building? Why are you building that? What are you not building? That has an impact. So I think sometimes when we have these discussions, you could replace AI just using the word technology, and it just basically works too. So yeah, totally agree that it's not the first time this is happening.
For sure. And I think one of the biggest reasons that you do licensing as a maintainer of an open source project is sometimes there's definitely like an MIT license, there's an aspect of that of, I am not legally responsible for your usage of this. And I think one of the challenges is AI is so unpredictable. If you put out a training set, if you put out data or an AI model, you don't know necessarily what it's going to do in every case. For example, Google had a great ethics paper about how face detection AI had a significant racial bias. And it detected white males very well, but for African-American females, it had like a 50% failure rate, which they didn't realize until much later, and people were already using some of these models. And so I think, I totally agree. I think there's the power of this is, it is a powerful tool that can have some unintended consequences. Like other pieces of technology, we're going to figure out, hey, I'm going to make sure that this is used responsibly, et cetera.
But it also has intended consequences. So, for example, the way you look at how big companies like, again, sorry, Microsoft and Google and others are developing these systems, this is not just accident that happens here. There's a strategy behind it. Right? There's a strategy to monetize that and to have vendor login and other not so nice consequences. And I totally agree that technology is not neutral. And I think this is in the core of the open source free software movement, that we actually have ethics and we have some goals like actually improving IT for the whole world, not just for some big companies. And that's something we should always realize and we should work on and to make the world better.
Oh yeah, I'd love to talk about ethics, because I agree, like it is kind of scary. Work for Microsoft, it's a huge company, we're doing lots of AI stuff. You know, how do you guarantee ethics in AI? How do you use AI responsibly? And speaking personally as someone, like I'm developing AI features for developers, we have a very rigorous step to go through. And part of those are considering, you know, what could this AI say? Does this AI have any significant biases? What harms could it have? Because I agree it is a scary space, and like a large language model like a ChatGPT or a chat experience, there's a high level of unpredictability, and how do you kind of protect users, themselves, their data, et cetera? It's a tough problem.
I mean, touched on briefly there, one of our questions was about bias, and we discussed this yesterday actually briefly, but I know that open source shouldn't have more of an obligation, but we have perhaps more agency to change things in terms of bias of models, the input and the output. Have you any thoughts on what we could do to make that an action rather than just an idea?
Well, transparency. You really should know what's going on. And we as open source community, we usually have that, right? You have the source code, you can run it locally, you really know what's going on. With lots of those AI systems, you have no idea what's going on. Right? GPT-4 is a complete black box. Copilot too. No one knows what's really behind that. And that's a big problem. So we really need like more transparency, what these big companies are doing there, and like really opening up completely with the training data and the algorithm behind it, and only then I think it can be trusted.
Do you think?
I'll say you have to be transparent about your bias, because I'm very biased. I'm super biased. I'm super pro open source. That's a bias. But I'm transparent about that. Yeah. So you can have both. You can be transparent and you can be biased. But people have to know.
Maybe linked to this as well. Do you think it's possible for us to incorporate attribution in some meaningful way?
Yeah, thank you for the question. I think it's a super difficult technical problem, right? There's a talk that I attended at PyCon Estonia a couple of months ago by David Mertz, who is working on an attribution framework for AI in general. So how a system can tell you in some form of structured metadata where did it derive the different sources of information. And I think this would be a dream come true to have, you know, to be able to say, okay, so I'm getting this text or getting this image, and I drew information from these 10 writers or 10 artists, you know? Because obviously, like, every single point of the data, the training data is going to have a contribution, but there's going to be some major points there, you know? Then how do we do that? I think it's an open question for now. And the truth is that I think it's a really difficult problem, but we should not be scared at difficult problems. You know, like we can, if we think it's a thing worth doing, let's just try to do it.
I would actually like to challenge this because as much as the idea is good and it would help a lot of developers or some areas of the business, I think as an end user, I might not want to know all those things because I want a quick answer, a seamless experience. And then if someone bombards me with a lot more information that I ask for, I might just feel overwhelmed.
Yeah, like I totally agree. I think we have to differentiate like end user products from how the system works. So you can store that information, for your own analysis later on. That doesn't mean that you have to present it to the user.
This is actually a question that Andrea proposed. How do you think AI is going to influence, in the long run, other industries?
It's very interesting because yesterday I was talking to Juan-Luis about the impact of AI in general, and I think there are different angles to look at it. On one hand, I think it will become a commodity. Nowadays, we look at it, oh, there is this new feature that has AI, but we ignore that online stores, for example, they have been using AI for a long time. We benefit from it, and we don't even realize nowadays that, oh, it uses AI. I think it's going to happen similarly with a lot of other industries. At the same time, there are going to be capabilities or aspects that it's very hard to predict how are going to change. And it requires also us to adapt quickly to all those changes.
So I'm firmly Team Star Trek, which is very positive about AI. And I think speaking for developing software, I feel very positive and optimistic that it's going to supercharge basically the ability to get something of an idea in your head to an actual website or an application or something. Which is awesome because how many people do you know where they're like, I have this great app idea and I need you to code it for me. Them having that person to be able to just develop their idea themselves without necessarily knowing C++, freeing pointers, etc. I think is a huge benefit. And so I'm hoping that it basically opens the world of development to a lot of people who might not have been able to step into that before.
I think I can give an example, a recent example we learned at PenPod, exactly around that topic. For a year, a company had been developing a PenPod fork, a vertical. PenPod is a design tool, and they had been building an e-commerce website builder on top of PenPod. They didn't know Clojure, which is the language that we use at PenPod, but they didn't care. They just used ChatGPT, and they learned Clojure. They created the fork. And they now have a business on top of a PenPod fork using ChatGPT-powered Clojure development. What? We always thought PenPod as a platform would come next year, but so soon, that was amazing. And at the same time, I want to say that this is a beginning. These diffusion models and LLMs are not just the whole of AI. In my opinion, this is a low-hanging fruit. This is like the initial steps. There are many, many challenges out there that where diffusion models or LLMs are not equipped. Okay, and so we have to see more of these kind of revolutions or changes at scale, which is what all of this is about, right? It's the scale that really scares with other models. So AI didn't begin with diffusion models and LLMs, won't end with this. So we have to keep thinking. Okay, this is just longer hanging fruit. The future is yet to come.
And one thing I'm somewhat concerned in the future is that being treated by a human is going to become a luxury. So if we think, for example, of healthcare, I think there's a very clear incentive for especially public healthcare systems, right, to replace parts of their system with AI, like chatbots that reply to you when you're sick or you feel unwell and so on. And I think we're going to create two tiers, right? One that is answered by a chatbot, which is basically for free. And then if you pay a surplus, then you can get treated by an actual human. And I'm not sure what the consequences of that are going to be, but I think it's a very clear direction we're getting.
I would like to follow up on this because I think we have to bear in mind that AI is not going to be adopted across all industries, all geographies, all cultures at the same time. And whereas some companies or some people are more open to AI, some others are not. And in the long run, we will see this also when we analyze the adoption of AI. There are cultures that are just more engaged with other human beings, so likely they will not want to talk to robots in a hospital. But maybe there are others that they don't mind, and that's fine as well. We don't have to push at the same time everywhere just because it's there and it's possible.
I think this is a big topic, but I mean, maybe to start with, in terms of designers or artists, their work is going to change. How can we ensure that the benefits of AI are felt by the largest majority of people rather than perhaps benefiting just a few?
For sure. So I agree. AI, you can see an immediate impact to art with Stable Diffusion or to music. And I actually really agree with Billy Corgan's opinion, who's the front singer for Smashing Pumpkins. He did an interview where he said that AI is really exciting for him as a musician because he described his way of making music was analog, which was him in his basement with a guitar figuring out 10,000 riffs over 15 years. And now with AI, he would be able to see those riffs immediately. And he said that his form of creation was discernment, right? He's choosing his vision in his head of what the song should sound like, and he's discerning over what it is. And it just so happened that the AI created the riffs for him to discern, or he created them himself with his guitar, was a detail, like an implementation detail to him. So I think it will change, and people are going to have different experiences. But I think that there is an opportunity of, hey, you'd be able to see so much more. People would be able to create so much more, even though it might be an AI creating it initially. It's a human discerning it and pulling it together to get their vision at the end of the day.
I think this is a bit of a short-sighted view, to be honest. In the future, like, everybody can, in 5 minutes, create a Smashing Pumpkins song, which is based on the awesome work of some real artists, right? Which has the effect. And by the way, there's not only music, this is like emails, concept marketing, websites, applications, everything, right? Which lead to a flood of content based on the work of humans, right? Which then will lead to an effect that no one really has time to listen to all these songs and visit all these websites and reading all these PDFs anymore, because it's just too much. And then you need like AI again to summarize it for you, right? to select the good songs from all the billion songs that are published every second, right? And then we have a situation where the whole question about bias is so huge, because then we live in a world where machines that are completely intransparent, like these proprietary AI systems, deciding what we consume and how it looks like. Then we have this gigantic filter above our whole life, which is done by proprietary systems controlled by big companies where we have no idea how they decide what goes into my life.
Craig's example is one of those where you could replace AI with just technology, I guess, right? I think this, for designers and in general, for anyone looking at this, behind the scenes, there's this tension between commoditizing and empowering. And I think designers are looking at that with concern. Am I going to be commoditized more than I'm going to be empowered? And when you have this massive ability to level up the playing field for everyone, it's hard to not go with that because, okay, perhaps you will get commoditized, your work as a designer or an artist, or even as a developer, but other people can then now become a developer because they can, the onboarding process is so much easier. So that is the tension always, commoditization versus empowering. And it is a very personal perspective. The tension is out there, but what is your angle? And so, yeah, we see that at Penpot because we are a designer tool. And the way we see this, the kind of the solution is, please, we need developers. I'm a developer myself. We need developers to not just by the strength of numbers, take over the designer world. Just because it's so great to automate everything, to scale up everything, to no, this is much more complex to just very quickly solving the problem of design because I can do it in no time. So I think that is a very tangible tension that we feel, when you're doing an open source design tool. How can we have both designers and developers working together as allies and not commoditizing each other?
And on top of what you already said, I think it's really important to insist on the concept of consent. There was this assumption that because something was available on the internet, someone could take it and make it part of a huge data set, right? And I think nobody was ready for that. Like when I was, writing tutorials online or uploading my drawings, I was not thinking that someday I would be part of a training body of an AI, So there has been some mechanisms in place now for artists, for example, to remove their artwork from training data sets. But first, from what I've heard, I think it's a nightmare. And second, it's not really that effective, right? In a sense, like the harm is already done. So I think we have to think about these things up front. Like, do I consent for my work to be part of this training corpus? And then, this might seem like a silly thing, but I think it was this week that Scarlett Johansson is suing some company because they trained a model with her voice and face, and they made an advertisement with her and without her consent, And I think all of this is rooted in the idea that, sure, because it's there, you can take it and just use it, And I think it's really important that we insist a lot on that, not because something is there online, I can, watch 3 or 4 videos of myself even, and then start pretending that Juan Lu says things that he's not supposed to be saying.
But I think this goes into a broader topic about education about AI, and it is how do we educate developers to use and to build projects using AI that care about all of these concerns, but also users or even early enthusiasts who are just, building their own data set or take a random data set from the internet without even checking what's behind it. Is it allowed or not? Should you do it or not? And it really goes into a need that definitely we have to educate more on AI, not just to think, oh, I can build this cool project, but rather what's the impact, what are the consequences, what are the rights that any data source or model has.
Can I just, on the consent, open source developers understand consent because it's every day they're just consenting several rights to other people. So they are familiar with this idea of consent. I think other people, perhaps designers, just because of their background, are not so familiar with consent. And I think open source and open licenses, perhaps not the ones that we have right now, but other, like going back to the social contract, should make designers, want to consent. Like, yeah, I'll give you my work because I know this whole game theory is actually good for everyone. Like, this is a win-win. I'm not giving this away for nothing. I'm giving it for a greater good. Then I do it, but I know the rules. So particularly open source and open licenses are well equipped to think of a new consent mode for people that are not developers. So that's an opportunity there.
I agree. And I think there's also a lot of interesting parallels we can draw to analog, where there's a lot of solutions for some of these problems. For example, ChatGPT and other text generation AIs, you can ask it things, but you're not necessarily sure where the answer came from, or image generation, you're not sure where that came from. And there's been steps in that space for people to do footnotes, right? Like when you read a book and they make an outrageous claim, they'll footnote it, so you know you can check the source. And I think we're stepping more towards that direction of, hey, what tools can we build into this so that people actually have the confidence in this, they can understand where it came from, what safety and responsible mechanisms can we build into AI. And there's a lot of parallels to analog existing mechanisms for that. Exactly to your point, Frank, of there's a lot of scary things that could happen. I think I feel a bit better personally on it of, we've seen a lot of these problems before of artists, taking other people's work, or someone making outrageous claims in a book for false information, et cetera. How do we protect against that? I think that there's methods we can use that we can apply to AI.
Yeah, I think there's just a different level. I mean, sure, you can say, yeah, this all existed before, it was fine, so it will be fine again. I'm not really sure. With the example with Scarlett Johansson, right, you could make the point that Photoshop existed before, sure. This was possible before AI with just Photoshop, but the work that's needed is just on different dimension. Now everybody can do it, which means it will happen like 1 billion times all the time. And I think the scale of it really makes a difference. You cannot really say, oh, it's just the same as a book. It's just the scale is completely different.
I will ask a more positive question in a second, but listening to what you're all talking about, I was thinking that maybe, especially when there's a generational shift, young people today are quite happy to share their location on Snapchat with all their friends. Gmail has been scanning our emails for decades. Have we desensitized almost a generation to your data being taken and being used for models? And how is there a way, as an open source community, we can counteract that without putting ourselves at a severe disadvantage in terms of progress? And then I'll ask a more positive question.
Yes.
I agree as well. I think that there's, there's scary ramifications of that. Of your example of, you have videos of yourself online, and so do I. People can take those videos and they can make 3D, an AI video of you doing something else, right? Like an artificial video of you. That's not something I necessarily intended or thought about or even knew would happen when I put videos of myself online. And so I think there are, the data that we've put out online is going to be used in unintended ways. And so I think that is a real concern.
Yeah, like 100% with you, Craig. And on top of what you already said, I don't think we're desensitized. It's just that we're very ignorant of what are the consequences of like sharing our data online and so on. I like to say that, some people say that some social networks where you're anonymous are very dangerous because anonymous people do crazy shit, right? And I don't think that's actually true. It's like, in general, lack of consequences that make people do crazy shit. If you frequent LinkedIn, for example, where people put the full name and where they work on and so on, people say all sorts of crazy things online for everybody to see, and they don't care, and they're not anonymous at all. So I think, in general, it's not a matter of people young or old. It's just that there's this super open feedback loop in which we're sharing things online for a very long time, and we have no idea how this is going to come against us, basically, because technology moves much faster than our own intuitions about all these things.
I don't think our brains have evolved to cope with this, to be honest. I think we are in this point in evolution where it's just too much, So we need to be enhanced to deal with the enhanced world. And probably the key ingredient is to have a positive correlation. All this has to have a positive correlation with critical thinking. If you achieve that, then, okay, transhumanism, okay, a positive transhumanism. Typically, it's not positive, I know, transhumanism, it doesn't look like, but you can think of today as a bit of a transhumanism, right? Not posthumanism, but at least trans. And I think we have to be aware that probably in the next couple of decades, everyone's going to understand that just our brain is just not enough. The consequences, the prediction of what is going on, the amount of data that I have to analyze, inform decisions for every aspect of my life. It's just an enormous amount of energy are required to be disciplined, to just always think and probably overthink things. So I really want cyber implants pretty soon, open source cyber implants, of course, to give me that boost so that I can keep applying my critical thinking to whatever is coming.
I think we have this already. I think it's called a smartphone. Smartphone is an interesting device, right? It's like glued to our hand, first of all. It's basically implanted, I think, nowadays. Second is, this is a device that controls our access to all information. So on LinkedIn, for example, we don't read all messages. We read the messages that the nice app on our phone shows us, which is decided by some magical AI system running somewhere else who knows how it works. Gmail is not showing us all mails. There's a spam folder and there's a priority inbox. Another awesome AI system deciding what I'm reading and what I'm not reading, and so on and so on. And I think we already live in this world, and I'm actually quite scared of it, because this is not transparent what's going on there.
Sorry, I've spoken too much, but if I may add like one positive thing on top of what you're saying, I think, I don't think any of these systems were created with an evil purpose, like all of these magical decision taking on behalf of the users and so on were born as a way to make our lives easier in the first place, right? So I will show you only a filter of your LinkedIn posts so that you can see what's more interesting to you, or that you can spend more time here and give me more money for advertisement, right? But the fact that they were not born with an evil purpose in the first place doesn't mean that they don't have evil consequences, So I think we have to balance all this time, like we're putting this system in place to make our lives easier. What other consequences does it have?
I think it's a balance there. Whereas it makes our lives easier, it also can challenge us to be more disciplined, to go the extra mile for what we actually need, and maybe educate ourselves on how do we use technology in general. It's very easy to look at the negatives or at the positives only, but at the end of the day, they both exist, and they always did with any other innovation. You can use cars to go from point A to point B, or you can use cars to, I don't know, hit someone while they're crossing the street. It doesn't mean that we don't use cars anymore. It means that we are more cautious on how to use cars.
There's a fantastic book called Weapons of Math Destruction, which talks about exactly that. We use mathematics in a lot of those ways of, for example, BMI is a great general tool of determining a population's health as what it was designed for. It falls apart when applied to one human specifically. And so I agree more than ever, the weapons of math destruction and how that applies to AI is becoming more and more apparent.
We actually only have a few minutes left, and I thought it'd be good to end on something that's hopefully a bit more positive. I mean, considering the rate of change in something like Mid-Journey output over the last couple of years, would anybody be willing to make a guess of what the state of MI or ML might look like in 5 or 10 years?
I think this is very difficult because 5 years ago, I don't think any of us could have thought of a ChatGPT that gets 1 million or 1 billion users in less than a week. I think it's similar now. We can assume things or we can think of things. Yes, I think there are going to be more regulations on the market. I think it's going to be in more industries adopted and so on. But how it's going to look like, I think it depends on what do we decide to focus on in the short term, on the positives or on the negatives.
I will answer to a slightly different question, and I'm going to say how I would like for it to look like in 5, 10 years. There's a beautiful theater play in Spanish that has an anarchist character that says that the machines are going to do all the work and we don't have to work anymore, right? And this was written at the beginning of the 20th century. 100 years on, there's more and more technology and more automation, and I keep working extra hours every single day, So something is slightly off, and I think, I'm a super privileged person to be doing what I'm doing, and lots of other people don't have as much luck as I do have. So in the future, I would love to fulfill this dream of the machines doing the boring things for us, and then we do the art, not ChatGPT and not Stable Diffusion, but we get to do the drawings and the artistic things and so on, and we have a lot of leisure time. So that's how I would like it to be.
I think software development is an art as well.
That sounds like kind of a modern slavery to me. I think I sometimes feel like it's 1996 and we're getting asked, what do you think internet is going to do with the world? And it's like, depending on the company you're in, like you have different bets. I think it's going to be a function of what it gets prioritized, you know, what the privileged people prioritize really, and how accessible the whole set of resources is. You know, how compute power, software, whatever, how accessible that is, so that we can have a balanced environment. And my take, is not going to change much. We're going to have the same status quo. I don't see, like in 5 years, I don't see like massive changes in the sense that we'll continue to have this arms race, but averaging out, everything averaging out, it's going to be pretty similar as to what it is today, which is bad.
So I think it's a really interesting year. I mean, most of us, I think, we read the article beginning of the year from this tech journalist from the US who had this story chatting with ChatGPT, and then ChatGPT fell in love with him, right? And really acted not like just some assistant that's writing a nice email, but like a person, which immediately got super scary for everybody, obviously. Then the reaction of the tech giants was they basically limited the power from these AI systems by now by limiting the number of prompts that can be referenced on top of each other, basically artificially limiting the sort of the memory of the systems, so that cannot happen anymore. And this is then the state was the state for the last few months. But this is an artificial limitation, so these systems are already a lot more scary than we see them at the moment. And I think this will be unlocked at some point again by the companies themselves or by some others, where you really have a like chat system that are really basically no longer like distinguishable from humans, right? Passing the Turing test. And then imagine just applying some other technologies that already exist, maybe putting text to speech and speech to text to it, that you can really talk with this chatbot, which has these emotions, and then maybe adding a screen to it, which has a face. This moves the mouse, same as the voice comes out. And then imagine someone puts this on top of a robot that's rolling around or walking around your home. And I find it actually quite fascinating that this didn't happen yet, because this is like super possible today. And the reason for that is that I think these tech giants, they realize that the outcry, that the regulations will be insane once everybody will see how this actually could work, right? And I think that the tech industry is at the moment like in a waiting state, where they're trying to actually slow down the process artificially because they're afraid of regulation. And I think this will in one way or another, this will happen the next few years.
I can see where you're going with that, and I think the answer will probably be giving those things a 4-year lifespan. I think, do you want to say something, Greg?
Oh yeah, I was going to say, for mine, I'd actually venture a guess in the next few years, I think the biggest impact will be the level of access to information. ChatGPT, kind of change the game for AI for a lot of people because of how quickly and creatively it could give info. It can pass, like the LSAT and the MSAT and other tests. I think refining how the safety around what information it can give, because it can also create fictional answers. But we're already seeing it with things like creating that project that you described, where those people did not know that language, but they quickly utilized an expert. That expert happened to be AI instead of a person to create something. I think that's probably the most exciting thing of you would be able to get access to these experts. Like what could you do as a person if you had access to an expert on C++? What language, what projects could you create? I think that's probably the most exciting and where I hope to see AI go in the next couple of years.
Thank you. I feel like with all the things that we've discussed, we've barely scratched the surface, and we could almost have sessions in each of those questions. But thank you very much for the time, and thank you for everyone for coming.
Thank you, everyone. The next talk in this room will be in about 5 minutes. And of course, others are starting the same time in other rooms. Quick note, if you are giving a lightning talk at the end of the day, could you please try to be up here in this corner of the room 10 to 15 minutes before 5. Thanks. Yeah, that's good. Thank you. We're just about to start, so if you could take a seat.
I have to put this in the wardrobe, but we might come back to this talk.
All right, let's welcome everyone. Aparna and Chris from OpenSearch, who are going to talk to us about the importance of measuring trust and especially what community contributes to that.
Hello, everyone. Hopefully you can hear me here. Hopefully you're having a great conference so far. Thank you to Ubuntu, our host here, for a spectacular session so far. And special thanks for having us here on stage for what we're going to present today. So consider this. You have a large open source project on one end that is sponsored by a large corporation. So the big question here that we're trying to look at is, in such a situation, how does the community view the open source project? Do they trust the project? Do they not trust the project? If they do trust the project, what are underlying reasons for them trusting the project? And if they don't trust the project, what can we do to better understand what are their concerns? This is exactly what we are going to kind of explore in this particular talk. We're also going to look at best practices, recommendations, and what we can do as open source projects that will serve everyone. My name is Aparna Sundar. I am a researcher in OpenSearch project, and this is my colleague, Chris Frieden.
Thank you, Aparna. As she said, my name is Chris Frieden. I'm the community manager for the OpenSearch project. We're both employed by AWS. We're not speaking on their behalf, and our opinions expressed today are our own. Today's agenda, we're going to be going through some trust in open source, discussing that in length due to a survey that Aparna had put together. Some recommendations to enhance that community trust and keep building trust with your community. Metrics and findings that Aparna found during this quarterly survey. I find them fascinating as a community manager myself, so I believe everyone else will. Ways to foster trust that we embrace, both at Amazon and with the OpenSearch project, as well as some practical things that I take on as a community manager, and maybe some recommendations you could take back to your own communities. First, a little bit about the OpenSearch project. OpenSearch is a community-driven, Apache 2.0 licensed, open source search and analytics suite. You can use it to ingest, search, visualize, and analyze your data. As of October of this year, there were over 1,000 different individual contributors. We have 200 maintainers, more than 200 maintainers across 17 different organizations. So it's growing. It's kind of a really fun thing to watch grow. So we have over 3,000 members in our community forum. And then as of April this year, we launched a Slack that already has over 1,400 members. So it's growing quickly, and that's been pretty fun so far.
All right, let's go ahead and start off with trust in open source. What are we talking about when we're thinking about trust in open source? If you do a quick scan of the internet, this is an example of what you'll see. You'll see a lot of blogs that are out there that are talking about reasons to not trust open source software. And if you do a quick scan of that, we see certain themes that start to emerge. You'll see some of the challenges of trusting free software. If it's free, is it going to be of good quality? You'll see a lot of vulnerability warnings that people will give, saying, hey, it's free software, anything can change at any time. Is this something you really want to trust? There's also a lack of legal obligations that they'll warn you about, in the sense that, anytime licenses can change, so you want to watch out for that as well. Other things that you will get cautionary notes are on lack of security expertise. Open source software may not have the security that your software, that you're proprietarily building may require. So that's another problem as well. There could be an excess focus on features and functionalities. Open source software does not have good user experience. People will not be able to use it. You'll have usability problems. You'll have problems building what you need, and there's no backing. So these are common themes we tend to see. So here we're wondering about how can we ameliorate some of these concerns of trusting open source software. Chris is first going to share some of his insights on what we do in the open source project, and then I will share some best practices as well.
Thank you, Aparna. A few things that I've found help build trust in an open source environment, especially for the open search project, that have worked for us. Openness. I know it goes without saying, right? But we're open source. Be open as possible. One of the things that we started hearing feedback on was you're having your development meetings behind closed doors. So we've cracked those open. Corporations can find that a challenge at first, whether proprietary software is used to having these closed door sessions where open source is not. You need to break those out into the open. One of the nice things for us was the security team went first. So I was kind of tickled by that, because I now can use that and go, look, security team did it. You can too. We had a nice feedback from our security development manager, where he said, I think it was his second meeting, he said, Chris, one of the community members, we were triaging something, they wanted it assigned to them, and they're doing a great job of working on this issue for us, or with us, sorry. Invite others. You want to make it as accessible as possible and enable people where you're able to enable them. You can take further actions of building out things where you can invite another member of your community to be a moderator on your forum, something I'm going through right now with one of our incredible community members. As I mentioned earlier, we have maintainers from over 17 different organizations. You enable others, and that builds this trust between organizations. You can have them come in and lead meetings. You can have them maybe even come in and do your releases for the project.
All right, so these are some of the recommendations from our Open Search community manager. Other organizations, trusted organizations that have done research over a course of time with other open source projects do have some recommendations as well, in terms of, they don't call it boosting trust, they do call it boosting confidence in open source software. Some of these are creating effective and kind of the impact of enterprise with open source development. So essentially kind of get that enterprise behind you, boost the scale of it, hire and develop from the project's community, thereby fostering some kind of ownership, allocating time for upstream contribution, so increasing the scope, increasing the span of your open source software, setting up a mentorship program, once again, the importance of community there, and then implementing inner sourcing practices as well. So what we did was, around a year ago, some of the focus of Open Source Project was to increase awareness. Over the course of time, Chris and I, we go to a lot of these, we go to a lot of conferences, we talk to a lot of people, and the whole marketing team as well at OpenSearch. And over time, we started realizing that one of the topics that kept coming up with our community members was this concept of trust. So now, where do we start? We need some metrics to go off of, because we can't assume they don't trust us, or we can't assume they do trust us. So which is why we went ahead and started collecting some data. At Open Search Project, we run a survey every quarter. The survey spans a whole host of feedback we get from our community members. It's scaled feedback, so apart from the GitHub, we do this, but these are inference-based, these are opinion-based, that we'll get it in. We get feedback on the experience. We get feedback on functions and features and functionalities we need to enhance. We get feedback in terms of perception of open source, as well. So this Q3, we said, all right, we're going to focus on trust because we want to get a baseline of what is it we're measuring. So we don't have a trust in open source software metric anywhere. So what we did was we adopted Katie Payne's trust in organization metric. That was a nice metric to take into consideration because it has 6 of these factors, so 6 of these dimensions. It focuses on dependability, control mutuality, commitment, satisfaction, communal relationships, and exchange relationships. 4 of these items focus on this interpersonal, the social quality that open source projects do have. Dependability and satisfaction is talking directly to us, at least we worded it so it talks directly to the software. For those of us interested in that particular measure, we're going to actually write a blog right after this, after this session here, and we're going to put up some details of this for anyone who's interested to actually look it up. But essentially, for example, if you look at dependability, it has a 4-item measure, right? So the 4, 3, 5, 5, those are the number of items that are there in the actual metric. And then the alpha number that's there is the reliability. Essentially, do those 4 items actually measure a construct? So for example, we had 4 items in dependability. Are they measuring that construct of dependability? So alpha equals to 0.89 indicates that there is a high reliability. We want our reliability score to be between 0.9 and 0.7. So 0.7 and 0.9. Anything below that, you're looking at a lot of variation. You don't know if you're actually measuring the right thing here. So our lowest here, I believe, is that communal relationship, but it's also because it's just a 2-item measure, so it has a high variation. But in general, those measures are off the scores we measured in our survey. So just setting this up as this is our key indicator of perceptions of trust in OpenSearch. So we ran the study in terms of data collection. This was over Q3. We hosted the link on opensearch.org. Recruitment was done on the website. Chris does community meetings twice a month, and so one of those meetings, I think a couple of times, we've gone on, talked to our community members, invited them to participate in this. We also send out partner newsletters, so we've kind of invited them to take part in this as well. And all in all, we got around 36 community members who participated in this particular study. So I'm going to quickly go into our findings. Before we go into our actual findings, in aggregate, let's take a look at who are these individuals who responded. We do anonymize all the detail. We report in aggregate, but this kind of is useful in terms of understanding or contextualizing the result. So first thing that's important to note in our sample is that over 90%, 91.7% were self-service. This is great because OpenSearch can be done self-service, or you can have a managed services that kind of takes over with that. Of the 11% who said that they use a managed service, they quoted AWS, Avon, Logs, Ivy, all those as their particular managed services provider. But the key kind of takeaway there is 91% are self-serve. This means they are the actual developer installing OpenSearch and working with it. So that's a good metric for us to look at. The other metric was, we always captured this role metric. We started capturing that in Q1 of 2023. Most of our users actually go through the full journey of OpenSearch. However, there is that end user, which is a low-code user that also uses OpenSearch, or they could be users who go through the entire spectrum. So, and there is a blog on this on opensearch.org that you can look up in terms of how we're thinking about these individual roles. These roles are domain-specific, so they're helpful in terms of prioritizing the amount of UX and UI that these users will require, or how much of assistance. So for example, if you put in like an AI, or you put in any kind of like natural language query and things like that, users or consumers and producers will kind of make use of that a lot more. Infra users can kind of engineer it themselves. They're doing, so there's just different kind of behaviors and domain expertise as well. So that's important to kind of capture in our sample as well. And the fact that we had 66% of them also supports the fact that these are self-serve developers who are installing things themselves, very technically savvy kind of sample that we're getting here. So that's great. The last thing here in terms of the actual sample itself was in terms of what you use OpenSearch for. How many of you here are familiar with OpenSearch? Just raise of hands or have used it. Okay, so quite a few of you, that's good. So OpenSearch is, you set up your query engines, you set up your search here. What we found here in this particular sample is we had 63%, over 2/3 of our sample are using it for log analytics or security analytics. Music to our ears, because they can't do that unless they set up OpenSearch for a query mechanism. So that's great, but they're not using it for search. That's fine, it's just indicative of the sample, that they are an evolved sample that is looking at or taking this particular study. Okay, other information about our sample, there are other questions we asked in the survey in terms of how do you use OpenSearch, plugins you use, who's your end users, versions. We also asked a lot of questions about our community meetings. All this will be on the blog. I don't want to go into it in detail today. One note is we did have our NPS score. We captured that with every quarterly survey, which is a net promoter score, was at 64, which is the highest it's ever been in comparison to Q1 and Q2. There are some reasons for that. Q1, which had 57.8 as the closest comparison here, we're actually doing very positive. Our developers really like OpenSearch as a software, which is great. Our results in Q2 had a little twist, and that's going to be on the blog as well. We did have a little bit of a sample mix in that, which is why we had a little dip that particular year. All right. Company size, around a quarter of them belong to large enterprise, and so that's also positive for us because if they're all just self-serve, making solutions for themselves, that's a different context. We did have 25% of the sample that are setting it up for large enterprise. They have a large operation. That's good for us as well. All right, with that sample, context, some of our findings. Keep in mind, this is our benchmark of this trust evaluation. Let's just go with the top one, which is the average was 7.4 on a 10-point scale. So 1 to 10, your average is a 5.5. We're looking at a 7.4 in aggregate average in terms of how much they trust OpenSearch project. That's great. That's a good benchmark. The only thing is we don't have a reference point, but at least it's better than the average, so that's good. Some of the interesting findings are in the deeper factors. If you look at the factors there, one of the things that they rated really highly was dependability. And that's fantastic. They think OpenSearch project is, or OpenSearch's software is quite dependable. That's fantastic for our developers. The other metrics such as control mutuality commitment, communal relationships, and exchange relationships were all similar to the overall average. So we're looking at a 7.4, 7.5 average, still indicative of that overall, they're good. The social relationships, the social ties that they're saying, positive, excellent. One thing we're looking at that's a really big dip is satisfaction. 7.1 on a satisfaction, which is a dip from that mean 7.4. So in our original survey, we didn't know what we're going to find because, again, this is the first time we're actually gauging perceptions of our community. We did throw in a question in terms of what they liked about OpenSearch and what they disliked about OpenSearch. So we were trying to contextualize, what about satisfaction took a dip? So we looked at some of our findings in terms of the, in terms of what they said about what they disliked about our particular, about the OpenSearch community itself. This is verbatim what they said. Some of the key themes that you can see here are comments on maintainers, community meeting times, the actual comments on features. There were comments of the origins of OpenSearch, the complexity of OpenSearch, and even some comments on Amazon's investment in OpenSearch. So these are some overall themes we're seeing in terms of why they disliked OpenSearch. On the positive side, on the flip side, we saw that there were some positive comments when we asked them what they did like about OpenSearch. Comments range from observations on the people behind the project, the openness and how inviting OpenSearch was, and positive statements about the fork of OpenSearch itself. And so this is kind of nice to hear this, that they were actually coming out, talking about OpenSearch, its origins, all those kinds of things. So those are all positives there. So this is just a study. What are we doing about these findings in OpenSearch is something that Chris, our community manager, is going to explain to you.
Thank you, Aparna. A few things that we'll talk about next is how fostering trust is really important, both in our experiences with Amazon and especially with the OpenSearch project. One of the things I keep referring to in this is this mindset of trust is Amazon has these leadership principles. One of them is called earn trust. Really, it talks about enabling, treating others with respect, listening to diverse perspectives. You can be vocally self-critical, something I honestly do a little too much maybe. And then you all trust and you're working towards a common goal. Our experience so far is these are taken very seriously. And Amazon and AWS have contributed to over 1,200 different open source projects across the communities. And a little anecdote I kind of like to share is I've got this experience. Most of my career has been in proprietary software, and that's a very closed mindset in a lot of ways for what we talk about in trust. A few months ago, maybe even a year ago, another major cloud provider brought out, I saw a news article that they launched a service based on OpenSearch. And the proprietary mindset is, well, here come the lawyers, right? But in an open source mindset, you look at it and you go, look, that's incredible actually, because you have all these different communities, these different providers, these different corporations, and different people across the community now using it even more widely, which translates almost immediately back to more contributions back into this project. And guess what? That makes it better for everyone. We have an OSPO team to help us with different program management across the organization. And then even an open source strategy and marketing, or as they like to call themselves, awesome. They help us with a lot of different things. Back into the community itself, the project itself, building trust is you document things, like a nice code of conduct. It's not really a rule set. I don't really like to look at it as a rule set, but more of a, how do we enable people to work together, and what are the different ways we respect one another? Build your ladders. Make sure you have a ladder towards a goal, right? One of ours, as I mentioned earlier, 17 different organizations have maintainers. We have a maintainer ladder with a set of responsibilities. That's a way to enable others to go up on that ladder and become a maintainer. And then build a way to onboard into the community. Next, a few practical examples and practical things that I've been lucky enough as a community manager to help foster within the OpenSearch project. 6 different pillars that we'll go into little details about each one. Community meetings. I think Aparna mentioned earlier, we had some feedback from the community that not everyone could attend. So we made this modification. So we have it twice a month. First one's 8 a.m., next one's 3 p.m. So we kind of hit the globe in different ways. That way we can enable different parts of our community to come and take part in those community meetings in person. We also record them so you can come back and interact with what was happening and still interact with the community in that manner. Cracking open these triage meetings, making them public. Come on in and help triage these issues. Some people prefer to do that just through GitHub, through the interactions on GitHub and through the project itself. Sometimes it's beneficial to have these open discussions. So both doing this enables your community to do both. Back to documenting things. Our security team, as I mentioned earlier, they were the first ones to do this. They built this wonderful triaging file out in their repo. Some of the different some of the different repos have their own triaging, and that works for this part of the product. That's okay. Nice way to talk about to build trust with your community is actually talking about them, enabling them, and showing the world what these amazing things are happening and what they're doing with the project. Blog about them, blog with them, enable them to blog, and then talk about them on your social media channels. Forums and Slack. As a community manager, I always default back to this forum, right? We're all very, very familiar with what forums do. One of the things I like mostly about forums is the concept of a networked answer. This thing lasts for a long time. If someone didn't find the answer in a documentation or some of the official pieces, they're going to come into the forum and find that and maybe find this little niche issue that they might have had helped with, and enabling real-time conversations on Slack. Again, back to documenting things. This enables people to know what the ladders are and what the responsibilities are and ways you can interact with one another. I'm a maintainer on the project website, so you also have this ability to build out, we're running out of time, build out how you come in, how you blog, how you add something to our newsletter, how to find an issue on the website maybe. User groups and conferences. Find your tribe, or allow your tribe to find you, right? We have this wonderful individual out in Chicago that's built this wonderful user group, and we just enable them. Come to things like this, and if you're lucky enough, have your own conference. And then lastly, I'll leave you with this. If you're interested in trying OpenSearch, our wonderful friends at Canonical, this team of Michelle, Medhi, Pedro, Mikola, and a bunch of others have built snaps. So go out to the Snap store, give it a try. It's there for you. And then thank you very much. Let's connect.
All right, thank you, Chris and Aparna. We didn't leave any time for questions, but I'm sure they'll be available outside and elsewhere for anything you want to ask. We have a very short break now. In under 5 minutes, we'll start another talk on this stage.
Great, thank you so much.
Thank you.
All right, I'm happy to introduce Igor, who's going to tell us about using Ubuntu and microcates on very serious computers.
Yeah, thank you so much, and welcome to my talk. As announced, I will talk a little bit about how we are using Ubuntu and micro Kubernetes in research facilities like Center for Free Electron Lasers in Germany or San Diego Supercomputer Center in the United States. So, a little bit about me. I have a quite extensive software development background. It's more than 15 years. Within those 15 years, more than 10 years I spent in scientific software development, and within those 10 years, I spent 3 years being a kernel contributor to the open source SCADA framework. And SCADA stands for System Control and Data Acquisition. I will explain a little bit later on. And after those 3 years, I spent 1 year in a steering committee for that framework, deciding on some strategic decisions. And I also find myself being an event-driven system architect and a reactive programming advocate within the scientific development communities. And as photo suggests, I'm really keen to travel, and I try to travel a lot. And I talked a little bit to the people in the hallway and others community groups, and apparently when you start talk about big research facilities, everybody knows Large Hadron Collider, which is great, but I want to bring you the fact that there is a much more facilities than just Large Hadron Collider. So typically, those are huge territories with a lot of buildings. It's called campus, and every research facility has its own feature. This one specifically is located in Hamburg. It's called DESY, so Deutsche Elektronen Synchrotron. It's basically a synchrotron facility. So we have this nice fancy ring highlighted in orange on the photo, and this one is underground, but if you look for other facilities in Europe, so for instance Max4, UESRF, or Solaris, and there's a bunch of them. I know at least a dozen of such facilities across Europe, and also in the United States. You will clearly see the rings there, so it's typically a round building. And in Hamburg we have just a part of that building. It's highlighted in blue on the photography, and then on the schematics we see a part of the ring again, and then this building from the inside. So we have a storage ring, so-called storage ring, where the particles are flying, and then they eventually enter so-called beam lines, and every beam line is ended with a so-called end station. And end stations are marked in orange dots on the schematic presentation, and those dots, if you look inside, typically represented by a really diverse bunch of hardware. So it's called scientific instrument. This is where the actual science happens. So users come with the different samples, different ideas, prepare the send stations, and then shoot the targets with the particles. So, and also these facilities, I would say almost always features also high-performance computing, because all the data gathered from the end stations then goes to the clusters and being processed. How this all happens? If we look inside the storage ring, again, it's this banded tunnel with tons of the hardware. So typically it's some beam position monitors, vacuum pumps, and different motors, so on and so forth. And the SCADA is a piece of software which glues this hardware on one picture with the people on another picture. So it provides a feedback, so how machine performs, or scientific instrument, and again, SCADA stands for System Control and Data Acquisition, so it basically controls the hardware, gets the feedback, acquires the data, and so on and so forth. And these pieces of software can be of different sizes. So the one I contributed in was huge. It's used almost at every research facility in Europe. But as a hobby project, I developed my own flow control system for this custom hardware. A friend of mine, a scientist, asked for such a solution because there were specific requirements. I will cover those requirements in a second. Here we see this hardware disassembled. So normally it's in a crate. So we have controllers, motors, router to connect it to the outside world, and a Raspberry Pi. It's all in a crate, and you can then move it from one beamline to another, and even across the world. So this one specifically traveled to Hamburg, to South Korea, and as I said, there is many different SCADA systems, and at every facility, usually, well, in Europe they tend to use the single one, but across the globe there are multiple SCADA systems, and so the main requirement for that control system was to be able seamlessly integrate it into the host SCADA system. So the idea is that this scientist comes to the facility, installs the hardware, and then we have as little as possible downtime due to integrating it with a host SCADA system. And so how we achieved that? On a Raspberry Pi, I had a Ubuntu server running a micro Kubernetes, and then there is a bunch of software components running on that micro Kubernetes, which are responsible to solving that solution. So, as I said, it's deployed on micro Kubernetes. Here we just see some pods running in micro Kubernetes, and I also put some GUIs screenshots. It also provides a headless API, but yeah, I couldn't find a good way to demonstrate a headless API on a slide. So, summarizing this first case, I find it is very nice that we have this micro Kubernetes, because now I use it as a showcase, not only for this specific solution, sorry, but also demonstrating scientific software developers, like, let's say, best practices of software development in the companies. Because having this micro Kubernetes, it's very easy to do a local development and deployment. It's very easy to start, and you don't need to talk to the real hardware. You can always use digital twins. So you have two fully isolated system on your laptop, and it's very portable. So it's, by the end of the day, it's just a bunch of YAML files. You can give it to other persons and say, hey, here you can install micro Kubernetes or whatever you would like, apply those YAML files, and you will have this system running on your machine almost in no time. So obviously this opens the door to integrate with CI/CD pipelines and apply all these fancy strategies of rollout deployment, canary deployment. It might be not very important for this particular case, but on a general, on a larger scale, when we start to develop something using Kubernetes, this is super useful. And also embraces serverless design. Nowadays, scientific software faces challenges that are far beyond solutions of typical client-server architecture. You need to think more in either event-driven architectures patterns, and the systems becomes much more complex, and serverless design addresses this challenge one way or another. It's easy to share, just as I said, it's a bunch of YAML files or Helm packages. And finally, which I find the most important, it opens a window to integrate third-party open source tools. So for instance, we can integrate with observability tools and have all these very fancy GUIs and dashboards for free, and we can integrate with service meshes and then leverage the security and things like that. So next case, is San Diego Supercomputer Center. This one located in San Diego. San Diego is a city in the United States, south from Los Angeles, almost on the border with Mexico. And then we have this University of California, San Diego campus with this fancy building dedicated to supercomputer center. And inside that building, we have a bunch of very nice hardware. And the unique feature of this place, yes, for me, is that some offices faces the ocean view. That's like on the picture in the right-hand side corner. And what San Diego Supercomputer does for science, so it's obviously a high-performance computing, but apart from that, it's also a cloud provider for scientific projects. And I just want to step a little bit outside of the main storytelling, and just to showcase one of the, I find, very important projects that are hosted at San Diego Supercomputer Center. It's namely a project to analyze and prevent wildfires. So they gather a lot of data, process it, and then try to understand where the wildfires comes, and then notify the firefighters in time so that they can really do some preemptive measures. And I find this very important, and I believe everyone who is living in California for the last 5 years, one way or another, faced this issue. So for instance, I witnessed, not in California, but even in the northern part of the United States, this year I was driving from Yellowstone to Seattle, and the whole Washington state was covered with smoke. I mean, literally, you could see just a few steps away, and the smell is also not very nice. So I believe this is something very important they do. And another project, which is hosted at San Diego Supercomputer Center, and where I was involved, is this RCSB PTB website. It's basically a search engine to proteins. So RCSB stands for Research Collaboration on Structural Biology, and PDB is Protein Data Bank. So this website provides sophisticated search capabilities for biologists to find proteins. So for instance, you can search by chemical components, structure similarities, sequence alignments, and all that kind of fancy thing. And behind the scene, this is quite complex project with a lot of microservices. Here I put some print screen from internal analytics dashboard. I will dive into that a little bit later as well. But here the main message is that it's quite a loaded system. So it serves somewhat 3.5 million requests per day. They are not distributed evenly, so the peak is always working hours. It's distributed on both coasts, so on the West Coast, on the East Coast, and it's hosted by the San Diego Supercomputer Center running Ubuntu servers. So, talking about my role at RCSB, I joined them in a pilot project of migrating from OpenStack to Kubernetes. So, specifically, I was responsible for designing and implementing a Kubernetes platform and also lead the migration process. They wanted to migrate to Kubernetes because nowadays there is a lot of AIs thingy. You know, there's also tons of talks, even at this event, about AIs. And apart from ChatGPT, Midjourney, and other stuff, there are AIs that predict protein structures. And then the goal is to integrate those structures also into the website, so users can see and search not only for the experimentally discovered structures, which is, by the way, only 200K for the history of 50 years, and now it's millions and millions of predicted structures. So this is how like this project looked like. I really love concept maps to do project management, and it's a complex thing, but I specifically want to highlight one technical challenge we had to address during the migration process is preserving elastic infrastructure. And namely, this domain-specific analytics. So this is again that screenshot. So on top we see like a standard metrics from a web application. So it's requests per second, how many requests, how many errors, things like that. And then we have a layer of pie charts and heat maps dedicated to domain-specific analytics. So why this is important? Because it involves money. So this analytics is used to prepare grant proposals and do a fundraising for the next funding cycles. And also preserving the existing solution in which a lot of efforts was invested. It's like 1 year in development efforts for the search analytics engine, and it obviously costs money. So if we would fail to preserve this thing, we probably will need to start from scratch, and that will lead to direct costs of 200K roughly. And so here's a solution. It took a while to come up with it. So the main, so to say, technical difficulty was that previous infrastructure in OpenStack, every microservice was behind a dedicated load balancer. And then we took logs from that load balancer, sent it to some storage, and from there we had a bunch of scripts to ingest those, so extract the domain-specific data and inject those as the documents into the Elastic Index and provide the dashboards by the end of the day. With Kubernetes, the picture is a little bit different because now you have only one load balancer, which is ingress controller, and you can access Kubernetes only from like a single point of entry. And as the end result, what I did is basically I took the micro Kubernetes, reproduced almost a standalone sandbox of our system, and then played with different solutions and pieces. And as the end result, we have ingress controller based on HA proxy to match the previous infrastructure. And then we're using syslog to send those logs line to FluentBit. FluentBit is responsible to split the logs as it was in the previous system. And then basically everything is the same. So this solution is very efficient in terms of migration. And since micro Kubernetes and actual production Kubernetes are quite similar in our case, it was very easy to apply this solution. It's again just a bunch of YAML files. We apply for production Kubernetes, deploy something, see that it works, and we are good to go. So how micro Kubernetes saved us a lot of money and efforts? Again, it was very easy to have a standalone sandbox, and using echo services to mimic the actual services, because we only were interested in the log lines, not the services themselves. We could easily play with different ingress controllers and how to configure them. It also provides the possibility to use standard tools like ksniff to, let's say, listen for traffic between different ports, things like that. And it's also provided a great flexibility in connecting to a non-production Elastic cluster. So there was a very easy way to spin up Elastic cluster outside micro Kubernetes, inside, and then try different things. So the whole thing allowed very fine-grained tuning and efficient problem isolation. So meaning that when something went wrong, it was very easy to narrow down and pinpoint the exact problematic spot and just to fix it. So what's next? Kubernetes becomes de facto a standard solution for deploying applications, even in scientific world. And as for me, micro Kubernetes provides great starting point. So it's easy to start with. It provides a lot of out-of-the-shelf solutions like Helm and different ingress controllers, observability, and all that stuff. I will invest my efforts into advocating it, So the workshops, showcases, and so on and so forth. And apparently there is a now new initiative from IBM called Open Source Science. It's relatively young. And then they specifically want to address features of scientific development, like reinventing the wheel, some gaps in skills, and so on and so forth. For me, it's the most important thing, probably reinventing the wheel. It's somewhat derived from funding sustainability, because it's always grants, so you don't know where you will have money to continue the project you are starting with, and so on and so forth. But apparently these guys are a part of NumFocus, and I saw some stickers in the hallway from NumFocus, so I would really love to talk with those guys who brought those. Yeah, and I'm a little bit faster. So if you're interested, I would really love to continue this conversation and maybe bringing together companies like Canonical and with the scientific software projects. So feel free to connect with my network on LinkedIn. And yeah, basically that's it. Thanks. Any questions?
We still have a few minutes. If anyone wants the mic for a question, just raise your hand.
Hi, great work. I wanted to ask, the deployments that you do with microgates, are they, do you have a lifecycle management tool on top? How do you do the deployments exactly?
Really in production, is it working? Okay. In production, we use micro-Kubernetes only for this first showcase. And for that, yeah, I use standard GitHub Actions to do the stuff.
GitHub Actions for the work?
GitHub Actions as scaffold. So I have a GitHub Action runners with a scaffold script, and then I use the same bunch of scaffold scripts to do it locally and also to the production Raspberry Pi. I mean, it's always like next to you. It's not elsewhere.
Cool.
With the San Diego Supercomputer Center, it was just setting up a micro-Kubernetes. I mean, there was no point to have really pipelines to do stuff. It was mainly for experimenting. So it was like disposable entity, which, okay, I screw everything, I just throw it away and start from scratch with another instance.
Cool, thanks.
Sure.
Anyone else?
Is it possible to say node numbers, something like that? You know, how many nodes?
Yeah, for the first showcase, it's just one node, that specific Raspberry Pi. For San Diego, I played with multiples, but Docker-based, I think.
How about the rough numbers, like 10, 12, 100?
Just 2, 3. Again, this was more on experimenting and research and development side. In production, we have 5 bare metal nodes each coast. So these are really huge machines on each coast, 5 of them. So 10 in total.
Do you have separations with controller nodes and worker nodes? Or, for example, how do you divide 5 nodes?
There is, one typical control plane node, and then I think that like 2, I think it's 2 worker nodes, and then 3 nodes dedicated to storage. So it's runs Ceph and that kind of things.
Thank you.
Sure.
All right. Yeah, we've run out of time for questions, but we have a half hour before the next talk starts here. So, yeah, go out and have some tea and coffee. Thank you, Igor.
of the early sun, when the world was fresh and young, and the summer was nearly done. The nights were short and the days so long. I can see you in this pitch black night, with my eyes closed and I turned out right. On my knees I clutch my pillow tight. I beg forgiveness from the good and right. Oh, crazy, crazy thing that you once said to me. How would you say you love me and then turn your back and walk away? Many's the day we walked alone, you and I chilled to the bone. Life hung heavy in our tortured souls as we battled to gain control. Oh, crazy, crazy things that you once said to me. How would you say you love me and then turn your back and walk away? All about me, it's changing ways. These old ideas have turned to clay. No damnation, no penance to pay. There will be a judgment day. When the final call would come, nowhere to hide, nowhere to run, I'd stand alone, alone with him, saved by faith or damned in sin. A crazy, crazy thing that you once said to me. How would you say you love me and then turn your back and walk away? How would you say you love me and then turn your back and walk away? Darwin, evolution, Big Bang, strength. Those books are around in the classroom now, and they won't go back in no way, no how. You just might be right by me now. I could see the waves were set, no place where we could have met. A twisted knife for an unpaid debt. I never got to express my regret. Darwin,
thought nighttime would make us feel permanent, but then came the sun unexpectedly. In the day standing tall, we got your mother's call. She said she needed you at home, and you just stared at your hand, holding a grain of sand. You let it fall to your feet, then you said dance with me, and I did so willingly. There's lights on the radar screen, keep pulling away. Just stay and dance with me. Darling, how in the hell will we work this out when I need to go but don't wanna leave? I don't know, but I'll turn the car back around if that's what you're asking me. At the edge of the fall, we still don't know it all, what we were setting out to do. But is this how we should end? To leave and come back again without having made it to the sea?
All right, everybody, can I get your attention so that we can give it to Georges to talk about desktop portals? Thank you.
Hello, can you hear me? Yes, I hear myself. Thanks. Today we're going to talk about XCG desktop portals. I must say this has been the most difficult presentation talk that I have ever made in my career, and it's only 20 minutes long. I don't know. It's simultaneously the most exciting technology aspect that I've been dealing with over the past like 10 years or so, but it's also to some degree extremely boring. How do I make this look nice for people? I don't know. This can go very well or very badly. Let's see. So, let's talk about the world. We live in a world where we are slowly shifting the Linux desktop to containerized applications. We are running stuff in containers. Executables are having less and less access to system resources and might have good reasons for us to do that. So you run applications don't have access to, sometimes to your files or to your hardware devices or to your location, because they are in a constrained environment. This is where things are moving right now. So let's imagine for a second, actually, in this room, raise your hand if you know exactly what portals are to the code level. If you know roughly what portals are, raise your hand. Okay, it's about 50-50. If you really don't know anything about portals, is there anyone that doesn't even know about it? Okay, fantastic. Gonna mix and match here. So imagine for a second that you are an application. You're an app, everyone here is a little app. And then the genesis of your life starts. You know, someone goes, I don't know, into GNOME shell and clicks on your icon. And then suddenly you exist. And all that you can see if you're running in a constrained environment, if you're running in a sandbox, is this. Nothing. Now we have a few options, right? Especially for old applications that have never adapted to the changes of time. If you want to make them work, often, you want these apps to have access to your stuff. You want them to open a file, do something to that file, and then save that change. That's an example. You want to, I don't know, open your webcam and take a screenshot, a picture of yourself. or you want to stream something. And to stream, you need access to your camera, to your network, to your everything. So one approach to fix the nothingness, the void of your existence, is poking a hole into this little box that you're inside. So you go there with a screw and punch a hole in there. So you start to see some things, not much. This is an average-sized hole. But then, you want access to USB devices. That's a lot more complicated, isn't it? So you punch a larger hole in your sandbox. This one is bigger, gives you more information about the system that you're running into. Over time, you start adding more holes here and there, like access this folder. I want this app to be able to access my cameras or everything that I have connected in this particular USB port or, my Wi-Fi connections and my passwords. You keep adding holes and holes to your little sandbox until you reach this point where even though you, as an app, you are inside a constrained environment, there are so many holes in this environment that you can imagine, you can form a pretty clear picture of the outside world. There are still black regions in this picture. There's still some area in the box that you're inside, but you punched too many holes, and now we have a problem because if you, not as an app, but as a user, don't want that app to have access to so many resources, maybe you don't trust the app. Maybe you don't trust anyone. You live in a nihilist kind of, I don't trust anybody, I'm paranoid, I want to run away and hide in a forest type of environment. Man, this is really bad. You don't really want to do that. So let's take a step back. Let's go back to the emptiness, the void of the app's existence. Instead of punching holes and breaking the sandbox in fun and exciting ways, what if we give apps some buttons to push? So the app has to, instead of seeing what the outside world looks like, the app just expresses its intention, and something happens somewhere that abides to the app's intention. So the app says, hey, I want to access your monitor. I want to see what you're looking into. I don't know how many monitors you have. I don't have access to your monitors, but I want to see your screen. Or give me an application window picture, something like that. Or maybe the app wants access to a folder. It doesn't matter how. The app doesn't know your file system. The app doesn't know which files and folders you have, but the app tells someone, hey, I want to open a file now. Give me a file, please. I don't care how, just give me a file. So in some sense, you have to break the sandbox without breaking the sandbox. You have to give resources without punching holes in the cardboard of your box. And that's where desktop portals enter the chat, Essentially, you just teleport resources in and out of the sandbox without breaking the cardboard, the walls of your room. A little parenthesis. This sounds like an annoying complication, isn't it? Because now, if you're an app, you have to do a lot more work. You have to not know what you're dealing with. You have to abide. You have to live in darkness, essentially. Why would you do that? Why would an app do that? Why would you want to do that as a user or a developer? It sounds like an annoyance, right? I don't mean to give anyone an answer. I know that maybe perhaps most people here might have an opinion on this subject. If you want to share your opinion later, just hit me out on the hallway, and I'll be happy to hear. But why would anyone bother doing this? Unnecessary complication. Anyway, closing this. So where we are right now, we have the technology. It exists. It exists for the past 7 years, more or less, as an independent project. And really, all there is to it is it is as boring as one could expect. It is just a set of debug interfaces for whatever that means. If you don't understand, don't worry. It is not relevant. We have currently, I think we are on the 27 portal count. We have 27 bits of information that we can teleport inside the sandbox without breaking any constraint. And portals, they have grown over time, over the past few years. Like, they have broken the technological barrier, and in my opinion, they are, right now I think they are, I would say they are reaching the political barrier of the free desktop. Because encoding what a desktop, which buttons a desktop should have, is a political decision, not only a technological one. Because some desktops might, for example, want to expose, I don't know, window management functions. So they might want to expose, like, they might want to give an app a button that says, move another window to another workspace. But some other desktops don't even have the concept of workspace. How do we handle that? Because if an app requests something like that, and the host system, your computer, doesn't even have the concept of what this app is asking, how you're going to do that. That's where we reach the political territory, which is always tricky in free software communities, right? Fortunately, things are growing in a healthy direction right now, I would say. The technology itself exists. It's a bit annoying to use. Lots of debug stuff to deal with. But really, what I think is the most relevant is that for probably the first real time in, 25 years, the desktop has an API. The desktop has common functionality that we can expose to apps in a completely agnostic way. Portals are separated from their implementations. So when you're running in a sandbox, when you're running your app inside a constrained environment, the XDG Desktop Portal service just offers a bunch of buttons for the app to push when it wants to do something. How the desktop is going to react to these actions is up to each desktop. As far as I know, as far as is documented, there are 8 backends. So we have the GTK, GNOME, KDE, WL Roots, XApp, it's a couple more, Pantheon, whatever. It's about 8 documented ones. Probably more. The self-assemblers of their own systems probably write like little Python scripts that implement specific portals in specific ways. I've heard of these rumors. People like this in the community actually exist. I've never met them. So this is a cryptoid information. Take it with a grain of salt. But yeah, I would consider this a successful number, the number of success. It's not only 2 desktops or the 3 main desktops or 4 main desktops. We have a plethora of people implementing common actions in the desktop environments. The Portal project has been recently, like right now, it's in a much better state than it was last month. And last month, it was in a better state than it was last year. We're slowly getting rid of issues. The ratio is pretty good. And merge requests are being merged faster than they're created. That's a good sign, too. We recently just had a release, which marked the branching point where we started new features. Some exciting stuff that I'll be talking about by the end of the talk. if I have time. Oh man, yeah. We have a new website with fancy pixel art. If you're a geeky pixel art enjoyer, you can stare at this for hours like I've done. And we have even a light mode, and it changes the picture. Look at this. Of all of the technological improvements that we've made to the desktop, this is probably the better one. But yeah, back to portals. This is essentially what they are. They are just functions. Functions. That's basically what they are. So you want, I don't know, to create a screencast. You use the screencast portal, call a bunch of functions in that portal, and then you get magically a screencast without actually having access to monitors or raw frame buffers or kernel stuff or whatever. You want access to your location? You have that. Of course, not all of these portals are user visible. Probably most of you won't even notice that some of these portals are being used, like the real-time portal, which doesn't have a UI. You just want something to run faster. It calls into a portal method, and it runs faster. That's basically all there is to it. And there's no better way to embarrass myself than trying to show you how it works, right? Let's try to do that now. There's some fun stuff to try and do here. This is AshPD, a fantastic test playground application for us to test new portals, for us to test existing portals, new features, etc. So I don't know, let's start with a camera one, because I think people like cameras, right? So first of all, my notebook is connected here. It has a camera, so this information is factually correct, which is a great first step for a portal, I think. We can ask for permission to turn on the camera. Without portals, without a constrained environment, this is probably impossible to implement meaningfully. This, hey, actually, do you want to give this app access to your face? For the purposes of demonstration, let's give access to it. Here I am. Hello. So, yes, cameras work. This is fantastic, right? Because I wouldn't be demoing this if it didn't work. What is interesting about this whole thing is that now, if I come to, let's say, let's come to apps. Let's open AshPD. You see that there's a camera rolling here? There's a permission system in place. It's one of the benefits of constraining the environment that applications run is that you can limit access, and then you as a user can control what they're accessing. You control what information apps have. For the purposes of the demo, let's turn this off and try again. Let's see what happens. I hope it fails. It failed. OK, so now we have a way to control who's accessing our camera. Isn't it fantastic? That was not easy before the existence of these portals. Let's do another little experiment here. AshPD, there we go. Let's try to create a screencast. Let's do a simple one. Let's grab a window. Let's allow requests for windows and monitors. We've got this fancy dialog. AshPD, the application, is in a super constrained sandbox environment. It does not know which monitors you actually have, where they are, what they're doing, what their contents. But somehow, it is able to request for that information. Let's share a single window here. Let's share AshPD to AshPD. It is very small here, but I hope you can see that it's working. I can, I don't know, resize it, and the portal notifies about size changes, and it all works as you expect. This is a case where the design of portals chime in, because the act of selecting a monitor is by itself the permission to access a monitor. Because if you don't want an app to have permission, you just cancel the whole operation. The same happens for files, for example. If an app wants to access your files, instead of showing the allow app to access files dialog, we show the actual file chooser, and you can cancel that operation. It's part of the design philosophy of portals. So 2 quick experiments to show that we have a permission system, and it apparently works. And there's a design philosophy behind these things. So what comes next? What is the future of these portals? Currently, there's been ongoing work to enable USB devices. So applications within a sandbox, they can request to access USB devices. This is a big one because it sets the game for other types of devices like gamepads or, I don't know, head-roll devices, whatever other device, subtypes of device you can imagine may come after proving that this concept works with the USB devices. There's been some explorations on an extended reality portal. So applications can request and own display device, DRM devices, so they can show whatever fantastic XR environment in top frame rate you want. There's been some research on peer-to-peer portals as well, peer-to-peer content sharing. So say you're doing live streams and you want to put an avatar on your face instead of showing your direct face, and you want to send this avatar directly to OBS Studio. Right now, you have to create a fake webcam device in the kernel with a kernel module so that you can hand OBS Studio a pretty picture. It's not great. There's been some explorations in this front. People have been redoing the documentation of portals. Hopefully, it's going to be much easier to find, how do I create a new portal? How do I propose this? How do I write the code for new portals? Who do I have to talk to? How do I have to, what's the process and all those things? And also, you as a user, how do I configure portals? How do I change my system to do slightly different things and things like that? Yeah, the permission system is also growing, because right now it's just a simple, usually it's just a simple yes and no, I want to give access to this device or not. But sometimes it might be useful to have a little bit more granularity, you have granted device access to this app 6 months ago. Probably it's a good idea to expire this now, or I don't know, anything like that. And to have more control over these permissions, better permissions, more granularity. That said, I hope I have managed to excite you with dbuzz interfaces. Please join us. We're doing fantastic work. There's been people available doing code reviews and guiding each other. So the community is growing at this point. You can join us. This is the GitHub repository. This is the portals matrix room. Join us. We make some tea, and sometimes we make bread with olives. And sometimes we make portals too. So yeah, the future is bright. I'm happy that I've been talking to you about this. It was the most difficult presentation that I've ever given. Unused assets, this is a beautiful portal. This is a beautiful wormhole portal. This is a beautiful portal too. And I've been made aware that there's a cat lover conspiracy going on in the community. So I'm not letting this go unnoticed. This is a beautiful doga. Let's end here. Thank you. We have 2 minutes for questions.
We have 3 minutes for questions. I'm sure there's more than that, and we can catch George's over lunch, but yeah, raise your hand and I'll chase you down.
So 2 quick questions. First, would it be possible to have the same portals applied for snaps? And also, when you remove the permission for the webcam, it says failed. Why didn't it ask again for permission instead of failing?
First question, yes. Actually, snaps already use the same mechanism. The sandbox, I think, I cannot say much because I don't really know, but the sandbox is created in a different way. But essentially, the filtering and the access to XDG portals behaves like you'd expect from, for example, Flatpaks or I think app images with a bunch of extra commands attached to it somehow. For the second question, you have already given permission to the camera, then you removed it. So it assumes that you don't want that app to have permission. So the camera portal doesn't really, doesn't ask again, because then apps can just keep asking for cameras every single time. There is a way to remove the permission, because it's a tri-state. It's not a dual state. So the first state is unset, which is when we ask. Second state is either yes or no. And that's a final decision encoded in the permission. Of course, it's open to more investigations on how to improve this user experience. We don't have great messages, great rejection modes, great failure modes for these things.
Is there a way to have a permission set only once, like in Android, where you can set the permission just this one time, and then when you open the app next time, it doesn't have the permission again?
Yeah, that would be a portal policy. So I would say one of the new innovations that we have in portals is that we have a way to config which portals are used for which backends are used for these things. So on the GNOME side, I don't think there's been any research on allowing everything or any kind of experience like this. But you can implement something like that. You can write a Python script that just says yes to every single access request, or no to every single access request without even showing you a UI. So if you want to self-assemble something and do some experimentation and shows off, you can do that. And it will be actually highly appreciated.
One question here. I'm an application developer that's not using big toolkits like Qt or JDK because of targeting audio plugins. We don't want to use these big frameworks there. Mm-hmm. My question is there a C-level API that you can expose for all these deep bus complexities? Because having to implement this already in 2 different places is it's very painful.
I know.
So if there's a way to have an official, or even if it's not official, someone making an API that I can use as a C developer.
libportal.
That will be very welcome, yes.
Yes. It is a nicer, much, much nicer API to handle this.
Hi. I think I missed something from the beginning in the sense that you started talking about confined application, but I didn't really get what's the mechanism to confine the application to begin with, the sandboxing. Because otherwise, this sounds mostly like it's opt-in. An application will opt in to be confined and then use the portals. What's actually preventing application from just using a C function like open and just open a file without using the debug methods?
So this enters an area where I cannot explain every single technology to you. I know about Flatpaks. I don't know about snaps. I don't know about AppArmor or any other types of confinement of non-sandbox applications. At least on Flatpak, we use user namespaces. The mechanism is called bubble wrap. So the app is mounted in a user namespace. It is isolated from everything. And then in the manifest file, in the file that you use to build your container application, you can set some holes in the sandbox if you want. That's not what I want people to be doing. The goal here is to have 0 holes and everything happens through portals. But yeah, at least on the Flatpak side of things, we use bubble wrap, and that isolates the process namespace and file system, and etc. like this at the kernel level, I suppose.
All right, we only have 2.5 minutes before Fairphone is on stage, but let's give George's one more applause.
Thank you.
Thank you.
thought nighttime would make us feel permanent, but then came the sun unexpectedly. In the day, standing tall, we got your mother's call. She said she needed you at home, and you just stared at your hand, holding a grain of sand. You let it fall to your feet, then you said dance with me, and I did so willingly. There's lights on a radar screen, keep pulling away. Just stay and dance with me. Darling, how in the hell will we work this out when I need to go but don't wanna leave? I don't know, but I'll turn the car back around if that's what you're asking me. At the edge of the fall, we still don't know it all, what we were setting out to do. But is this how we should end? To leave and come back again without having made it to the sea? Then you said dance with me, I did so willingly.
All right, everyone. Let me introduce Luca from Fairphone, who's going to talk to us about using open source to stop us from throwing our phones away all the time.
Hi. So welcome to my talk, Open Source for Sustainable and Long-Lasting Phones. My name is Luca Weiss. I'm an Android platform engineer at Fairphone. I'm also maintaining a bunch of open source projects, including PostMarketOS, doing some contributions for Linux kernel and OpenRazor. And of course, you can find me on Mastodon. So let's go a bit into what Fairphone is. So Fairphone is a phone manufacturer. We were founded in 2013, kind of as an outcome of an NGO awareness campaign. I will go into this a bit later. Yeah, we do fair electronics. So we have our smartphones, we have some accessories for the smartphones, and also some audio products as of lately. Our head office is in Amsterdam, but we also have some employees in China and in Taiwan. And currently about 140 people are working for us. So, the digital industry. The environmental impacts are not negligible. It's about 4% of the global greenhouse gas emissions, and about 10% of the world's total electricity consumption. And of course, also the digital industry uses a lot of other resources like minerals for production and fresh water, for example, for data centers and production also, of course. And of course, there's social impacts, as we know. So kind of as in greenhouse gas emissions, about 85% of this is actually used for device production. And then 16% is used for example, running the networks in data centers. These numbers are for France, but I guess it's quite similar for a lot of other countries also. Electronic waste, as we I think know, is a really big problem in the world right now. It's the world's fastest growing waste stream, with over 50 million tons per year. And of that, phones are definitely a big component. About 1.5 billion phones are sold every year. Most of them are not kept for long. They're only kept for 2 to 3 years and then recycled, or probably most of them are not recycled. Some of them are kept in drawers, but for most of them, we actually don't know. Informally, lots of millions of people around the world are working informally to work to dispose of electronic waste, to re-get some of the materials. But for most of them, it's quite hazardous working conditions to both their health and also the environment where they're doing it. Yeah, and only 20% of the devices are actually recycled properly. So, what can we do about this? Fairphone itself was started in 2012 as an awareness campaign about conflict minerals, as I said. It was started by Bas van Abel and a few other people. So Bas van Abel was our CEO until I think about 5 years ago. It was a part of the Waag in Amsterdam. It's kind of a tech incubator there. And after a few years of campaigning, they realized it was showing the problems, but it wasn't actually creating any alternatives. So the best way to actually understand it and to influence it was to be part of it. So Fairphone BV was born as a social enterprise with a huge ambition to actually change the electronics industry from the inside out. And here social enterprise means kind of that the financial profitability is just a way to actually achieve a lot of impact in the world. So with no prior experience in the phone industry, a crowdfunding campaign was launched. It was one of the most successful crowdfunding campaigns in the EU for about 10 years. And wasn't done on regular platforms like Kickstarter, but actually on our own website. And so our mission at Fairphone is to establish a viable market for ethical electronics and to motivate the entire industry to act more responsibly. And we were founded really with the purpose of creating a better electronics industry. So let's look a bit at kind of how the timeline of Fairphone was. So as I said, we were founded in 2013. We launched our first phone there. In 2015, we launched the second phone, the first ever modular phone, where you could actually very easily replace parts without actually needing a screwdriver for some of the parts. In 2016, we published an open source Android version that for Fairphone 2 that we maintained. For example, in 2018, we got into a partnership with Orange, so kind of the start of some business relationships with network operators, so you can actually get the phones from operators. Fairphone 3 was launched in 2019. Fairphone 3 Plus was launched a year later, which was kind of the same phone, but with upgraded modules. So even if you had a Fairphone 3, you could just upgrade the camera modules, and then you basically had a Fairphone 3 Plus with better camera quality. Fairphone 4 was launched 2021. This year we launched the FairBuds XL, our headphones, and the Fairphone 5 was launched about 2 months ago. Yeah, and we celebrated our 10-year anniversary earlier this year. So our nice smartphones, as you can see, they're also growing a bit bigger, not too much lately. For example, we can look at Fairphone 2. We actually managed to get software support between 2015 when it launched and earlier this year, 2023. So we got 7 years of software support for this device with 4 major Android version upgrades. It was launched with Android 5 and we had Android 10 in the end. With Fairphone 3, so far we got 3 major upgrades for the device and we are guaranteeing updates until at least 2026. Fairphone 4, also at least 2026, but we're aiming for 2028 to actually support the device. And the Fairphone 5, we're actually managing, or hopefully managing, to at least get software updates until 2031. So 8 years after launch, but we're aiming for 2033, which is 10 years after launch, which is really would be a great milestone to have. As I said, this year we also launched our FairBuds XL, our headphones. I think they're quite nice. But yeah, the Fairphone 5, our slogan is kind of designed for you, made fair. It is designed with care to be fair to you, fair to the people and to the planet. And it's built to last longer, to be able that you use it longer, so it's also better for the planet. So let's go a bit into the first part of our tagline. So 10 years of software support, what we're doing with Fairphone 5. This is mostly enabled through our use of a kind of special chipset. It's an IoT chipset that is actually used in the phone, or a long life chipset. But it's quite similar to other Snapdragon processors in there. So we are getting a lot of support from Qualcomm there. So at least until 2031, we will get updates, hopefully 2033, with probably Android 19 or whatever it will be called by then. Who knows? So you may ask, why do we have so long software support for the device? Because a lot of people are actually changing their phone because of a lack of software support. And of course, also if you don't update the device, I mean, hopefully I don't need to tell you, but yeah, if you don't update the device, no issues can be addressed, no security vulnerabilities that are always discovered can be patched, and of course you also don't get any new features, which may, for example, come with new Android versions. So, for example, there are better permission management, autofill functionality, etc. I hope you know, or I guess you know, that Android itself, or the thing called AUSP, is open source, Android open source project. But what is actually running on the phone in the end is not really just AUSP. There's a lot of other things running on the just on the main CPU here, and a lot of the. So, for example, if we look up here, so the Android apps you can get from the Play Store, they're probably also all proprietary. Except if you go through F-Droid or something. The Android framework, Android API, etc., they are open source, they're part of AUSP. Also the system services in Android runtime is open source, it is part of AUSP. But once we go a bit lower to the HAL and the native daemons and libraries, these are provided by the SoC manufacturer, and they are usually very proprietary, so nobody apart from people with an NDA or a special business relationship with Qualcomm can look at them. And on the bottom, we have the Linux kernel, which is open source because it's GPL licensed. So I was talking about the code that goes into Android itself, but also what's running. So Android itself kind of would go into the main CPU of the device, so kind of, yeah, where Linux is running. Yeah, this is getting code sources from AUSP. For Qualcomm, it goes via a platform called Codelinaro, previously called Code Aurora Forum, CAF. You've probably heard, or you maybe heard of it. Also, some proprietary code that goes in there, but a lot of proprietary code is also needed for for many other parts of the SoC. So, for example, a lot of the coprocessors on the device, for example, for modem, for some audio handling, etc. They're all proprietary, and these are also very much needed to be able to run a phone as you would expect. So now let's have a look at what this means for on Android. Bringing Android to a device is quite a complex process. So any new Android release starts out at AUSP from Google. The version gets released, then the SoC vendor takes the AUSP code, adapts the code to a specific SoC. So writing all the hardware abstraction layer, etc. Once the SoC manufacturer is done, then the device manufacturer gets this. They can integrate their changes into the code. So, for example, for specific touchscreen support or other specific support, or some UI changes that need to be done, including also adding some operator changes on top. Yeah, then the operator requirements need to get tested. And also integrated, and a lot of things need to be adjusted there to actually work properly. And then finally, the Android version or the specific Android build needs to get launch approval by both Google, but also the operators to be able to launch the version. For normal updates, so both security updates and regular maintenance updates. From there, every month, both Google and Qualcomm and some other parties are releasing security patches. These need to be integrated by the device manufacturer, but also, for example, network operators have, for example, updated requirements or new app versions that also need to be integrated. This all needs to come together, and after a security update is ready by the device manufacturer, it still again needs to be approved by both Google and the network operators to be able to launch it. Google maintains any Android version for about 3 years. So then either you need to upgrade to a new device or to a new Android version, or you need to stop support, basically. Hopefully you're also upgrading before the support runs out, so that you get the new Android versions already. But yeah, what happens if this chain is broken? What if the SoC manufacturer doesn't provide compatibility for a new Android version for the device anymore? Well, that's generally where software support in the industry is stopping. Yeah, because the device manufacturers don't get compatibility anymore. So let's look a bit about our wonderful device, Fathom2. Yeah, as I said, it was released in 2015 with Android 5, sorry. In 2016, it got an Android 6 upgrade, and already back then, the SoC went end of life. And this is also where other phones with the same SoC didn't have any support anymore, for example, the Nexus 5. However, still in 2018, we managed to get an Android 7 upgrade out, in 2021, Android 9 upgrade, and in 2022, an Android 10 upgrade. So to understand how we achieved this, we actually need to go a bit, dig a bit deeper. So we kind of took over the role of Qualcomm. So we made the SoC work with the new Android version, so in this case, Android 7. For this, we reused a bunch of the proprietary components from Android 6, but we also looked a lot at other SoCs from Qualcomm that got the new Android version, so just new SoCs. So for example, for the Snapdragon 835, we looked at the code there because it was reasonably similar to the SoC in the Phantom 2. But we also looked a lot at the code from that is in Lineage.js. That's not really just taking entire parts over, but it's also about having a kind of a reference to how the device would be working. From Lineage.js, we also took a bunch of fixes that fix user-facing issues, for example. So maybe some app crashes, or maybe some app doesn't really work the way it should be. Obviously, it's not an ideal solution because the SoC manufacturer probably can do a bit more in-depth development to get it working a bit better. But it worked quite well. And yeah, we managed to do this for the next couple of Android versions also. We do publish a lot of what we do on our website code.fairphone.com. All of our devices also have, for example, an unlockable bootloader. We do publish as much as we can on code.fairphone.com, including build instructions. So for example, for Fairphone 3, our device from 2019, you can actually download the Android source code that is being used for the builds that we ship. And you can actually build it yourself for the most part. There will be some differences. For example, there won't be Google apps included. There won't be Widevine, so the DRM included. But for the most part, it is the same Android source code that we use to build the normal releases. So our phones are easy to repair. But why should it be repairable? Well, if things break on a phone, and they do often break, you don't need to replace the whole phone. If the screen breaks, just can replace the screen. If the camera breaks, just replace the camera. And of course, also batteries, lithium-ion batteries in phones, they're not really made to last forever. Their average, or the supposed lifespan is for about 2 years, and afterwards, the battery performance just degrades. So if you can just replace the battery works very well again. And by not replacing the whole phone, of course, you're preventing a lot of CO2 emissions if you don't replace everything. Because really, a lot of the CO2 equivalents that are emitted during device production, most of it goes into the core modules. That's how we call kind of the main PCB with the main processors and a lot of the main components in there. As you can see, then second is mid-housing, which is already a tiny chunk comparatively. So, for example, if you want to replace the battery, you don't need to replace everything. You can just replace battery, and the rest you can keep because, yeah, it's not broken. And this also means if you, for example, if the display breaks and you replace the display, and instead of buying a new phone and you're keeping your existing phone for about 33 days longer, then you're already kind of compensated for replacing the display. So if you then use it 2 years longer, it is really great. So, circular economy, it's a complicated topic, but I try to make it a bit understandable here. But yeah, there's a lot of priorities in there. Of course, Fairphone mostly looks at kind of the produce and the reuse sections here. So kind of during production, it's kind of refusing. So do you actually need a new phone? Maybe you don't. Rethink, maybe do it a bit differently. Or reducing, just make it less. During reuse also, we can do a lot of repair, so to not have to produce a new phone, but just repair it. We can refurbish it. If there's something a bit more broken with it, we can remanufacture or even repurpose it. And at the end of the life cycle of a device, some parts go to waste, some parts just can't be recycled. But some parts we can recycle again and we can put back into the production cycle. But since we can't recycle everything, we always need to have new raw materials because recycling can't just cover everything that we need. So we also do have schematics published for the FEV 4, FEV 5 hopefully soon. So you can kind of see where all the internal components are connected, including kind of where they are on the boards, on the PCB. It can be quite useful for repair also, and also for software bring up, if you want to do some extra tinkering with your device. All of our the FEV 4 and the FEV 5 are also covered by a 5-year warranty, because we think that that our devices will last that long, and we want you to also keep the devices as long. So if something breaks after 4 years, we still want you to keep the phone for longer, because as we went into getting a new device just causes a lot more CO2 emissions compared to when you just repair it. So let's go a bit more into the made fair section. So we do have a fair, in a phone, there's over 50 materials. And of those, at Fairphone, we selected about 14 focus materials where we think that the biggest impact is, or where we can achieve the biggest impact. It's a lot of work to actually integrate these into the supply chain. But as you can see, for example, for the battery, we have a lot of fair materials in there. So fair lithium, cobalt, gold, silver, tins, and a few less percentage for some other components in there. So for a lot of the components, we are looking to really get a lot of these into our phone. As also, you may ask why we selected these 14 focus materials. We actually published this on our website, in our fair materials sourcing roadmap. And this is an excerpt from it. So there's a lot of different factors that go into why we choose certain materials. So you can see here, it's kind of the demand in the electronics sector, critical for functionality, and the presence in phone. There's one of the sections where it's more or less depending on which material. Also been in the social areas, so kind of the government structures in the where it's mined, social challenges, environmental challenges, and also then kind of how we expect the demand to grow over the next years, depletion, how much of it is still available in the ground, and also how much new material do we need to boost the phone here. So to get fair materials into products is kind of 4 steps that we do: research, engage and trace, build and integrate. And we don't really get to the next step before actually finishing and understanding the previous step. So for example, for research, as I showed in the last slide, kind of we have this fair materials source roadmap where we see where we can actually create positive change for it. We engage with the supply chain, actually map the supply chain, engage with key suppliers, find out where they source the materials from, try to get our, already find out how we could possibly get fair materials into it instead. Build, kind of we need to look how we can, if there's already a supply chain set up, if we need to create a new one, if we can collaborate with some other people in the industry to get this done. We integrate, so we try to kind of connect the 2 different sides. So get the manufacturers to actually integrate the fair materials into the product. There's also a lot of, it's a continuous improvement. We're always looking into kind of where we need to adjust, where we need to do more. So this is kind of a very rough overview of kind of how a mineral ends up in a product. It's a lot of steps and a lot of in-betweens. So kind of, we cannot just rely on the final assembly manufacturer, so the company that actually puts everything together, where we actually order the product from, basically. Because yeah, we can't just rely on them to say, yes, everything's fine, don't worry about it. We actually need to check kind of on each level ourselves to know that it's actually done good. Yeah, so kind of there's a lot of different component manufacturers and different distributors where a lot of components go through. If you go down, the materials go to lots of traders, to smelters and refiners, and through more traders until you're kind of down where the actual mineral is getting dug out of the ground. So we do map the journey of our materials, and we publish this also on our website. Also, kind of, you may ask, why are we doing this? First of all, because we want to scale our fair sources, so we want to get more of these into our products, but also because we want to have followers. We want other companies to look at this, see how we are doing it, and actually follow it and implement it for their own products. Because, yeah, we are just a small phone manufacturer. But if we can get bigger manufacturers to also do the same thing, of course, it will have a lot more positive impact on the world. So for example, here you can see a part of the supply chain for the Fairphone 4. So you can see the different products that are coming from different areas of the world, coming through different the smelters and refiners or some manufacturers, and then kind of finally landing in China at our final assembly manufacturer. So you can see, for example, tungsten is coming from some place in Rwanda in Africa. Then it goes through a smelter, I think, in Austria. And then it goes to a different manufacturer in China, and then finally lands at the final assembly manufacturer, so where the actual phone is put together in the end. We have a very long list of all our suppliers, smelters, and refiners on the website, where you can see which companies are kind of involved there. So we want to be fair to people, of course. So we want the highest standards for good working conditions. We have a living wage program, which I will talk about next. But of course, also in the mines, we want to have, for example, fair trade gold, fair tungsten, or lithium from an IRMA audited mine site, which is the Initiative for Responsible Mining Assurance. We want to, of course, make sure that people there are not being exploited, that they actually get paid decently. For factories, I said, we produce the phones in China. China is the largest producer of smartphones in the world. Of course, also a lot of Chinese brands are producing there, like Huawei, Xiaomi, Meizu, etc. But also a lot of other manufacturers have their phones produced there. One of the reasons is, of course, the workers in the factory have different salary expectations to, for example, in Europe. But also many of the materials that are actually in the product do come from China. So we choose our production partners and component manufacturers and the final assembly manufacturer, not just by the technological requirements, but also look a lot of into the willingness to work on the social and environmental issues, and also the willingness to actually improve the working conditions for the employees in the factories. And this is also important because, for example, there's no unions for factory workers in China. So based on discussions with workers in the factories, we defined the need to work on about 46 improvements. Most of them are in the category of workers and worker satisfaction, but also health and safety and worker representation and living wage are part of this. 2 years ago, we were only looking at 16 improvements. So by now, we over tripled the focus areas for this. I was mentioning living wage a couple of times, but what does this actually mean? The living wage is kind of the amount of money that needs to be earned by a worker without overtime to actually have a decent wage to ensure a good living and working conditions. And the living wage gap, which is here, is kind of the gap between the daily wage, if they would work 8 hours, versus the living wage. So you can see it's actually quite a big gap. A lot of the factory workers are working overtime to actually themselves earn a bit more money to ensure, a good life. At Fairphone, we pay the gap of the living wage for the working hours that are getting spent on Fairphone devices. And actually, this bonus doesn't just get paid to the people on the Fairphone production line. So in normal factories, there's a lot of different production lines for different companies. But based on discussions with the workers there, they actually decided that it's fairer that this bonus gets split across the people, all of the people in the company, because otherwise some workers would be kind of advantaged if they work on the Fairphone production line versus a different production line, even though they're technically doing the same thing. For this, in the end, it's only about $2 per phone, which is really nothing if you think a phone is 500, 600, 700 euros, or even more. If you buy a $2,000 phone, what is $2? And you're, by doing this, you're actually ensuring that the people working in the factory actually have a decent salary. And so we think a lot of different companies should also follow the same approach and actually implement this. Because, kind of what we can pay to the factories is just a small part of what would be if every company in this factory would actually pay this living wage bonus. So our phones are made climate conscious. Lately a lot of companies are always using the term CO2 neutral or whatever. But we also don't want to pretend that a phone could be CO2 neutral, because it can't be, at least not yet. We definitely do try to reduce the footprints during device production, during and everything else. And we do invest in carbon reduction products, because we do think they at least do something. The emissions that we're covering there, so not just CO2, is based on a lifecycle analysis, which is an ISO standard. So for our Fairphones, the Fraunhofer Institute in Germany, they do this analysis for our devices, so we can actually see very detailed kind of where the emissions are and how all of the life cycle is there. We also have this public, and we also think all of the other manufacturers should also publish this life cycle analysis for their devices, because it really gives an insight into kind of what emissions your device is having. Is this your drawer on the right side? I think it is, because in Europe there's about 700 million phones just sitting in drawers doing nothing. This is more than 3 times the annual smartphone sales. And this of course also means these phones are not recycled. They're just sitting around. They're being e-waste. And this is actually a big part of where e-waste is. So of course, every time we sell a phone, also we at Fairphone, we produce future e-waste. But for most of it, we don't actually know where it ends up at. 54% of it, it is not known where it lands. Only 17% is actually formally recycled, and about 28% is either, 8% is going to household bin, which is obviously not recycling, or 20% are illegally exported to places like Africa. Maybe you've heard of a place called Akpo Bloshi, which is next to Accra, the capital of Ghana. There were some documentaries about this place. A lot of either e-waste lands there. A lot of people, mostly teenagers, are working there informally, and for example, burning some cables to actually get the copper out of the cables again. Of course, this is a huge health and environmental hazard, but unfortunately, this is what is happening in the world. So, of course, we do think formal recycling is better. So we've introduced, I think, 1 or 2 years ago, our reuse and recycle program. You can actually get a voucher if you send in your old phone, depending on how well it still works, or how much kind of recycling value could come out of it. You can send any phone, you can send a lot of other phones, not just Fairphone. If you send a Fairphone that you don't use anymore, that's in good condition, it will actually get refurbished, or some spare parts get used for actually getting them back into usage, kind of what I showed before with the circular economy. And of course, this also made it quite a bit easier with the modular design that we have at Fairphone. So you can just replace, or for example, take the camera if it works, refurbish that one maybe, and then we have it. So open source software, as the title says. Of course, we are using a lot of open source software. So how does it help Fairphone? Well, of course, as I said, the base of the software that is running on the phones is open source, so AOSP and the Linux kernel. We also do pick patches, for example, from Lineage.js, what I said, so kind of having a good reference also of how things work. Also, the way Android is being developed, it is sometimes a bit difficult to kind of find one code base which is actually working correctly, because the AOSP, AOSP has a lot of different release tags, and a lot of different manufacturers are just picking patches or maybe not submitting them. So Lineage.js is always working quite well, so it's actually a great reference for this. We do use stable kernel updates, so the LTS kernel from kernel.org, where possible. And for example, also we have some automated testing running using Android Test Station, which is an open source project by Google. So, but of course, we are also contributing to open source software. So yeah, of course, with the GPL license, we publish our kernel sources. We also do have build instructions for those, so you can easily build them. We do publish device resources. This is a bit more tricky in recent years because it is normally part of the proprietary package from Qualcomm, so we were not allowed to publish them, but we got an extra, after a lot of back and forth, we got the permission from Qualcomm to actually publish those also, because it's quite important to have these also available if you want to fix some things or just maintain have the community work on this also if they want. We do a factory package on the support page. Of course, these are not open source, but they are quite helpful for third-party ROMs that are trying to make the software work. We do publish the full Android source trees where possible. So we do have quite a bit differentiation. So for Fairphone 2 and Fairphone 3, they're actually the complete Android source trees which you can build and run on your device. Also lately we've published some source trees for currently Fairphone 4 and Fairphone 5, which are not buildable by a user because it is basically the code that our ODM, so the company that's maintaining the Android software for about the first 2 years of the lifetime, and also doing the initial bring up. But there we still want to publish these sources because they can be quite useful. For example, for Ubuntu Touch, if they want to fix something in the audio hardware, that they can actually look at the code and actually patch it and build it themselves. We do have TWP support for the devices. So, for example, for Fairphone 5, we were able to publish this on day 1 of release. And I'm also working on kind of getting this officially supported on, so you can just go to the twop.me site and download it. We do have EOS on our web shop. EOS is a privacy-focused Android distro where we have a partnership with them. So any end user can actually go to our website and buy it directly from us and get it pre-installed, shipped to their door. Of course, the normal software that we ship with phones is the regular Android software with Google services and everything that kind of a general consumer expects there. But of course, we know that some people don't want Google services, so we're actually trying to make it easier for them to run Android without Google services there. And we're also trying to support where possible third-party developers. So, for example, for Calyx OS or EOD OS or EOS, as I said. So I've been mentioning the Linux kernel a lot. So let's talk about let's talk a bit more about it. Kind of the Linux kernel is developed in upstream as the mainline kernel or upstream kernel on kernel.org. This is kind of what most of you are running on your computers, or at least based on this with some extra patches, for example, from Canonical for Ubuntu. Every year, one of these versions gets selected as LTS version, so long-term support version. Based on this, then Google creates an Android common kernel branch from it. So, for example, an Android 11 5.4 branch, which is 5.4 kernel version, meant for devices launching with Android 11. Then kind of similar to kind of how the Android bring up works, what I covered before, the SoC manufacturer takes this kernel version, builds their SoC support on top of that kernel version, and only then the device manufacturer gets this version and can build their support on top. So this also means by the time a device launches, the kernel version is multiple years old. And since it's never really updated, so the SoC manufacturer normally just provides one kernel version and is doing minor updates to that, but not really rebasing their whole tree on a new LTS version. So your A device is normally stuck with the kernel version that it launches with. So for example, you can see here for our different devices, so 5.3, 5.4, 5.5, they have launched with different kernel versions. So even though it says Linux 4.9 for 5.3, it's actually about 2.5 million lines of code difference to what is actually being released upstream at kernel.org. It's about about 18,000 commits. So you can imagine taking all of these lines of code or these commits and rebasing them on a new Android or a new kernel version is kind of impossible. Yeah, and the kernel version for 5.3 was released in December 2016, but the device was actually only released in 2019, so it was already kind of 3 years old by the time the device was launched. And also the 4.9 kernel version is, in LTS terms on kernel.org, is end of life since January 2023, so we can't pick the patches from kernel.org anymore, and we have to do this ourselves. Also, this is really getting a problem because, for example, this 4.9 kernel, it is supported still by Android 13, even though also at the beginning it was a bit unclear if it was actually supported. But for Android 14, Google is quite explicit that 4.9 kernel version is not supported anymore. So yeah, we are having a kind of a problem getting to Android 14. We are having some ways to maybe still get to Android 14. But yeah, it is becoming a problem for us. Yeah, for our new devices, you can see the lines of code and the commits, they get reduced a bit. But for example, also, yeah, 5.4, the kernel version will be end of life in 1 year. So yeah, if we want to go beyond it, which we want to be, or we want to go, yeah, it will be a bit problematic to some extent. And even 5.5, which launched with kernel version 5.4, we're now at 6.6, so yeah, it is by now kind of 4 years old, and will only be supported for two more years, at least this kernel version. Also, all of these kind of lines of code and commit stats, they are without some external kernel modules, which by later devices is actually quite a lot, so a lot of these tech pack components or Wi-Fi driver, etc. So, yeah, as I showed, kind of staying on old kernel version is not a good idea, because yeah, support will be dropped by AOSP. There is, of course, if you're staying on the same version, there will be no new features or any improvements. And yeah, if maybe there's also questionable if there might be some extra security issues if you stay on a very old kernel version. So, yeah, what's the alternative? Yeah, we can try to push device support upstream into mainline kernel, so we can hopefully easily upgrade the kernel. So it's kind of an R&D project that we have. Sample 5.5, our newest device, it's now about 2 months after launch, and with the kernel version 6.6, so the very newest kernel version, plus about 100 patches only, we get a lot of the functionality already just working. So, of course, yeah, a lot of the basics, serial console, power buttons, volume buttons, regulators, real-time clock, they're all working. USB is working, including Type-C functionality, so you can, for example, plug in a USB keyboard, and it actually gets detected properly. Internal storage and SD card. Display is working, touchscreen, and the GPU is working with the open source free Drano driver, which is in Mesa. DisplayPort over USB-C is working, so you can already plug in your phone to a monitor, and you can use the monitor as a second display for the phone. Wi-Fi and Bluetooth is working, battery and charger state is working, hardware-accelerated video decoding and encoding is working. All of the co-processors are up, so all of these are running signed proprietary firmware, but we can start the processes and actually talk to them, so they do the correct things, for example, the modem or the ADSPs for audio and a few other things. flash and torch LED is working, and the camera I2C bus is working. So we can at least currently talk to the camera sensors via I2C. We can't get any image data yet from it. But of course, a lot of functionality is still missing to actually have this fully functional and be at least remotely ready to be actually used by normal end users. So yeah, the modem is actually not working really yet. This might just be an open source user space issue. I haven't really gotten to the bottom of that yet. Audio is not working yet. Didn't really spend any time on this yet. Camera is missing. As I said, we can talk to the camera sensors, but we can't get any picture data from it yet. Time of flight sensor, which is kind of a distance sensor for autofocus. Vibration motor, NFC, and sensors are also not working. It's also kind of good to know here, for example, the camera stack works quite a bit differently, kind of what mainline Linux would expect. So where you get some video for Linux devices, you open them, you maybe run some IOCTLs on it, and then you get some image data from it. In Qualcomm's Android stack, this is actually implemented in user space. So basically all of the sensor communication via I2C happens in user space. And yeah, a lot of different functionalities implemented there. Replicating this kind of in a completely open source way is probably kind of impossible, or at least getting the same amount of image or the same quality of image from it. But still something, yeah, we are interested in looking at kind of how much we could do there. As I said, this is all an R&D project. So yeah, we are exploring different ways to kind of resolve this problem that we have by having old kernels shipped by the SoC manufacturer to us, and kind of how we can resolve that. For Android versions, we have figured this out with 7.2 already, how to kind of get away from the SoC manufacturer's dependency on updating to a new version. But for the kernel, we haven't figured it out yet. We're working on that. We're also looking into a few different parts of maybe how to get to a newer kernel version. Maybe differently to kind of what a pure mainline upstream kernel would be. But yeah, unfortunately, we don't have something to share yet. Maybe at some point. Yeah, so I think at least for the 5.5, yeah, I think we got quite some reviews. We are quite happy about what we were able to do with it. Media seems to be positive. Lots of great reviews. Yeah, so thank you for listening, and time for questions.
Thank you for the detailed presentation. I wanted to ask, in order for you to become sustainable, you also have to be economically sustainable, so that you can keep producing parts and support. How do you even, because you seem to be working against capitalism, within capitalism, how do you make that work?
So we generally the kind of the financial goal of the company is to make a profit. Not really just to please investors, but to just to stay alive. Because of course, if you're just making miners, you can't stay alive. Except if some, for example, venture capital firms are always pumping money into the company. So we're definitely trying to be financially healthy there. I think was it last year or 2 years ago or something? You can read this in our impact report, I think it's called. So we actually did make a profit. Yeah. So yeah, it is tricky to balance everything, of course. But yeah, for the detailed numbers, you can really check our impact report where a lot of the numbers are, and you can hopefully find an answer there.
Just a comment was around the time of the Fairphone 4, I kept noticing that you had a LCD screen, and once you've kind of experienced an OLED screen, you kind of don't want to go back. So I was like, oh, I wish Fairphone would come up with an OLED screen. And literally about a month before you announced the Fairphone 5, I went and purchase another phone, and I was like, no, now I have an OLED screen. So anyway, my question is, when you say you can donate old devices, I mean, pretty much any device, if it's an old like Nokia 3310 or something lying in a drawer, or would you be able to donate those kind of devices?
So for the reuse and recycle program, we do have a list of devices that you can send in. I don't know the details there. You can check the website. It's not every device, so you can't just take any random Chinese phone and send it there. But I think a lot of devices are on this list, so especially ones that were sold a lot in Europe, I guess.
You shared a lot of what you're doing to keep your phones updated to the current software versions and the kernel as well. How much of overhead are you incurring just by coordinating with other vendors like Qualcomm for the chipset and Google for Android that would be eliminated if you would own your own mobile software stack and chipset?
Yes, but yeah, I mean, of course, it's a lot less work to make existing software work for the devices. It's also kind of my job to kind of figure out why the existing, why the software that is being provided to us by either directly Google or Qualcomm, why it doesn't work. Of course, we will have different problems, and I think a lot more work to have our own operating system. And of course, also in the mobile landscape, it's kind of impossible to really have any, even Android-based alternative without Google services is kind of impossible. I think Huawei tried this with their Huawei mobile services, and I think they pumped a lot of money into it, and I don't think it really went anywhere in Europe at least. So yeah, it is difficult. Of course, with EOS and the web shop, we do provide a variant without Google services provided there. It is, of course, for people that actually want this and only want the open source software that doesn't have any Google service reliance. Yeah.
So what would you say is the excuse that we have? Sorry, hi, Luca. Why wouldn't my next phone be a Fairphone, and what would it take to get over that hump? Like, what's the catch? Let's just maybe say this. Like, what do you think is the most important things to fix so that all of us here are comfortable with this being our next phone? Because all of the things that you said are great, right? So let's get there.
I mean, I would ask you why you don't have a Fairphone. I mean, of course, I know that a lot of people get their phones through operator contracts, and a lot of operators we don't collaborate with, so you can't get it through the operators there. Of course, also our phones are quite a bit more expensive compared to other phones of the same kind of technological specs. But yeah, we're not just doing technological specs, we're also doing the fair specs and trying to get a lot there. So unfortunately, we are not pocketing a lot of profit. Would be nice. So it actually does cost us quite a lot to actually get out of this running. If we were to sell more devices, probably economies of scale would also help to make it cheaper there and to make it more affordable for people. But yeah, it is a very tricky thing there.
So you showed the list of your priorities, and the purpose was very, very low. And this is a bit weird to me, because a 10-year-old phone is a very underpowered phone, but a very powerful thermostat, for example. So are you doing something about that, and why is it such a low priority, given the potential impact is very big from this? Thank you.
So I think from Fairphone's perspective only, I mean, this tricky. I mean, so far the devices that became end of life, so kind of Fairphone 2 by now. Fairphone 1 is a bit of a different story. Fairphone 2, there's actually a company looking into kind of, or researching kind of what could be done with the old main boards and maybe getting them into kind of IoT devices or repurposing for something proper. But of course also before, it's kind of the question, when would you start making kind of an alternative use case from a company? So for example, I don't know, maybe after 5 years after launch, we make a kind of what the framework talk was. So kind of making a desktop enclosure, let's say, for the tiny phone SoC and being able to connect the monitor to it and everything, using it as a desktop, which probably would work even worse because it's an old underpowered phone. But something like that. But maybe a lot of people have already kind of thrown the phone away or given it to someone else. So I think it's a lot easier there to just give other people the phone and to reuse it, to actually use it longer. After 10 years, I think, yeah, it is tricky to say also because we don't really know what will be the performance requirements be in 10 years for kind of running anything. Also think the kind of form factor wise, it might be tricky to, especially some of our phones kind of have a phone shaped SoC, so they're just a bit too bulky and weird to actually put into something.
You shared that your company has venture capital investment. How do you ensure that the company stays true to its mission in 10 years, 20 years down the road with investment?
So we, I don't think you can classify what we have as investments as venture capital. We do have some investors. I think earlier this year, we closed another funding round with a lot of investors or some investors. So the kind of the mission of Fairphone is being overlooked by our supervisory board. So we do have someone, and also when getting new investors on board, we also look at them to see what are their goals. Is it just to make money or to actually do something proper with it? So for example, I think there's InvestNL is one of the, I think it's kind of part of the Dutch government that has some investments in us, and I think in some other parts also. I think you can find more about this. Earlier this year, there should be, if you put in like Fairphone investment round, I think it was about 40 million or something, around this number. I think you can find some of the names there. But we definitely do look at also the investors that invest in us and make sure that they don't want us to do weird things.
Hi. Any plans to give an e-ink display a try? Thank you.
I would say no. I think there were a few phone manufacturers in the past that tried to have either like as main display or as kind of a secondary display on the back. I think there was a company, I think a Russian company 10 years ago or something. I don't think it really works. And I think, as you can see from our phones, we're not really very experimental in kind of the phones that we do. We kind of try to do something that we know that will work. And will also sell, because, yeah, of course, if we produce a lot of phones or design a lot of phones, which costs a lot of money, of course, and don't sell anything, yeah, we will go bankrupt and, yeah, we will stop to exist. Yeah, I think also, I guess, for example, I don't know, if you look at folding phones right now, you can see there's no Fairphone folding phone. I don't think we'll have one anytime soon because there's a lot of concerns with kind of how the hinges work, how the durability would be. If we want to have people keep the phone for 10 years, I'm not sure any current folding phone will actually last for 10 years. And if it's the first phone, then of course also more, or the first phone that we designed might also be extra problems.
I want to say thanks to Luca, and also especially thanks to Fairphone. I think they've had a bigger impact on the industry than just the number of phones they sell, and it's really, really admirable. All right, thank you. Next up, you probably know, is lunch. The next talk in here will be data science at 2 o'clock, and I want to make sure that everyone in this room at least knows that there's a restaurant downstairs. If you're heading towards the exit of the hotel, it's just on the right. That's also open to us for lunch, and yesterday it was very quiet, so yeah, don't wait too long in a queue up here. Go downstairs.
Said
hands are under my skin. I can feel the wings trembling. They would save me from falling. Waves are bringing me back to the land. 100 hands are around me, but they would save me from falling. See the thoughts flying so high. I would like to be with them. They would save me from falling. See the sun heat in the sky. It's so warm and so tender.
it's up, game out, feel like going home now. Now. Fails and turns to luck, words aren't making it seems. Whip hand and join fire. Cut the ground better, dang, just about out from under one. Now the laugh is up, struck about, grapple up and down. Hip hustling higher, fire. On a cloud, turning round, down a sealed, be all up and out. They don't get on, we all fall down. We don't get up if we all fall down. Get up, get on, we all fall down. We don't get on, we all fall down. Get up, get on, if we all fall down. They don't, we all fall down. Like I'm feeling no, okay, maybe going out so right. Picking, fixing a fire now. I'm by the hip, standing still, moving up, going round and round. They don't get on, we all fall down. We don't get up if we all fall down. Get up, get on, we all fall down. We don't get on, we all fall down. Get up, get on, if we all fall down. They don't, we all fall down. They don't get on, we all fall down. They don't get up, if we all fall down. Get up, get on, we all fall down. We don't get on, we all fall down. Get up, get on, if we all fall down. They don't, we all fall It's opening up, duck forward, get cold. Let go and come down, let go and come down. Let go and come down. Tonight it's your favorite shirt, the wind ain't hot but it's calm. Let go and come down, let go and come down. Let go and come down. It's possible I might miss you. If not, when will it again? I burn, you turn, I learn. Why not? Why? You got to feel it tonight. Blow hot and blow cold, play fast and loose. Take it to head, take it to head.
Welcome back, everyone. With no further ado, I will introduce Juan Luis, who's going to tell us about data science in production.
Thank you very much. All right, well, thank you everybody for attending. We're going to talk a little bit about data science, and before we get to that, I need to start with kind of a tricky question. So can you please raise your hand if you know what Jupyter notebooks are? Okay, so for people following online, most people know it. Can you keep your hand raised if you like Jupyter notebooks? Okay, yeah, lots of hands dropped, which is about the answer that I expected, so my anxiety is much lower now. So, okay, I got it. Lots of people don't like Jupyter notebooks, but it turns out that many other people do like them. So, for example, that's why there's this 2018 article in the Nature journal about why Jupyter is data scientists' computational notebook of choice. Or, for example, the fact that in the Python survey of 2022, there's this suspicious other category in the IDE, the primary IDE question, that probably hints that there's something that data scientists are using that is not VS Code, and it's not PyCharm, and it's not Vim. So I will take an educated guess and say that it's Jupyter, probably. And in the following question, which is, what is your most widely used secondary IDE? You see that Jupyter Notebook comes in second, and, well, there's some overlap between Notebook and Jupyter Lab, right? But if you add these two percentages, it's very clear that it's the most widely used secondary IDE. So much so that only on GitHub there are more than 10 million public notebooks at this point. There's some research that the JetBrains people did, and they hinted that, you know, in 2018, so 2 years before this article, there were like 1 million public Jupyter notebooks, and then in 2020 there were 10 million almost. So can you imagine 3 years later what has happened? So, okay, 10 million public notebooks, imagine the amount of private notebooks that exist, but then half of the people in this room do not like Jupyter notebooks. How can so many people be so misguided? And it turns out it's a little bit more difficult, right? So according to some models in any machine learning operations process, or MLOps for short, there's an experimentation phase. So you come up with a use case for machine learning, and then you start iterating and so on. And then there's a production phase in which, again, it's an iterative process because you have to update your code, then make sure that it's running correctly, and so on. And what happens is that the people that like Jupyter notebooks are often on the left-hand side. The people that lower their hand are on the right-hand side. And in the middle of that, it's what I call the chasm. Okay? So the point is, how can we make sure that the left-hand side and the right-hand side talk together when the people that use notebooks don't really understand the methods and the processes of the people on the right-hand side, and the people that work in the production of these systems don't really like notebooks at all. So before going to that, I introduce myself very briefly. So my name is Juan Luis. I'm originally an aerospace engineer, and then I taught myself Python because I needed for solving some equations at university, and here I am. And at the moment, I'm product manager for Kedro, which is an open source Python library for data pipelines at Quantum Black, which is part of McKinsey & Company. I'm currently the organizer of the PyData Madrid monthly meetups, and previously I've been very involved in the Python community in Spain in general. So I co-founded Python Spain nonprofit, and I organized the first 7 editions of PyCon there. I've been contributing code for the SciPy and the PyData ecosystems for almost 10 years, and I've been working in that chasm that I mentioned before for about as long. So I'm obsessed with bringing scientists, whether data scientists or science scientists, and engineers together. So to answer the question of how we can cross this chasm, I had to go back in time just a little bit. Bear in mind that Jupyter Notebook, with its current name, was introduced in 2014 by Colombian programmer Fernando Perez. At the beginning, the logo resembled these annotations by Galileo in his notebook in the 16th century when he was observing the moons of Jupiter. And that was about the time that notebooks started to take off. For example, there was this cover in Nature, and you can see there on the bottom that there was an article devoted to IPython notebooks. And that year also, O'Reilly introduced notebooks as a way to author technical books, which was kind of impressive. And that same day, I don't know if this was coincidence or not, GitHub also added support for Jupyter notebooks to their interface. So this all happened in 2015, and at that time, I was giving a very well-attended talk, I must say, at PyCon Sweden, so this was already 8 years ago, about IPython and how it was enabling the new generation of open science and so on. And I talked about Jupyter, and I, of course, picked an enemy, and this presentation contained this slide over here. So you might imagine what am I talking about, right? It was easy to pick Excel as an enemy, because we had so many recent disasters that had been happening recently. For example, there was this not so famous article by the economists Carmen Reinhardt and Bernard Rogoff that proposed basically that the more debt that the countries were taking, it was in the long run really bad for the economy, and this was like the article that justified the budget cuts in Europe at the beginning of the past decade. And it turns out that the spreadsheet had some dubious assumptions and some arithmetic errors, so the conclusions were exactly the opposite of what the paper was intended to show. And this was very famous in the open science community back then. But there was no shortage of problems caused by Excel. For example, in 2020, there was this article by The Verge that said that scientists have to rename human genes because Excel is constantly turning them into dates. And this is a very annoying behavior that apparently couldn't be turned off back then, to the point that, as the subtitle says, it's easier to rewrite genetics than update Excel. And the same year, in 2020, there was this super fun thing that happened because in the UK, they were adding COVID cases along columns instead of along the rows. And so at some point, Excel ran out of columns, and there was some period of time that they were undercounting COVID cases by 16,000, So with all these things, how could I not possibly pick Excel as an enemy, right? Or maybe we're missing the point. Why fixate so much on a specific tool, right? Because, if you think about it for a moment, bad things can happen no matter what tool you use or what programming language you use. So to get to that question, I need to go back in time a little bit more just to present you the biggest hater of the history of computing, Exer Dijkstra. So this guy was really famous in the 70s because he won the Turing Award in 1972, so he really knew what he was doing, and he had tremendous contributions to the world of computing. And he was also known for having very harsh opinions about virtually everything, really. So let's see what Dijkstra had to say about Fortran programming language back then. I'm going to read out loud. The sooner we can forget that Fortran has ever existed, the better, for as a vehicle of thought, it is no longer adequate. It wastes our brain power, it is too risky, and therefore too expensive to use. Fortran's tragic fate has been its wide acceptance, mentally chaining thousands and thousands of programmers to our past mistakes. Wow. There were some harsh words by Dijkstra. I don't want to think how the Fortran community took this criticism back then. But the point here is that Dijkstra maybe it's putting too much emphasis on the tool, and he criticized virtually every language that existed back then, so I'm not going to follow all of that. But the idea behind this implicitly is the idea of linguistic determinism. So from the Wikipedia definition, linguistic determinism is a theory that says that the language that you learn or the language that you use limits and restricts your ability to understand the world in some sense. So this is now generally agreed to be false by modern linguists. However, there's a weak principle that is called these days linguistic relativity, which means that the language can affect somehow your perception of the world, you know? So it doesn't cripple your mind forever, as Dijkstra seemed to think about Fortran for programmers back then, but maybe it has some influence. Or better put, you can write Fortran in any language. This is the Jeff Atwood article where I took all this information from. It's really old, it's from 2005, but I think it's as important as ever today. So, okay, if the language cannot cripple your mind in terms of how do you understand computing, but it does affect a few things, then what do we do? Well, there are some things that we can fix. For example, some of the other very famous contributions of Dijkstra was this article called "Go-to statement considered harmful," that apart from giving way to probably the biggest cliche of computing today, because now everybody repeats this considered harmful thing, it had a very important lesson, and it was that we have to go towards structured computing somehow. So the presence of the go-to statement was impeding our ability to progress and write more complex software. In fact, there's this article by Nathan Smith, which is a very influential person in the Python community, that came up with the concept of structured concurrency, and he has a very nice description of these issues. So for example, if you see the with construction in Python, which is what we call a context manager, everything that happens inside that context manager assumes that the file is open, and everything that happens outside assumes that the file is closed. And if you think about it, this is really cool, because you don't need to manually open and close the file. But if Python had a go-to statement, you could never do this, because if your program execution flow can jump at any point in your program to somewhere where the file is open or closed, then basically you cannot make any assumptions and you cannot make any progress. So it's an example of a feature that the moment it exists, it limits your ability to grow. Okay, so with this in mind, back to notebooks. What does this teach us about the current situation, right? And the fact that many people dislike notebooks. Well, people dislike notebooks for very good reasons. For example, there's this research that I found in the Greg Wilson blog that said that basically 90% of the public notebooks that exist don't have any way of installing the dependencies and so on. So you basically download a notebook, and then you don't know what software were they using to do the analysis, and even if they specify the dependencies, the versions are no longer up to date, so the code still doesn't run, and even if they specify the dependencies in the right way, the code, for whatever reason, doesn't run top to bottom. So if you go and read the article, you will see that they analyzed 100,000 notebooks, and only 725 were fully working. So that is less than 1%. And there's no wonder that people have had bad experiences with notebooks. And also, on the other hand, there's this super amazing talk by Joel Grus called "I Don't Like Notebooks." This was from JupyterCon in 2018, and I highly recommend you to watch it because it has so many amusing examples of things that happen when you're working with notebooks. I don't agree with all the solutions that he proposes, but definitely the problems that he was exposing were very real at the time. And for example, there's this typical thing if you've worked with notebooks where you start accumulating untitled notebooks over and over again, and very quickly you start losing track of everything that you have. Okay, so there are some specific problems, and not everybody likes notebooks, but also it's a very useful tool. So I'm going to conclude this presentation and give some time for Q&A by stating a couple of things that I think we should not do, and two more things that I think we could be doing a little bit more. So the first one is that we should stop telling people that the tools are bad. You know, there's lots of discourse online about how notebooks are bad, and by using them, you're a bad scientist or a bad data scientist and whatnot. And I don't think it's taking us anywhere because, if Fortran resisted the criticism of Extra Dijkstra in the 70s and it's still very much alive 70 years later, we can assume that Jupyter notebooks are going to continue existing for a very long time. So we better stop telling people that their tools are bad or that they are bad because of the tools they use. Bonus points if you actually try to be helpful when people express their problems and the technical issues with any sort of computational tools. And second, I think we should stop telling people that they must be the masters of everything. Our profession as data scientists or data engineers or machine learning engineers is already difficult enough. Like, if you want to be a good software engineer, that's really hard. If you want to have deep domain expertise, that takes years to accumulate. And if you want to have good mathematical and statistical skills, well, I don't need to tell you that you need to study a couple of textbooks, right? And if we try to pretend that people are doing the data science part, so the exploration part, can also become excellent software engineers and use fantastic tools and dump everything to production directly, then I have some bad news. We already had that some years ago. It was called the Drew Conway's Venn diagram of data science. And it didn't work, because we tried to stay on the data science part, but in the end, we ended up in the danger zone part, or in the traditional research part. So that didn't work 10 years ago. The industry has matured, and now we have different roles that do different things. And so I think we should continue that trend. So what to do instead? Well, first of all, let's fix the problems that are worth fixing. And there's actual progress being made in all of these tools. For example, Jupyter now doesn't automatically save everything as untitled 1, 2, and 3. The first time that you save a notebook, it prompts you to choose a name. So this is a very good UX pattern, in my opinion. And it's very recent, I think, from the last version or so. But at least one of the problems that was exposed in Joel Gru's talk is already gone. Another one is this thing that notebooks have of the implicit state. That sometimes you have cells out of order and the execution is a little bit difficult to understand. So there are kernels now, like IPyFlow that I'm demonstrating here, that if you affect one of the cells, there's a visual indicator that is going to appear in a moment, that you also will need to change some of the other cells. So you see, I changed that cell, and now Jupyter is telling me that I need to execute the other ones because they are out of date. And this is a very simple way of addressing that problem. And there's even a method to do this automatically. So all the cells that are affected by a change are going to be executed. And well, Microsoft has fixed their automatic data conversion thing. So now you can actually disable it, and genomics will not need to rename the genes anymore. So thank you, Microsoft. It only took a few years, but we were finally here. And the second thing is that I think we should meet the users where they are. Our data scientists pretty much love notebooks because it enables them to do exploration in a very quick manner and so on. So why not meet them where they are? For example, when Microsoft announced this year that they were adding support for Python in Excel, I know like half of you are thinking this is a massive headache, and the other half of you are thinking this is awesome. I don't know what to tell you, to be honest. I think it's going to have pros and cons, as everything. But I think it's awesome that instead of writing like arcane macros on VBA or naming cells like A2, B5, and things like that, you can write actual code and a human can read. And I think this is a net improvement over what we had before. On the other hand, even Snowflake, the data warehousing company that is competing with Databricks, they just added Snowflake notebooks now. So before they were like a database, a columnar database for large amounts of data. And now they realize that to become a full stack data platform, so to speak, they need to add notebooks as well. So everybody is biting that bullet, so to speak. And it's what we're doing in Kedro as well. So Kedro is an open source data science framework. And for many years, the messaging has been like, don't use notebook, notebooks use Kedro instead, right? And in the past few months, we've tried to evolve that messaging. And recently, we added an article to our blog that explains how you can use Kedro from the notebook. So, for example, you can define your data sets in a YAML file like this that specify where exactly your data lives and what kind of library you're going to use to read it. And then from the notebook itself, you should be able to load this data catalog thing from the YAML file. And then your notebook code doesn't care about if your file is a CSV file, if it's on disk, if it's on an S3 bucket, or whatever. The code becomes completely agnostic, so the data scientists can do their job and analyze things, but you don't have to care about hard coding relative paths or absolute paths or things like that. So in any case, software engineers and data scientists, we need to talk to each other, and it looks like it's difficult if we don't move past the differences in tooling and processes that we use. But I'm confident that if we're empathetic to one another and we're kind to one another as well, we can continue building a working relationship and at some point cross the chasm. So thank you very much.
We still have about 3 minutes for questions. Anyone? No.
I have a very simple question, but it's a stupid one, so I hope you do not mind.
There are no stupid questions.
Well, I was not previously familiar with this product. I did look at IPython years ago, but I am not a Pythonista, and I have never really used it. I cannot find a simple explanation of what is a notebook in this context.
So a notebook is like the idea of literate programming of Donald Knuth from the 70s. So a way to have in the same document code, explanations, images, video, and whatever. So it's a way to summarizing not only the computation itself, but also the results of the computation and any other media that you want to add. So it's like an evolution of the paper notebooks that scientists were using on a digital form.
Yeah, one question from my side. I use Python, so I have some experience with these tools. Do you believe like the default interface to using Python and learning it, which is in the terminal, black and white, is the scary part, which pushes new people, new learners who are more prone to making mistakes to go, oh, just install Jupyter and suddenly you can click buttons and you can click them in any order. Do you think that puts more responsibility on the Jupyter people to make it? So if you had to improve Jupyter, you would also keep in mind that a lot of people who are new to Python might be experiencing it through it. So do you believe that?
So, well, to the first part of your question, like, do I think that the terminal scares people? Absolutely, yes. Like, have you tried showing the terminal to a normal person lately? And you know what scares people the most? The fact that it's black. Because that reminds them of these hacker movies where the hacker is getting into the terminal and doing shady stuff, you know? If it were white, then people would just think, oh, this is just, you know, like a bad text editor maybe, or a confusing one. But, you know, there are lots of UI and UX decisions in the tools that we use that we take for granted that have like a very large impact, you know? So in that sense, the fact that Jupyter is friendlier in that sense because like you can edit the text after typing it, right? Something that you cannot do in the terminal. Or that it's white, so it's not sending you the message that you need to be a hacker to use it. I think it was a huge leap forward to democratize data analysis, data science, and so on. What other assumptions remain that are blockers for people to get into this? I don't know, but if we start questioning them, I think we can move forward.
All right, well, that's time. Thank you again to Juan Luis.
Thank you.
The next talk in just under 5 minutes in this room will be on bringing Linux to Apple Silicon. Getting quite a crowd for this one. All right, next up we have Tobias, who will be here, and Hector, who unfortunately decided to stay in Tokyo rather than come make us all sick. So we should thank him for that, to talk about running Linux on Apple Silicon.
Well, thank you for that. And for the first half of this talk, I will hand it off to Hector Martin, the project founder and lead of Asahi Linux, and we'll get to learn something about the current state of Asahi Linux. And here we're going to learn something new about how firmware works, how we handle Apple's firmware in Asahi Linux. So a warm welcome for Hector, who joins from Tokyo.
All right, thank you, everyone. So I hope this works fine. I am sorry for not being able to be there in person. I'm still recovering from a weird, cold or something that's been going on for 3 weeks now, and I didn't think getting on a 14-hour flight sounded like a good idea. But hopefully we can do this remotely, and we won't have any trouble thanks to the magic of technology. So, all right, let's get started. So the talk is from Asahi Linux to Ubuntu, running Linux on Apple Silicon. So let's talk a little bit about who we are first. So I am Hector Martin. I go by Marcan online most of the time. I am the Asahi Linux founder and project lead, and Tobias Heider, Toby, is the Ubuntu Asahi project lead. So I will start off by talking a little bit about Asahi Linux. So you've probably heard of us if you are at this talk. But quoting from our website, Asahi Linux aims to bring you a polished Linux experience on Apple Silicon Macs. And what that means is we are doing as much as we can end-to-end to make Linux, and in particular desktop Linux, work well on Apple's new machines. So that means not just drivers and things like that, but just making everything sort of work together as it should. And a lot of people get confused and think that Asahi Linux is a distro. We are not a distro. What we do is we work with distros. So our goal is to get everything upstream and working, and to collaborate with distros so that we can offer different types of Linux, different flavors of Linux on Apple Silicon. All of our work, at least on the core side, is 100% volunteer or donation funded. So there's no help from Apple, but there's also no hate from Apple, and that's very important. So Apple Silicon devices are embedded ARM64 devices. And that means we are using device trees for configuration. There is no ACP. The boot system is completely custom, at least on Apple's side. The peripherals are basically all custom Apple stuff. And if you look at the platform overall, it's a lot closer to a Raspberry Pi than a PC, except, actually fast. And our goal is to make this work at least as well as Linux on x86, if not better, and do all that upstreaming everything. So if you look at the embedded Linux world, it's kind of a mess of, most of the time, it's a mess of outdated downstream vendor kernels. The bootloader ecosystems are fragmented. The distros tend to be vendor, custom distros. There isn't really much user choice on any given system. And standard distros may or may not work to some extent, but it's kind of sketchy. Those vendor distros often have outdated or non-standard libraries. There is very little focus on upstreaming, at least from the vendor side. And those vendors also rarely contribute across the whole stack. So you see a lot of fragmentation in the ecosystem. And when I started the project, I thought we can do way better than that. So our flagship distro port is the Fedora Asahi Remix, which has been in beta since August. The release is going to be really soon now. I'm pretty sure it's going to be this month. And the goal is that it should work just as well as Fedora on AMD64, and definitely much better than Fedora on a Raspberry Pi. Not to hate on all the wonderful people that are working on that, but our standard is basically the bar we want to meet is x86. We want to be as good as x86 support and AMD64 support. And that has to work all out of the box and mostly upstream. So, relying as little as possible on forks and things like that. So to talk about that, here's how the upstreaming state is for the Fedora Asahi Remix. All of our bespoke packages are packaged upstream in Fedora repos. You can install them on any other Fedora system, even x86 systems. They won't do much there, but you can. And all the fixes and improvements to existing userland are basically upstream in the respective projects. What we have downstream is the kernel. We have a kernel fork, which is in the process of being upstreamed, and that's one of the hardest parts. We also have Rust for Linux support in particular, which the default Fedora kernel does not. We have Mesa with support for our GPUs. That is actually like a 90% upstream, except the UABI for sort of process reasons. We have U-boot downstream. That's also basically all upstream already, except for some boot config details. And our branding and image creation and Calamares config repos and stuff like that. So just, basically branding details that go into the final images we make are downstream. But all the core components, all the platform support, everything except the kernel, Mesa, and U-boot is already Fedora upstream. And so, as I said in that slide, a polished Linux experience, what does that mean? Sure, we have to write the kernel drivers and Mesa drivers, and that's a lot of work. But we also have to deal with bootloaders, and we have to deal with the install and update tooling, and we have to deal with boot and vendor firmware tooling, and we have to deal with user space system tooling, and we have to deal with platform support daemons, because we're going to have to write some stuff to make things work. We also have a lot of integration around audio to deal with, and also desktop environments. There's always going to be things that don't work out of the box for various reasons. So all of this are things we have to work on, because a lot of people think we are working just on like the kernel drivers and then everything else just works. Not really. So yeah, there's a lot of work outside the kernel and outside, like the Mesa drivers. And there's a lot of bug fixing. Actually, yeah, so there's a lot of bug fixing. We'll talk about that in a second. But when you are kind of this first platform that is ARM64 desktop Linux that people actually want to like use as a daily driver system, because most of the time people, there wasn't really any viable platform that had the like spec requirements and the experience that people wanted on ARM64. Raspberry Pi is not a great dev workstation, nor are most Chrome OS laptops, unless you're just using it as a remote terminal. So yeah, we find a lot of bugs everywhere. So things that we have as part of our Fedora remix and then the core repos. This is sort of one of our biggest things right now. We have a fully OpenGL ES 3.1 conformant driver for Apple GPUs. It's conformant on all the variants, on all the chips that Apple sells until the M3, obviously, that just got announced right now. But up until the M2 and all the variants of that, it is certified conformant OpenGL ES 3.1 on all of them. And that is the world's first driver to have any Kronos conformance for Apple, because macOS does not have that. They do not actually pass the tests of like any of the OpenGL version tests. And we have desktop OpenGL 3.1, soon 3.3. That's not conformant because honestly, nobody does like 100% conformance for desktop OpenGL is kind of pointless, because that includes the like legacy OpenGL 1 stuff that some CAD software from the 90s uses and nobody else cares about. But ES conformance is is the big thing, because ES is like the subset of OpenGL that matters. And if ES works, then pretty much everything people care about desktop OpenGL is also going to work. So that's a big deal. But it's not just the GPU driver, because everyone knows about the GPU driver. We also have to do things like get the speakers to sound properly, because did you know that most recent speakers need DSP to not sound terrible? And as far as I know, we are going to be this isn't released yet, but it's going to be very soon. We're going to be the first desktop Linux platform with out-of-the-box software DSP for the speakers. And that means I and James, who is also working on this, have been sitting around and sticking microphones in front of laptops and calibrating the frequency response so that we can go from something that looks like that to something that looks like that. And that makes a huge difference. And as far as I know, this has never been done on Linux before. It's part of the reason why speakers on laptops tend to sound worse on Linux on some devices than on the like vendor drivers on Windows. And this has been a thing on other platforms for a long time. It's a thing on cell phones. You have to use DSP, right? But we haven't had this integrated in Linux. Of course, you could DIY, some plug-in DSP, but this has to work out of the box and just look like regular speakers, including the crossovers, because sometimes these laptops have up to 6 speakers, and you have to split the signal and do all kinds of processing. And we also have like fake bass plugin that we wrote. It's called Bank Sound. So there's a lot of work that goes into that. And not only the DSP, we also have, as far as I know, the world's first open smart amp implementation. And what that is that basically when you say you have a speaker that is plugged into a 10-watt amplifier and you give it full scale music, you're probably only going to be sending that speaker a max of like 2-3 watts, if that. So the worst case power is a lot higher than the case, the power you send to a speaker when you're playing normal music. And that's especially the case for the tweeters when you have two-way systems. And so that means is that if you're limiting the volume of the amplifier to a volume that is safe to have the speakers at for any input signal, then you're wasting a lot of headroom there. And so every micro speaker system on like tablets and phones everywhere is using some kind of smart amp system where you actually estimate the temperature of the speaker voice scale and magnet based on feedback from the amplifiers. And then you limit your volume, your gain based on that. If the speaker gets too hot, you lower the volume. But if it doesn't get too hot, you can send peaks to it that are way higher than its maximum power. And this is also one of those things that is just, it's obvious. Everyone does it on at least tablets and phones. Most laptop manufacturers do not care about this kind of stuff, which is why most laptops have terrible audio, but Macs don't. And we want to sound at least as good as Mac OS, so we have to do all of this. And on Macs, it's done in software, so we have to do it in software, and that's how Speaker SafeTD came around. And then there's things like this, like the touch bar, right? There's exactly 2 models of MacBooks, and there will be no more, hopefully, that have this thing and are Apple Silicon. That's an OLED MIPI DSi screen hooked up to a custom display controller and a Broadcom touchscreen hooked up via SPI to a custom SPI controller with a custom SPI HID over SPI protocol that is different than the HID over SPI protocol that the keyboard uses, because of course it is. So all that has to work, and since the kernel just sees a frame buffer and a input device once we have the drivers in, we need something to drive that, and so we have a daemon for that puts out the keys and uses uinput to send input events to the rest of the system, and it all just works. And it integrates with the actual keys on the keyboard. You press function, the little labels change. You can send the special keys, all that. These are all the things that we have to do to make this actually function properly, right? It's not just about getting the drivers in. There's a lot of work that goes into all the integration so the machines work as you expect them. And then, of course, there's the installer. So we have an installer. It's text-based, but it's very user-friendly. We don't actually have any docs for it. You just say run it, and nobody has complaints. So I think we did a good job. And it just guides you through the system, through all the process that goes into installing, which I will talk about more in a second. But that's another component that we have to deal with. And then, as I said, there are bugs. There's lots of kernel bugs. We found out that ARM64 atomics were broken for over 2 years in mainline Linux. Oops. Turns out that those bugs reproduce a lot more easily when your CPU is highly out of order and very high end, like Apple CPUs are, and don't really reproduce on little tiny ARM cores. We found framework bugs. The Qt5.js JIT started crashing at some point in ARM64 and tracked that down. We fixed desktop bugs like KWin, compositor glitches, and performance issues. We've even found compiler bugs. I found a GCC bug that was miscompiling executables that turned out to be over 2 years old and also affecting all architectures, just differently. Here's a fun new one. So we just enabled the webcam, and the newer Apple laptops are probably the only laptops in existence that do vertical video, as in the sensor physically is square and you can crop out horizontal or vertical video. And it turns out a lot of video for Linux apps cannot handle that because, first of all, a lot of them will default to vertical video because the algorithm for picking a resolution is whatever is tallest, which kind of breaks with that. But also, vertical resolutions, which become horizontal in vertical video, tend to be non-powers of 2 or non-close, to a large power of 2, which means we end up needing stride padding. V4L2 supports that, but a lot of apps don't, and so then they break. And lots of apps are broken on page sizes that are greater than 4K because ARM64 supports 16K and 64K. And it turns out a lot of apps make assumptions about that, some of them large, some of them small. There was one where Chromium had broken WebRTC, depending on how many network interfaces you had, because they were using netlink on a buffer that was 4K, and netlink messages from the kernel can be up to 1 page in size. That's what the stuff we run into sometimes. And so the story here is if we run into a bug somewhere that is in any way related to the platform, we have to fix it. We either get upstream to fix it or we track it down ourselves and fix it. But we take responsibility for at least any core software that we are shipping and any implications of the platform. And there's a lot more. There's the U-boot port. We have scripts for extracting firmware and handling that. We have automatic bootloader and device tree updates. We have the LSA UCM configurations to make the audio stuff work with Pipewire. And by the way, for the speaker DSP, we worked with Pipewire and WirePlumber to add a bunch of features we needed to make that work and out of the box and have like, we just got a feature merged in to hide the physical speaker device, so we can just have our DSP, fake output, virtual output, but then it's not marked as virtual, so KDE doesn't think it shouldn't display it. And then the real one is hidden. So, from the point of view of the system, you have a stereo, speaker device that you set as your default output device and it works, but behind the scenes, all this DSP happens. So that was part of the speaker story there that I forgot to mention. I also made a Widevine installer because it turns out that a lot of people want to watch Netflix or play Spotify, and Google doesn't make Widevine available for ARM64 Linux desktops, but they do for ARM64 Chrome OS desktops. And unfortunately, Chrome OS uses a weird glibc and a weird ABI, and so you can get it to work on standard ARM64. So we did, with some weirdness and some horribleness. But now we have an installer that can just get it to work without any modifications to the rest of the system. And also things like our Calamares first time setup is running on Wayland. And I think we're probably the first to do that because I had to send a bunch of patches for that. And that actually made our distribution, our remix, our Fedora remix, 100% Xorg free. We do not install Xorg, the bare metal Xorg server anymore. That everything on the system relies on Wayland. And we also have world-class dev and reverse engineering tooling, which is very important to get everyone working on this to have a good time and actually enjoy doing it. I've kind of heard that even Apple uses some of our tools because they're better than theirs. So yeah. That's something that we worked a lot on, especially early on, because it's what makes all of this possible at all, right? You need the tools to actually, get to the point where you can work at a pace where we can keep up with what Apple is doing. And so there's a lot of the work that went into that. So that's what we're doing today. And as for things that are coming up, my next sort of personal project is CI, because we have a lot of platforms to support and different chips and different firmware versions. We'll talk about that. And so we're going to need continuous integration on real hardware to make that all work. And so what you see there is the beginnings of the Asahi Linux CI cluster. And it's not plugged in yet, but that's where it's going to be. And that is another thing that we are setting up. So before I hand over to Tobias, I wanted to talk a little bit about a part of the platform that isn't very well understood, because I think that a lot of people that come into the Apple Silicon ecosystem, they get very confused about how it all boots and how it all integrates with macOS, and whether this is a hack or this is something that is officially supported or how it works. So let me just spend a few minutes talking a bit about how the platform boots. And the first thing you're going to have to do is forget about everything you know about EFI or BIOS or anything like that. This is completely bespoke Apple stuff. So forget everything you think you know about how machines boot, and check this out. So this is how a macOS, like an Apple Silicon machine with 2 macOS installs, boots. So there's a boot ROM, of course, and then there's a NOR flash, just like on any x86 system. That's where the BIOS would live. On Apple Silicon, that has a thing called iBoot1 and system firmware. And so iBoot1 is the first stage bootloader after the ROM, and its job is to boot an OS on the system, to select an OS to boot and boot it. And system firmware refers to all the firmware on the system that is updated and system global. So that firmware is always a single version for the whole system. And then this is the clever part. What Apple does is that they take advantage of APFS, which is their file system, which is kind of like Btrfs. And so they have a single container by default on the disk for all the macOS installs you might have. And so that is an APFS partition or a container. The partitions are regular like GPT partitions. And so then that inside contains a pre-boot volume and a, actually the paired recovery OS is a little bit drawn wrong there. That's actually a single volume for all the installs. But there's a pre-boot volume, and then there are system and data volumes for sorry, every macOS install. Let me get a drink a bit. So my throat's going to dry. So we have separate root and data file systems for every macOS install, but there is a pre-boot volume that is shared and in different folders. What that contains is iBoot2, which is the second stage bootloader, and that is in charge of loading the OS firmware and the XNU kernel. And the OS firmware refers to all the firmware that is attached to a given OS installed in the machine. And this is really clever because it allows Apple to break the ABI of that OS firmware on every macOS update if they feel like it. And since it's not global, but it's installed separately for every OS, they can do that and they won't break backwards compatibility because it's just a different copy. And so that's how they do that. And then, that iBoot2 loads the firmware, boots the kernel, then that just, mounts the file systems, and that's how macOS works. And then you can also see there's a paired recovery OS. I won't go into details about that right now, but each OS has a copy of its own recovery OS, and there's a system recovery OS that has everything an OS has and the recovery OS, but no Mac OS. And so that is used for recovery purposes, but it's also used as the boot picker. So when you switch OSs, all the graphical stuff on the screen is actually a stripped down Mac OS. It's not part of the firmware. Or if you think about it that way, recovery OS is part of the firmware, however you want to see it. So how do we put Linux on these things? And that it's a typo there, on these things. So Apple makes certain promises, and it's not like they have a list of these promises, but you can infer these promises from the published documentation, the tools they provide, and sort of how the system is designed. And so these are the promises. Apple promises that you can install multiple versions of macOS, that old versions will continue to work, at least on machines that they support at the time of their release. And they promise that you can replace the XNU kernel with any binary of your choice. And they promise that the system firmware ABI is stable and backwards compatible. But the spec is do whatever macOS does. Sorry. And you get to have fun. That's the story. So with that, here's how we install Asahi Linux. A Fedora Asahi install looks like this on the SSD. What we do is we have a macOS stub. So we have a fake macOS that has a copy of iBoot2 and the OS firmware, but instead of the XNU kernel, we install a bootloader that we call manage stage 1. And then there's a paired recovery OS that is actually there, but the system and data partitions are basically empty. So they have to be there, but there is no root file system, so this isn't really macOS, but it looks like macOS. And then we create a separate EFI system partition, and that contains our mini stage 2, which is our second stage bootloader, and that will load some embedded device trees and a copy of Uboot. That then provides an EFI environment that allows the grub core to load in the normal way from the EFI system partition, and then that loads your kernel from /boot, and the rest is just Linux, same as any other system. And so the interesting thing here is that we have a macOS install alongside every Linux install, minus the root file system. So the way the installer works is that we resize macOS to make space. We resize the container. We are not sharing the APFS container with other macOS installs by design because we don't have to, and this makes it easier to uninstall and make sure we don't break anything. So we have to repurchase anyway, so it doesn't matter. We resize macOS to make space. We create a container for the fake macOS, which is 2.5 gigabytes, which is not that bad, and all the volumes in there. And then we install macOS. The Asahi installer is secretly a macOS installer. It just pulls the components from Apple's server. They have zip files on there that contain all the bits and pieces for a restore, and the URLs are static and well known and never change as far as anyone can tell, and haven't for forever basically, because they've been doing this for iOS for ages. And so you can download bits and pieces of that and install them exactly the same way a regular macOS install works. Then we create the EFI system partition. Then we install mini stage 2 and the device trees and Uboot and all that into the ESP. Then you install the rest of the distro. And finally, we install mini as a replacement XNU kernel into the stub. And that's it. And then you can just boot Linux. And so then what about the ABI story? So as I said, system firmware has a stable ABI because it has to be backwards compatible with old macOS versions, but the OS firmware ABI is unstable. So what do we do about that? And the answer is that we picked specific supported ABI versions. So right now, we support the macOS 12.3 on M1 machines and 12.4 on M2 machines and 13.5 on all machines, ABIs. And we only ever install those versions. So if you install any other version as your stub, that's not going to work. And the rule is that the kernel, the Linux kernel, cannot drop support for old ABIs. So any ABI we bless as officially supported has to be supported by the kernel forever. But as far as iBoot and Apple are concerned, that means that we are just an old macOS install. We can just keep using those ABIs forever, and as long as macOS, that version, keeps booting, which it's supposed to, then we can keep booting, and the platform design guarantees that. It does mean that the kernel needs to grow and ever increasing support for different ABIs, but because we only had ABIs generally for device support, and we try to space it out, and we have we've designed tools to make this maintainable on the kernel, and we are just about to have CI so we can test all these ABIs. That's not an unsurmountable task. It's a bit painful, but it's okay. So platform design guarantees this is stable, except yeah, we kind of just had a little problem with the latest macOS release. Apple broke the system firmware ABI. That was a bug. This broke macOS users. You'll find tons of macOS users saying their machines became unbootable and they needed to be recovered with like a USB flashing thing, which is supported, by the way. You can't brick a Mac, but you do need another Mac to fix it. So it's kind of not great. Asahi installs were actually less affected by this because our drivers are more robust than Apple's, but it was still not great for the reasons that you couldn't actually recover your system because all the recovery stuff was also broken. And this only affected some machines with certain obscure settings, which is why they didn't catch it. This was totally a bug. Apple know about it. It is absolutely getting fixed. I have gotten confirmation of that. So, some people were thinking, oh, this is Apple not caring about Asahi. They broke their users. This is a bug, right? We rely on this because they rely on this, and they screwed up, and they're fixing it, and that's it. So this was unfortunate, but it's the fact that it's getting fixed in the next version is proof that it's not supposed to have happened, and that we can continue to rely on these rules, on these promises. So that's about it for my side. I am handing off to Tobias. I hope that was interesting.
Well, I did learn something. I'm going to be talking about my own side project that I started about a year ago, and I have never publicly talked about it. It's been around the internet. So you might have heard about it, and it's called Ubuntu Asahi. Much like the upstream Asahi project, this is a community project. Our goal is pretty obvious. We take Ubuntu, we take Asahi, put them together, and have the polished Ubuntu experience on Apple Silicon, right? I think it's important to stress that we are a community. We are an open community. As long as you follow our social standards. We do have a code of conduct, which is the one from the Asahi project. We also implicitly follow the Ubuntu code of conduct if you want to contribute upstream, of course. And our ideas are pretty aligned with the Asahi project and Ubuntu projects overall. So we try to upstream everything, and we don't hate other distros. No, we like to collaborate. It's important for us. Everyone has preferences. I think if we are working together, we get a better Linux ecosystem in the end. So let me see if that works. Right. So first of all, I want to talk about how this all started. That was too far. Yes. Like many of you in the audience, I got this pretty nice laptop, solid hardware, works very well, but it just so happens that for my work, I want to use Ubuntu. Other Linuxes, sure, that's better than nothing. But I just have like my single, I don't want to remember 10 different ways of doing things. I just want to use Ubuntu, right? When I started looking into this was August last year, there wasn't an option to run Ubuntu. But I found on the Asahi wiki that there's a list of supported alternative software Linux distributions, and one of them was Pop! OS. Pop! OS, which was done by a person called Lucy, and I have to thank her for that because it was brilliant. I could start from there, change a few things, like the actual repository. That was pretty much a Ubuntu setup. So with a little tweaks here and there, I got Ubuntu running on my laptop, and it was great. Like, it just worked. And reading those scripts, I also understood what's needed to build an image that works with the Asahi installer. Props also to the Asahi project. The installer is well suited for putting in other payloads. There's a lot of configurable parameters, so you can build your own distribution there. And back then, this was kind of hacky, right? We didn't have any proper packages. We didn't do things the right way. It was a debootstrap. Then you put a kernel in, install the initial bootloaders, etc. It worked. It wasn't great. And I'd like to talk about what we've done since, for you to learn what goes into porting your distribution, maybe. If you look at the development history that's from GitHub of our Ubuntu Asahi repo, you first notice maybe that it's moved from my personal namespace to the Ubuntu Asahi organization because, well, I started it, but it's much bigger than me today. And the other thing you see, is that it just doesn't look like there's much happening there. And if anything, we delete stuff. Like, what's that about? But in reality, if you use it, you'll see it works well better today than it did at the start. And let's look at what we've done, right? So the first big thing we've done is we did stuff the right way. Instead of having a image build setup script that does things, maybe how Ubuntu is supposed to do them, maybe not, but it worked. We moved our logic to packages. And if you've ever done deb packages, you know there's a way you can package things in debs, and there's a right way to package things in debs. And that's actually a quite time-consuming task. So yeah, I think we've seen a lot of those packages in Hector's part of the talk. Like you see, what do we have in there? It's currently around 11, I'm not quite sure, packages. We maintain them for 2 releases. Usually, currently there's Chami and Mantic, so we don't care about about Kinetic, no Luna, the last one, because that would just be a bit much to test. Overall, bootloaders, kernel, firmware, ALSA configs, Mesa is a big one. And one that's pretty Ubuntu specific here, livecd rootfs, which you use to build images in Launchpad in the proper Ubuntu workflow. And we've got a meta package as well that just pulls in all of those. So as you could guess, I guess, our installer script got a lot shorter because now it only installs the meta package, pulls in all the rest, and that does the logic. Another effort we've been driving is, well, we started from Pop! OS, and it was great that we could just reuse their tools. And another distribution that was looking into better Apple Silicon support is Debian. And so we thought, well, why not just make our packages available the proper way so that every Debian-based or Ubuntu-based, which is implicitly kind of the same thing, right, distribution can reuse those packages. We do the work anyway, and others might be able to help us, might be able to tell us how to do it better. So I'm very actively working closely with the Debian Bananas community, which is the Debian team that tries to do the same thing we do, I guess. And it's working great. I'm getting great feedback there and learning a lot about doing it the right way instead of just doing. And this is, I think think Mark said, Debian is remarkable because it just works. And we're doing our part, we're giving back, and I think that's great. And big thanks to the Debian developers who help us, even though they don't use Ubuntu. But yeah, that's the kind of collaboration I'm talking about. Next big thing, embracing Launchpad. You might have heard of Launchpad. You might think of Launchpad as the place you host your PPAs at, maybe even a Git repository host. But let me tell you, it does a lot more than that. And I don't even pretend to know like 10% of what it does. But I found, while I was working on this, that looking closely into how Ubuntu, like proper Ubuntu images are built, there's a lot to discover. We use Launchpad to build our binary packages via PPAs. We serve those packages via Launchpad. We host our Git repositories on Launchpad and GitHub. But one cool thing Launchpad can do is it can build packages on Git pushes. That's nice. Now it can also rebase those onto the newest version, like onto the newest archive version. So you can maintain your diff and it rebases it continuously on the newest archive version, which takes away a huge part of manual rebasing work. Great. And the other thing it does is it builds system images for Ubuntu using livecd rootfs. So you can just hand off a huge part of the process of actually building the image. That's what we previously did with like debootstrap and custom scripts, straight to Launchpad. And you get a lot of options for free because it also implements a bit more than our initial scripts did. More about that later. Another thing we worked on, we got help from the Ubuntu desktop team here, is snap support. So initially, when I ran Ubuntu the first time, I think snaps didn't work at all. There was a bug in Snapcraft. Well, it was not actually Snapcraft. Snapcraft was calling patch-elf. Patch-elf aligned elf sections by 4K. Doesn't work on a 16K kernel. Snap binaries wouldn't run. That got quickly resolved by the Snapcraft team. And that's we encountered a lot of those ecosystem bugs at the start. Looks a lot better now, thanks to Asahi and others using it as well. Another great example of collaboration, right? The ecosystem is getting better. Another big thing in snaps is graphics acceleration. The way it currently works is we have a kernel driver. The API is not stable though, so you always need a matching Mesa version. So we usually update Mesa and kernel in tandem. You can imagine not great for snaps, right? If you package your Mesa into a snap, it's going to be outdated at a point. That's kind of part of the concept. So what we did is, thanks to another group of people working on support for the X13S, who I think came up with that solution, and the desktop team, we now have a dedicated GNOME snap which bundles our Mesa version. That is on a separate snap channel on Ubuntu Asahi updates. We subscribe to that channel, and we keep that up to date with our current kernel. Even on Chami, we have like what you would call a hardware enablement kernel. We always use the newest. So it kind of works on Chami and Mantic. You get the right Mesa, snaps work, even with graphics acceleration, which is great because we want to have a great out-of-box experience, and we don't want to have a custom setup, right? Firefox is a snap by default. Now it just works. Awesome. And that brings us to our plans for the future. I said Launchpad. If you use Launchpad to build images, it gives you a few more options. One of the big ones is, well, flavors are also built that way, and we've discovered that the way we currently build our images, building flavors is actually only one option away. Like, we pass it in as an argument, and you can get Kubuntu, you can get whatever. It's worth noting, as Hector said, Wayland works better. But I would really appreciate if we could get flavor installers. I think it would be great. There's a lot of people who want to use Kubuntu. I know people who do use Cinnamon. And if you are working with any flavors and you meet me, I'd like to talk about that. Another thing we currently don't have is a proper USB installer. It doesn't support USB booting out of the box. So, well, we've heard before, it's kind of like a Raspberry Pi, right? We build our image, we flash it onto disk, and then, well, there's a lot of choices that are made before that step, usually, right? So you get my pre-selected defaults, and those might not be what you want. It doesn't give you the full choice of a proper Ubuntu installer. You might want to use ZFS, you might want to use full disk encryption, and currently, if you want to have that, it's kind of tricky to set up. I do have to go the full Gentoo way, basically. So solving that problem, maybe using desktop provisioning, maybe using other solutions, that would be great. So that's on the roadmap. Bottom left, what's that? That's a numbered. For the next Ubuntu release, LTS release, is going to be called Noble Numbered. And one of our big goals is having the central components in the archive, having proper support. Maybe it doesn't have to be great. Of course, it would be better if it was. But having a bootable system in the Ubuntu archive without requiring a PPA, which we currently use, I think that's actually doable together with our work on Debian, quite realistic. So I'm really looking forward to that. And then the last one. I didn't really know about that before I came here, but on the first day we saw a great presentation on Ubuntu Core desktop. And I think that would be a cool thing to have on your Apple laptop, right? So a immutable Ubuntu distribution. It sounds pretty doable. I've seen a Raspberry Pi running it, so why not? And with that, giving you a bit of time to scan the QR code. No, not quite yet. There's a few more things I have to say. So, the QR code leads you to a website, which compiles all the information we have for you, how to install it, communication channels, etc., documentation. That's your central point of information, I guess. And then there's another thing I want to mention, which is Mastodon. We have a very active Mastodon account managed by Mark Essler here, and we're trying to boost everything kind of Asahi related. So I think it's a great newsfeed. If you're interested in the general subject, follow that one. You will learn everything that happens in the world of Asahi and Ubuntu. And down here, that's how you install it. We host our installer script on ubuntuasahi.org. On macOS, you pipe it into your shell, and it should install. If you want to read it, of course, pipe it into a file, read it first. That's the fast way. And now, finally, I want to say thank you to the people who made this possible. Because it wasn't just us. It was the Asahi project who built all this awesome upstream software, the kernel forks. That's really smart stuff. I'm not sure if I could do that. The Ubuntu project, which helped us do so many things, like the desktop team, the kernel team is helping us. The Debian project for helping us with the packages, and everyone in the wider community as well. We've got people replying on GitHub to random issues, people helping in the chat, and I think that's amazing. That's great. And finally, the Asahi project is run by volunteers who work on their own time, but they do accept donations. If you want to support us, please support the Asahi team. This QR code should take you to their website, asahilinux.org/support. It tells you how to donate to the Asahi upstream developers. And we would all really appreciate if you did that. And we've got a bit of time left. So So I haven't told you yet is I did all this setup here while Markan was talking. So this presentation is actually running on a M1 Mini here on my desk. I guess it's time for a little demo. I told you snaps are working. That's a snap. Does anyone know Sonotic? I hope you do. It's great. It's kind of like a Quake clone, and we'll just see if it works. So this is the Rust kernel driver produced by the Asahi project. You might have read about it in the news. And there we go. That's accelerated. It just works. All right. And then I guess we do have time for questions, or you'll have to watch me die.
Just raise your hand, then I'll chase you down.
Hey, I suppose this is a question maybe tomorrow to Hector, not sure if he's still there. Yeah. So you said that you have to kind of bless the OS firmware version for the different, whenever you decide and you need to. Do you think, like, what do you think may be the risk if you skip a firmware version, or like what would cause you to decide that the new firmware really needs to get blessed and go from there?
So basically, we just go by platform support. Apple releases new Macs, and they only support from that macOS release onwards. So for example, we blessed 13.5 because it's the first official version to support all the previous platforms released this year until M3. And so it's a bit of a game of chess deciding whether you're going to support a new release like the M3 that just got released right now, with the version that they came from. We did that for the M2 with 12.4. I think that was a mistake. We should have waited for 12.5 because we could have unified that with the M1 support. But for example, in this case for M3, we are probably going to wait until they release an M3 Mac Mini, which we're hoping probably happen early next year, because that will allow us to run that version in CI, which is basically Mac Minis. And so there's a bit of a game there, right? Where it's like, okay, we're going to support the new platform very quickly, but then add more firmware versions, or wait a little bit and then bless a given version when it merges like two different lines of machines in the same one. So it's just a decision game around that. It's not so much a risk in terms of what version we pick for some technical reason. It's just reducing the proliferation of supported versions, so we don't need the add workload to us.
Let me ask it this way. How fun is it working with the extra fancy chips like the neural engine, the other accelerators? So any experience or guidance there?
So we don't actually have support for almost any of the accelerators. And we actually get this question a lot, is like people saying, well, if you don't do video acceleration, like how is that usable? So people have tested that these machines last longer on battery doing software decoding of video that most Intel is doing hardware decoding. So it turns out it doesn't really matter for for usability. But yes, we will support most of those accelerators. We don't yet though. So we have the GPU. We have that's as far as accelerators, actual compute. That's pretty much it. Alien reverse engineered the neural engine and actually has driver. We just haven't merged it yet because it hasn't been a priority, because there's no standard like OpenGL and OpenCL for machine learning. So either way, you need like to port ecosystem packages. So it's not like we could just plug in and make like TensorFlow work using it. But we will merge it eventually. And she is now looking at the video decoder, so we are going to support that as soon as that's ready. We have some demos of the ProRes decoders running. We do a lot of demos in Python with our dev framework. It's part of the process we have. So we have a demo for the ProRes. I think we have a demo for JPEG, but I don't think anyone cares about JPEG acceleration anymore. And the other big one that's going to have to come eventually is the video encoder. But yeah, right now we don't really have any of the extra stuff. It's not the CPU because you don't need it for a usable system. And so we're focusing on all the I/O things that, like the speakers, which we haven't publicly released yet, because a lot of people care about the speakers working than about video decoding being somewhat more efficient.
Hi, thank you for the amazing work, first off. And my question would be, have anyone looked into supporting Apple's secure enclave under Linux for storing disk encryption keys, possibly?
So that's also on the list of things to come, right? So I don't think we have much for the secure enclave yet, but that's definitely on the list. So once there's sort of a vague priority list, right? The way the project works is that if you want to come in and work on X, you can totally do that. And whatever people want to work on is the priority for them. And then I get to work on everything else, right? Because I'm the one that's getting mostly full-time funded by the donations. And so, but I sort of encourage people to work on the things that we care about the most. And I myself, sort of will take things down that list. And so right now we're in the wrapping up I/O hardware support phase. The next big thing there is going to be DisplayPort, alternate mode, and Thunderbolt. And once we move past that phase, then we're going to start branching out into the decoders and the security stuff. So yes, the goal is, in fact, to eventually be able to do things like have your SSH keys in the secure enclave and support Touch ID and all those fun things that macOS can do. And we'll probably be more flexible than macOS because and this is the theme in general, we're not bound by macOS APIs. So we can make better use of the GPU than you can on macOS with layers on top of Metal, for example. So we will have almost certainly better Vulkan support than with Molten VK on macOS. We have more low-level interfaces for the neural engine, what Aileen figured out. So that will be more flexible than the CoreML stuff on macOS. So that's kind of the theme here. And most likely we will have more, for example, I think we can do ED25519 on the SCP, even though there's no Polyc API for that on macOS. So things like that would probably be pretty interesting.
Thank you.
Thank you. So to just summarize a little bit, do you consider Ubuntu Asahi to be a viable alternative to the macOS operating system at this point for mere mortal, for simple users, not the geeks in this room? So can normal people just use it as it is now?
I'm pretty sure I know normal people who are using it today. It really depends on the feature set you require for your daily work. So there's a few things that don't work yet. One of them is speaker support. It's not enabled yet as a security measure. Microphone doesn't work yet. And external display support. Those are the big ones I can think of. It served me well for the last year pretty much as a work machine. So it's certainly usable. I know other people who are not developers who use it and are super happy about it. I think ultimately you have to try it. The setup is very non-destructive, so you always get a dual boot environment. It's easy to remove. We are not aware of cases breaking your macOS installation or anything like that, or breaking your device. It's not generally a thing. So I guess try it. I'd say yes.
Okay, thank you.
We get the question a lot, and it really does boil down to are the features you need in there yet or not, right? For example, a lot of people have been using it as a remote headless system since way before our initial release, like a few months into the project, because that worked very early on, and the CPUs work and all that. But then, if you do video conferencing all day, every day, well, the webcam was just supported very recently. Speakers are coming with the Fedora Asahi release, hopefully microphones too. So not today, but hopefully very soon. If you need external displays, then maybe wait a little bit more. If you need Thunderbolt, that might be a bit later. It just depends on your personal use case.
And to add to that, I have hardware here, so you can look at my M2 and see if it works. So I'll be outside, and whoever wants to have a look at the hardware running it, free to find me.
I'll be trying it. We're out of time, but the upcoming, we have an hour break, I think. We'll be back here at 4 o'clock, or if I have this correctly? No. Yes, half-hour break, thank you. We have a half-hour break just to get tea, coffee, mingle for a bit. At the hour, we will have in here sustainability talk.
thought nighttime would make us feel permanent, but then came the sun unexpectedly. In the day, standing tall, we got your mother's call. She said she needed you at home, and you just stared at your hand, holding a grain of sand. You let it fall to your feet. Then you said, dance with me. And I did so willingly. There's lights on the radar screen, keep pulling away.
All right, everyone. May I have your attention for Joseph, who's going to be talking to us about bringing sustainability to development. And a quick reminder, I'm sorry, if you happen to be one of the people giving a lightning talk, as soon as this is over, please head up into the corner here. And thank you, Joseph.
Thank you, Hans. Just a request, if you can close the door, because I can get distracted by the sound. And another request, if you're seated over here and you're willing to, it'd be nice to sit over here, because actually the online participants are in this direction, and it will help me look this way if I have people to look at. Yeah, my name is Joseph Debugging, and I'm working with KDE. And the talk today is going to be called Achieving a Circular Economy with Free Software. It overlaps a bit and I hope complements the great talk earlier today from Fairphone by Luca. I'm also going to try to reference some of the other projects like the Frameworks project, which is also totally relevant, and Asahi Linux, which is also in the slides today. I'm the one who's privileged to be up here on stage, but actually the real work is done by the community. I'm going to try to remember to acknowledge them throughout the slides. Of course, I won't be able to acknowledge everybody. This work is also, in part, was funded by the German German Ministry for Nature, Nature Conservation, Nuclear Safety, and Consumer Protection. In a project which went from 2021 to 2023, and is now and was also partially supported by the KDE nonprofit, which is a great nonprofit supporting thousands of volunteers to do great work developing KDE software. We're running a fundraising campaign right now. Check out the website if you want to support us and what we're doing. Two warnings in my talk today. So one is it's a bit depressing. I'm really going to go into some of the more depressing aspects of the climate crisis right now and how it relates to software. And a second warning, I'm going to quote the Pope, not for religious purposes, but there was a recent publication that's relevant, and even the Pope is raising red flags about what's happening in the climate. All of the slides have lots of links and sources in them. You could download them from the repository. I'm going to leave this up here, and to get started, I usually like to ask the public a couple of questions to start some interaction. And the first questions are just going to be yes or no questions. If you feel that the answer is yes, just raise your hand, okay? So my first questions are related to what you associate with free and open source software. So who here associates collaboration with free and open source software? Okay, most hands are going up. Who here associates free and open source software with passion? Okay, a lot of the same hands. Who here associates it with autonomy? Okay. Transparency. Great. Sustainability, in terms of environmental sustainability. Okay, many less hands now. I hope by the end of this talk, I convince all of you that the next time someone asks that question, you will raise your hand. Okay. A couple more questions before we get started. So, who here is familiar with this symbol? Another yes, no question, raise your hand. Yeah, okay. Who here can tell me what the 3 R are? So go ahead and just yell it out. Reduce, reuse, and recycle. These are the 3 main topics that I'm going to focus on today in terms of the circular economy. Of course, it's a more complex topic than that, but I'm going to reduce it down to these 3. Okay, one last question. This is a collection of essays that many of you may be familiar with. Who can fill in the blank and just yell it out when we get to it? Free software, free society, okay? How do we get from one, free software, which is a technological issue, to the other, which is free society, right, which is a social issue? And I'm going to focus on 2 inherent qualities of free software, that is autonomy and transparency, in terms of how they relate to the other qualities that we associate with free software. In this case, it's free society, so it's a social issue. And one of the main points I want to make is that transparency and autonomy are not features added to free and open source software, right? These are inherent to the choice to develop free and open source software by design, right? You decide intentionally to have transparency and autonomy be part of your software development when you release your software under a free and open source software license. And I want to take those same two inherent qualities, the autonomy and transparency, and I'm going to argue that this is software design which enables the 3R, right? And there's a term for this. When you design your products to enable the 3R across their life cycle, that's called the circular economy. And a shift to a circular economy would have huge environmental impacts. There's one estimate that suggests that just shifting from a linear to a circular economy could reduce global greenhouse gas emissions by up to 70%. It's not just me who's saying that autonomy and transparency are critical for sustainable software design. The German Environment Agency released eco-certification criteria called the Blue Angel for software in 2020. And in the criteria, they recognize three main categories. So transparency and resource and energy efficiency, potential hardware operating life, and user autonomy criteria. And I'm going to go over these throughout the talk and then come back to this at the end. And this is the main model that's going to drive the entire conversation. So on the bottom here, you just have the linear model. The linear model being reduced to produce, use, and dispose, or more specifically, energy and material input, production, distribution, as the sort of production, transportation, use, and then disposal, and waste and emission leakage. And I'm not a great designer, but I tried to put this sentence interrupting the entire thing, because one of the main questions I'm going to try to answer throughout this talk is how does FOSS interrupt the linear digital model and enable a circular one? And I'm going to relate some of these sort of first order principles of FOSS, how it's influencing what we're doing at KDE and the KDE Eco Initiative. Okay, so that's the background. But let's talk about what the problem is. So what's the problem? What are we trying to address by talking about this and focusing on it in KDE? And how does it relate to software? So many people think of software as being something immaterial, but it's software that determines the energy consumption of hardware, and it's software that determines how long you can use a device. So going back over 150 years, there was the first study done on the greenhouse effect. It was by Eunice Newton Foote, a woman scientist who, when presenting the study, was actually presented by a man and only later attributed to her in the publication. In the study, looking at various gases and the effect of the sun on them, found that the highest effect of the sun's rays was in CO2. The receiver containing carbon dioxide became itself much heated, and on being removed from the sun was many times as long in cooling. Okay, this is 150 years ago. Over 100 years ago, the environmental impact this could have was already pretty well known. This is from an article in 1912 from Popular Mechanics magazine. And it states here that adding CO2 tends to make the air a more effective blanket for the Earth and to raise its temperature. This effect may be considerable in a few centuries, and we are now in that time where the effect is considerable. This is just from earlier this year. You probably can't read all the details in the graph here. This is from a climate scientist at the University of Reading, Ed Hawkins, in which he notes that changes are emerging across the climate system. That's shown in all of these graphs here. This is from pretty much the last 50 years, and they're all going up rapidly with one exception. Everywhere we look, the climate is changing rapidly. These changes are not natural. They are caused by the burning of fossil fuels. So these graphs are representing here carbon dioxide, ocean warming, sea level rising. The only one that's going down are the polar ice caps in terms of the ice. And then the quote that I mentioned earlier from the Pope, this is from just a few weeks ago, a publication which is pretty scathing in its critique of the role or the lack of action from governments, and very much in favor of environmental activism. And in it, he says, "I have realized that our responses have not been adequate, while the world in which we live is collapsing and may be nearing the breaking point." What does this have to do with us here? So these are some estimates of the greenhouse gas emissions from the ICT sector. This includes everything that can be estimated, so production, transportation, end-of-life treatment, things like machine learning training, usage from end users, data centers, networks, etc. And in the research estimates, it's found that the contribution of the ICT sector is on a par with the global aviation industry. So somewhere between 2 and 4% of global greenhouse emissions come from ICT sector. The aviation industry is about 2.5%. And if nothing changes, if it continues on the trajectory it's on, it's estimated it can go up to 30% of global greenhouse gas emissions by 2050. And this is from a report from the Association of Computing Machinery, and they point out a couple of the main factors contributing to the rise in greenhouse gas emissions from the ICT sector. One of the main ones is machine learning and training of AI models. Between 2012 and 2018, it was increased by about 300,000 times. From 2018 to 2021, when the report came out, it was doubling every few months. I'm sure that's much higher now, given recent developments in AI and machine learning. Another factor that's an important one, which is the number of internet-connected devices, in particular short lifespan devices, which is expected to increase to about 75 billion devices in the next 5 years. Yeah, that comes with huge environmental impacts, which I am going to talk about in this talk. Okay, so this is the linear model. And it's just to point out that all of these stages apply to both software and hardware individually. We saw some of this in terms of hardware in the frameworks talk, in interrupting this model. We saw some of this in the Fairphone talk. Today, I'm going to talk about where the two, so software and hardware, intersect with a particular focus on software. And I'm going to talk about it in 3 ways. I'm going to talk about lean software for longer and more efficient hardware use, vendor independence for hardware reuse and repair, and software recycling for new hardware support. And these are ways that we can interrupt this model, and I'll go into each of those in detail. So what do I mean by lean software? The efficient use of hardware, so doing the same task with fewer hardware demands. And this is relevant for the use stage of the linear model. This is a study from the German Environment Agency in which they compared word processors doing the same task in terms of energy consumption. The user emulation is referred to as a standard usage scenario. They compared various software products. I'm just focusing on the word processors. And they compared, in this case, an open source, that's all they identify it as, which is on the left, the green bar plot, with a proprietary word processor, which is on the right. And as you can see here, the energy consumption of the proprietary one was 4 times more than the open source one. And this is, again, to do the exact same thing. Okay. Now, for an individual user, this might not mean much. But when we talk about these things, we have to scale it up. Right? When we talk about software, it's distributed across millions of devices. When you think of word processors, every university, every home, every student, every doctor's office, et cetera, has a word processor running on it. And this is an example taken from an online course on sustainable software development from Detlef Toms, in which a back-of-the-envelope calculation is done to look at what would happen if you just reduce a process by 1 CPU second. And 1 CPU second reduction would be about the equivalent of 10 watt-second savings. That's nothing. Multiply that by 1.5 million users, which is a very modest assumption here. Making the assumption that that reduction is relevant 20 times and 20 interactions in a day, and that occurs 230 workdays a year. Right, that adds up to 19 megawatt-hour savings. This is from 1 CPU second reduction. If you want a comparison of what that might be the equivalent to, that's like driving a modern electric vehicle from Paris to Shanghai 6 times back and forth. Okay. I've been giving similar talks now for the past year and a half, 2 years, and if I can convince 500 developers that this is worth taking seriously, and each of those developers just makes 10 of these very manageable reductions in their software, multiply that by the 19 megawatt-hour savings, and we're talking about 95,000 megawatt-hours. That's roughly the equivalent of the annual energy consumption of 30,000 two-person households. Okay, so a small city. Another way you can think of this, flip it around, if you add more processes to your software, you're increasing the energy consumption potentially by the annual consumption of small cities. Okay, once you scale it up. So this is one of the motivations that is motivating KDE to start measuring our software. This is a usage scenario report from Ocular, looking at the energy consumption over time when running various tasks in a usage scenario. This is from the report that was submitted for Ocular to receive eco-certification. And yeah, this is something that we're starting to do. We want to integrate it into the general development process so we can take a look and publish information about how much energy our software consumes. This summer, with some great work by a KDE contributor, Karanjot Singh, together with help from, in particular, Volker Krauser, among others, has now integrated this into the CI pipeline so that when a developer wants, they can trigger the measurement process. This sends the usage scenario that needs to be prepared in advance into the KDAB measurement lab here. The lab consists of 3 main components. You have the system under test, that's computer running the software that we want to test. This is following the Blue Angel criteria with off-the-shelf hardware. It's a Fujitsu desktop PC. This is connected to an external power meter, which is just measuring all of the power draw while running that usage scenario. And all of this is then being triggered, and then the data is being collected by a data aggregator and evaluator. It's just a little Raspberry Pi. This is all sitting in the KDAB Berlin offices. They've been very generous to offer us space to set up our lab. The analysis, so that the usage scenario will run however many times that you think are necessary. The Blue Angel recommends 30 times for statistical reasons. You can run it 1 time, you can run it 3 times, 5 times, whatever you think is necessary. For the analysis part, it's looking at the energy consumption driven by the software itself. So you want to subtract out the baseline energy consumption from the operating system, as well as the energy consumption from the software when it's running idle. Okay, so that's all part of the measurement process. Once you've run those scripts, they can take, depending on how many times you run it, between maybe an hour to 5 hours. You get then the results back from a tool called Oscar, which gives you a PDF with various graphs and summaries of the data, the energy consumption. And then that gets, it's created as an artifact in GitLab, and then the developer can download it and look to see if changes were made to improve the software or if it's gotten worse, et cetera. This is still very much a work in progress. If you're interested in this, we want this to be set up for free software developers. So the KDE Eco Initiative is under KDE, but this project and the projects, the Blauwe Engel for FOSS, the Free and Open Source Energy Efficiency Project, K-Eco Lab, we want to be part of free software development in general. Some details about the way that that pipeline works. There's the build phase in which the Flatpak is installed on the lab computer. Then there's the energy measurement in which the emulation is run, and the data is then sent to a tool called Oscar. That's the open source software consumption analysis in R tool. It's developed by the Umweltcampus Birkenfeld, the environmental campus in Birkenfeld. And then that gets then, the script is run, the data is then sent back. Okay. This is all related to use, right? And use is just one phase in the linear model. And in fact, we haven't interrupted the linear model at all, right? This is just related to how much energy does software consume. There's really nothing particular about free and open source software in this, at this point. So what I want to focus on from here out is, oh, sorry, I got ahead of myself. After the use phase, you have the dispose phase, right? That's where hardware in particular is what I'm going to focus on, gets sent to, or maybe sent to a end-of-life treatment center or a landfill, or it might end up in your drawer, or we don't know. And there's various issues related to that. So as mentioned earlier in Luca's talk, the dark side of e-waste, right? There's a lot of e-waste being produced. In 2015, Achim Steiner from the United Nations Environment Program commented that there's a tsunami of e-waste rolling out over the land. In 2016, about 45 million tons of e-waste were produced. That doesn't really mean much to me. It helps me to think of it in terms of comparisons. One estimate suggests that would be the equivalent to the material for 4,500 Eiffel Towers. That still doesn't really mean that much to me, but that's represented here in this plot. If you were to take those Eiffel Towers and stack them up, that would be the equivalent to over 17 Mount Everests of e-waste in 1 year. Okay, so this is a lot of e-waste, and that was 2015. In 2019, the World Economic Forum commented that e-waste is the fastest growing waste stream in the world. In 2022, 60 million tons, so a 30% increase from 2016, was produced, and that's only increasing. Less than 20% of e-waste gets recycled, so if you have devices, send them to Fairphone. If it's supported, recycle them. Let's do this responsibly. For the e-waste that ends up in landfills, it only contributes about 2% of actual physical space in the landfill, but it contributes 70% of the toxic waste. Okay, so e-waste is a real issue. This is also presented earlier, this is the waste disposal center in Accra in Ghana. In the best case, this is releasing toxins into the air, into the soil, into the water. In the worst case, it's unregulated, there's scavenging happening, and this is causing health risks to the people doing so. So this is in Ghana, this is just in the West Bank, this is from the burning of the cables that was mentioned also earlier in the Fairphone talk. This is during the day, the sun is here. This is in the West Bank, where this is also an issue. It includes also Thailand as another big area for e-waste. So there are very serious environmental aspects to the dispose phase, and then to replace those discarded devices, you start the process over, right? And then you have all of the energy and material input, production and distribution, which also has its own problems, right? This is from the 2019 Apple internal report. It's published, but it's a lifecycle assessment of their products in terms of sustainability, and they estimate that for the iPhone 7, over 80% of the greenhouse gas emissions for that product over its life cycle, which is estimated at about 3 years, is in the production, transportation, and disposal, in particular production. One thing to note, I just noticed that the Fairphone has a lower overall CO2 associated with its life cycle. It'd be interesting to look at the details about that. Exactly. So, okay, usage is actually just a small part of this. And another thing to note is that in the book where I was made aware of this data, it's a book called Smarte Groene Welt, Smart Green World. They compare the increase in production costs over time, and they find that although the earlier models maybe had a similar equivalent overall CO2 estimation, it's increasing in terms of what's going into production. And that's largely for newer chips, et cetera, requires different materials, and that's ever more energy consuming. Okay, and this also comes at huge social cost, which is why things like Fairphone and their emphasis on the supply chain is so important. So this is a picture of child labor in the Congo. The Congo is basically a dictatorship, and yeah, there are human rights violations happening to produce the cobalt to make our batteries, as one example. This is from a picture related to an article about the Supply Chain Due Diligence Act, which is a new law that just came into place in Germany, which says that companies have to be aware of the potential human rights abuses in their supply chains, and if they don't try to fix them, they can face fines. That might mean we all have Fairphones soon in Germany. Yeah. And software design plays a critical role in all of this, right? Software bloat, feature creep results in messages like this device doesn't meet minimum system requirements. I know family members of mine have had this problem with laptops that aren't that old. It's one of the ways I convinced them to try out Linux. If abandonware or planned obsolescence, this device is no longer supported, right? And the result is that functioning devices are discarded and new devices are produced and shipped unnecessarily. And so how does FOSS interrupt this linear model, right, of produce, use, and dispose? And that's going to be the rest of the talk for now. And the first point I want to make is about software freedom, so the free and open source aspects that are inherent to FOSS, enabling lean software to combat premature hardware obsolescence. So if we go back to this comparison of the two word processors, and look at them over time. So on the x-axis you have time, on the y-axis you have the power draw. The top plot is showing the proprietary software product, and the bottom plot is showing the open source one. And I'm going to focus on what's happening after this sort of neon blue line. This is the point at which the document is saved and the software goes idle. And what you can see in this plot, and this is again from that German Environment Agency report, you can see that the top plot continues to do things. It's continuing to pull energy. What exactly it's doing is not clear. It's not stated in the report. I don't know. It could be telemetry. It could be preparing for other processing. What you do see is that the open source product actually goes idle. Right? So when thinking about this in terms of lean software, if it's proprietary software, you're dependent on the vendor to improve that software. You can't do anything as a user. And I'm using an example here from a delightful children's book from the Free Software Foundation Europe. This is an example in which there's a world in which one software developer controls most of the devices. Here you have a skateboard, toilets, ice cream machine. And in this book, it describes a situation in which, with a key, the main developer in this community could make all the ice cream machines dispense only vanilla ice cream. And sometimes people were disappointed when their flavor wasn't available, but what could they do, right? They were dependent on the vendor. The name of the book is Ada and Sangerman, A Tale of Software, Skateboards, and Raspberry Ice Cream. It's really a nice little book. It's a great gift if you want to explain to people what you're doing for adults and for children. And one of the main points I want to make here is that the 4 freedoms that come with the transparency and autonomy inherent to free software, the use, study, share, and improve, mean that if there are inefficiencies in your software, you can do something about it. Right? And this is one of the things that's happening in KDE. If you want to contribute, you're welcome to. We've started tagging things related to, so merge requests related to efficiency with an efficiency tag. We also now have tags for inefficiency in our bugs. Since we've started doing this is just from the last year and a half, we've had over 350 MRs tagged with efficiency, the efficiency tag. This is related to things like, anything related to freezing, spikes in CPU usage, et cetera, et cetera. This gives us a way to start tracking how we are doing and making our software more efficient. Anyone can contribute to it. That's one aspect to it, but there's another aspect, and I think there are two more that I'm going to talk about in terms of lean software. And I'm going to talk about this. I think we take this for granted in the free software community, that you can uninstall things, right? This is sort of a duh. Of course you can, right? Just put in the command and you've uninstalled it. This is not a given. And when you have those unwanted software components remaining in your system, they're going to cause inefficiencies that add up. Think back to that example with just that one CPU second reduction. If you think about all of the ways that those inefficiencies in terms of your boot up time, shutdown time, the use of your RAM, et cetera, are contributing to energy consumption that you don't want, being able to uninstall makes your software more lean. You can also often install what you want and nothing more, nothing less. You don't need to install the entire thing. You can install what you need to use, and that's it, right? And those contribute to a lean software design. Another one that I think we take for granted is the freedom of offline capability and freedom from advertising. Now, KDE has a policy of opt-in, so by default, any telemetry is off. If you want to, you can help contribute information to us by turning it on. This is a report for the EU about the carbon footprint of unwanted data use. And what they refer to as unwanted data use is the types of tracking that users cannot turn off. And this is within the EU. And I like this plot because it shows energy consumption both in the network and data centers. And they estimate that about 60% of EU citizens would turn off certain types of tracking if they could. This is based on some questionnaires they've sent around. And that unwanted data use contributes between, the carbon footprint of between 350 and 950,000 citizens in 1 year. Okay, this is for something that people don't want. So being able to turn this off, this is really low-hanging fruit, but this is something we are already doing, right? And emphasizing this, that this has sustainability benefits is huge. And one of the things that we're doing in KDE is we're trying to focus on awareness raising by documenting the various ways that our software, being free and open source software, contributes to a more sustainable software design. This is also a work in progress. Hopefully it will be integrated soon. An eco tab in our software alongside our about information, our authors, our thanks to, et cetera, highlighting the ways that this software, being free and open source software, has sustainability benefits, as well as any links to measurement reports that we're doing in our lab or eco-certification if we pursue that for other software products. Okay. That's in terms of the longer use phase, but now let's look at reuse, right? FOSS makes it possible to give old hardware new value. This is a real example. It's a laptop, a MacBook from 2009. The end of support was 2019 with macOS 10.10. This is still being used by a KDE contributor running Ubuntu 22.04, up to date, works great. This would otherwise end up as e-waste, but given that there is a software alternative that runs up to date, that's not dependent on the vendors, you can keep using this hardware. This is just an example again from the children's book Ada and Zengerman. This is going back to that ice cream machine. It's an example where the Ada, the protagonist of the book, was able, from a broken ice cream machine, to build a new one that can make ice cream in every imaginable shape and color. Right? You can do new things with that old hardware when you have access to the source code. And this need for software repairability, so what I mean here is that we can continue giving security updates in this context, right? That we can patch the software, which you can't do once proprietary software is no longer supported by the vendor. This is a report for a circular economy from the EU from 2020. And they note that value is lost when fully or partially functional products are discarded because software is no longer supported. and with a focus on electronics and ICT as a priority sector for implementing the right to repair, including a right to update obsolete software. And this is an open letter to EU legislators from the FSFE, the Free Software Foundation Europe, as part of the Upcycling Android project. I'm going to question, how can you have a right to repair without software freedom? I don't know what it means to have a right to do something if you can't access the things that are needed to make it run, right? So FOSS here, again, I think is necessary to enable a circular economy in terms of repairing devices so that you can reuse them. Okay, and this is the last aspect of the circular economy that I'm going to look at, recycling, and I'm going to talk about it in terms of software recycling. There was just a talk right before mine, and I'm really honored to be able to talk about their project after them. It's a really amazing project, the Asahi Linux project, and free software gives you the freedom to integrate with existing code, right? You don't need to reinvent the wheel. They're doing incredible work to make Linux work on the M-series chips, but they don't need to do everything. They can integrate that into existing code bases and provide usable operating systems on new hardware. And one of the important things about that is that if you go to this entire model, by recycling software so that you can support new hardware, that's going to influence all the stages down the line, right? So that when you get to the use phase, you can improve it, make it leaner, make it run so that it consumes less energy. When the vendor no longer supports that hardware, we can continue supporting it by patching the software when needed, et cetera. So this has effects down the line. So to come back to the Blaue Engel, the Blue Angel eco-label, as I mentioned earlier, they recognize that autonomy and transparency are crucial for sustainable software design. You don't need to be free and open source software to be eco-certified, but there's an advantage because you're developing free and open source software, you're already fulfilling many of the criteria. This is a summary of the three main categories. So to be eco-certified, you need to be transparent in terms of your hardware performance and energy consumption, your minimum system requirements, as well as your support for energy saving modes. You have to run on hardware at least 5 years old. Now, this seems very low to me. I think we could do you could run on much older hardware, as many Linux enthusiasts are. But the real false advantage comes in this user autonomy criteria, where documentation of your support for uninstallability, modularity, continuity of support, offline capability, freedom of advertising, documentation so that that software can continue to be supported over time, transparency, that it's either it's open source or the APIs support open standards, things like this. FOSS is already fulfilling many of these criteria. It's a matter of documentation. KDE is proud to be the first ever eco-certified computer program in the global eco-labeling network. We applied for eco-certification of Ocular about a year ago, and earlier this year, last year, we're certified. If you're interested, we have documented the entire process in a handbook covering many similar topics to what I've talked about today. You can download it from the website eco.kde.org. The title of the book is Applying the Blue Angel Criteria to Free Software. It's right now in 3 parts. We're including a new chapter soon. The 3 parts are the why. Why is this important? Covering many similar topics to what I presented at the beginning. What is the Blue Angel? What are the criteria? What does uninstallability have to do with energy savings, things like this? And then maybe the most important one for software developers, how do you then measure your software? Perhaps some of this is no longer necessary. If you want to use our lab, it's now mostly automated, and hopefully we can continue in that direction. KDE last year, this time, adopted 3 new unifying goals for the community. one of which was sustainable software. And it's now a focus of the community to focus on ways that we can create a culture of sustainable software design, raise awareness how free and open source software, and KDE software in particular, is more sustainable, and looking at energy consumption of our software. And I have a few slides after this. They're kind of like tooting our own horn kind of slides. But in case I didn't have enough time, I wanted to put this here. I like to conclude some of my talks by raising the question I think many people ask, is all of this worth it, right? Adding extra steps into the development process, there are bigger problems, et cetera, et cetera. And of course, XKCD has a comic that's relevant. And here it's cue ball and white hat talking, and cue ball says, "I'm trying to fix a problem with the world, can you help?" And white hat says, "It's obvious you don't actually care. If you did, you'd be trying to fix this bigger problem instead." And cue ball responds, "Okay, you want to help me fix that bigger problem?" And white hat says, "No, for another reason I'll think of later," right? So let's not be white hat in this and just find excuses for not doing something is maybe the first thing to say. But I would also say there's a logical fallacy in this kind of argumentation. Saying there's a bigger problem, that might be true, and I think there are bigger problems, right? But that doesn't mean the other thing is not a problem. And I hope I've shown you that there are various problems related to software development that are relevant, that do have an impact. Another thing to think about is what resources do you have at your disposal, and what is your likelihood of success? So tackling the biggest problem may not be the most effective strategy. We're software developers. I'm not actually, I'm an enthusiast, but many people here are software developers. You have agency. You can do many of these things. You can start thinking about this stuff, and it does have an impact. Thinking of just one CPU second reduction when you scale it up can have huge energy savings. You can do this, right? We can make these changes and start bringing this into the culture of software development in free software communities. And yeah, the last point is that software does have big impacts. So I hope that I've convinced you of that. And again, this is, so quoting the Pope, I like this quote, I like it as a sort of a summary. Every little bit helps, right? And avoiding an increase of 1/10 of a degree in the global temperature would already suffice to alleviate some suffering for many people. And this is maybe even more important to me. It's something less quantitative, right? We need to realize that there are no lasting changes without cultural changes, which is one of the things I'm really trying to do in the work that I'm doing with KDE Eco. And there are no cultural changes without personal changes. So we need systemic change, we also need individual change, and we can do this. I'm just going to toot our own horn a little bit. There's been a lot of outreach related to the KDE Eco project, in particular after certifying Ocular, which raised awareness of what we're doing. There was an invitation to join the Green Party at the German Parliament for a Sustainable by Design conference. Cornelius Schumacher, who's been really influential in this entire project, attended as a guest speaker, among many other people like Cory Doctorow and big-name German politicians. You can read about it at the blog. In the House of Lords in London earlier this year, or maybe it was end of last year, there was the Open UK Awards. Here you can see KDE contributor Jonathan Riddall, who joined together with the Francis Maud, who was a member of the House of Lords, who was influential about a decade ago in creating a website for information about open data and open formats in the UK. We were there as co-hosts for this Open UK Awards. This is a partnership with FOSS Nigeria, working in remote areas, teaching children, the Almajari children, so they're focusing on education, but they also are focusing on sustainability aspects of this. One reason is they want to have control over the devices, so they're using free software, in particular Plasma Mobile. It's also interesting they're running a lot of this on solar energy, from what I understand, because it's not the areas they're going to are not connected to the electricity grid. So this is something that we're also involved in. We've had a lot of work in season of KDE, working on some of the tooling. There's a KDE Eco Test, which is an emulation tool based on XDo tool with Python to emulate user behavior for creating usage scenarios. We have some preparation for Blue Angel certification, and then Selenium scripting, which might be the next chapter in our handbook, using Selenium to emulate user behavior, which can also run on Wayland. Right now, most of the emulation we're doing is on using XDo tool, so it's only in X11. We want to also look at the efficiency in Wayland. This has been reported on in a German magazine, heise.de. Selenium in particular is quite interesting to us. It covers many different aspects of the three main goals in KDE. You can also read about it at our blog. There's a sustainable software awesome list at the repository. You can check it out, featuring links to many different projects. And then just to give a shout out to a couple of projects that are doing things that are relevant to what we're doing and have collaborated in some way with us. There's the Free Software Foundation Upcycling Android, which is keeping smartphone devices in use with Android derivatives. There's the the Sustainable Digital Infrastructure Alliance. Next month in Berlin, they have a green coding summit. They've also been influential in the work that we're doing in KDE Eco. And then the Green Coding Berlin, which is also developing tooling for measuring the energy consumption of software, also been involved in some of the lab setup aspects of what we're doing at KDE Eco. And finally, the Green Web Foundation, they're doing estimates of energy consumption related to websites. So all projects worth checking out. There's many ways to get involved with us. If you're interested, check out our website, eco.kde.org, contact me. We have a monthly meetup the second Wednesday, so next week. Next week we will be talking about Selenium, so you might be interested joining to check out what we're doing there. Mailing list in a matrix room. And just one more time, the slides. So that's the end of my talk. Thank you.
We have time for a question or two, if anyone wants.
Thank you very much for such a presentation. You have mentioned several steps about what each organization could do to make their software more sustainable, but could you provide some examples on what we as individual developers or enthusiasts could do on a personal level to help the sustainability? Thank you.
So as a developer, in terms of actual coding, I'm not the best person to ask because I'm actually not a developer. There are many things that you can look at. If you look at CPU spikes, that correlates often, not always, but often with energy consumption, and trying to fix those kinds of bugs will have an impact on the energy consumption overall in your software. One thing I would think about is ways that you can implement maybe some of those user autonomy aspects into your software, things like opting in instead of opting out, so things are shut off by default. I know that isn't necessarily what you want as a developer, but these do have sustainability impacts. Things like this I would recommend as sort of low-hanging fruit. Those are just two things that come to mind. I'm sure there's very specific things in each individual case that, I can't really address, but if you want to talk and exchange ideas within our community, you're always welcome to join our mailing list or matrix room or come to our meetups and ask questions where people who are much, much smarter than I am can maybe give you some tips.
Hi, thank you for the presentation. I've been thinking a lot in the past few months about our continuous integration systems. So for any given software that you can imagine, we're basically booting a machine, installing basically the same dependencies that we just installed 5 minutes ago, and doing lots of crazy stuff, and running tests for half an hour. And are there any measurements of how much does that contribute to the whole footprint of the ICT industry?
No, but that's something that we have talked about also in our community. So that's one thing when looking at this linear model. That's the software production phase, a software which has its own carbon footprint and is embodied in the software release that you have, right? That's the embodied carbon of a software project. I don't know of any particular projects looking to quantify that yet. I still think we're at such an early stage in this, but that's certainly on the radar, and I think it's a very relevant topic, and I think it will be interesting if you work on that, or if anyone here ends up working on something like that, yeah, come talk to us, share what you learn. But yes, that's a very relevant point. There's a lot of energy consumption happening in just our CI pipeline. And that's also one of the reasons the measurement process is not triggered automatically. It's something that has to be manually triggered so that we don't want it running every time, right? That counteracts what we're trying to achieve here.
All right, that's time. One more thank you to Joseph. In just 9 minutes, we'll start lightning talks here. So if you're speaking, you should be up here by the AV stand any moments now.
And the title of my talk today is Changing the Engine Without Stopping the Car, and I don't know anything about cars. So this is with respect to documentation. So many of you here may think that product documentation in open source has very different issues than that of the proprietary product documentation, because typically there is an army of authors manning the documentation in the latter case, and they may have easy access to fancy tools, etc., but that's not the case. Because it doesn't matter how many people are behind the documentation if you don't build it in a way that's suitable for your product and your users. So the most common issue that I see in open source documentation is there's the engine missing in the car. So there is no good documentation to start with. So think again, how many of you here are trying to get people interested in a car that's missing an engine? And the next common issue is not having a direction, which is forgetting about the users. Sometimes we get lost in the process of building the product so much that we forget about the people for whom we are building it, right? So documentation needs must exist in parallel with the product needs. Especially in open source where there are like too many choices, it's easy to get lost. So good product documentation can be the key in bringing the users to your product amidst other distractions. And what's the key to a good product documentation? It's bridging the gap between the mental model of the person who's writing about the product and that of the person who's seeking that particular piece of information. If all this seems daunting, we have help. So there are multiple documentation frameworks and approaches that can help. I'll give a couple of examples going forward. So before we go to the next slide, so we can think for a moment, and if you want to restructure your product documentation from absolute chaos or even like get started with creating documentation, these documentation approaches help write with a purpose. So define your purpose and define your direction. Where do you want to go? And apply the improvements iteratively, diligently, and make the journey easier a little bit every time. And also grow tolerance to inconsistencies. It's okay as long as you are heading in the right direction. Just don't worry about the destination and enjoy the journey. Yeah, a couple of examples here, data and data access. So many of you may have heard of these two popular documentation approaches. So data is an open standard to develop structured documentation. You cannot and probably should not bend data to your will because it's imposing, but for a purpose. If you don't want to make too many decisions, just follow instructions and get your documentation journey started. Data might help you there. So it's like building your product documentation block by block. It focuses on functional quality, and it's like picking a standard preset engine model for your users. When you follow diet access, it may look very similar to data, but it's very different in its philosophy and application. Here, structure evolves more organically as you begin with cleaning up the first mess that you see. It makes your documentation journey more realistic and paced, focusing on deep quality. Here, you can build a customized engine for your users. And I want to end with a story. So there is this car showroom where the entrance sign says, "Good cars sold here." A critic walks into the store and asks the store manager, "Good cars sold here. Where else do you think you'll be selling the cars?" So the manager thinks, okay, yeah, that's redundant. Let me redo the sign, and he makes the sign as "Good cars sold." Yet another person walks in and they ask the manager that "Good cars sold, what? Otherwise you'll be giving it away for free." So the manager is now confused, not knowing what to do. He makes the sign to read as "Good cars." Nice and simple, right? Yeah. Yet another person walks in and asks, "Good cars? What? Everyone else is selling bad cars or what?" So the manager is like really frustrated now and not wanting to get into any trouble. He just makes it cars. You'll think the story ends there, but no. Yeah, another person walks in and asks, what, I came in for a sandwich? No. So as much as you can empathize with the situation, that's your audience. So go build that engine today and do it in a suitable way for your audience. Yeah. Thank you.
Next up is Alistair.
Hi there, I'm Alistair, and I am a software engineer at Canonical. And today I'd like to talk to you about an interesting problem that we faced at Canonical and an interesting solution to it. So, at Canonical, we make a product called Juju for managing cloud applications, but for the purposes of this talk, Juju is 1.6 million lines of Go code that uses MongoDB to store its state. And because it uses Mongo, we've decided to replace Mongo with a SQL database. Mongo is slowing it down, and we want to speed it up. This means replacing all the Mongo transactions with SQL queries. So the question is, what is the best way to communicate with a SQL-based database from Go? That means, how do we turn the Go data structures into SQL tables and columns, and how do we communicate back again? So we can do this by using the Go standard SQL library. We can write a SQL query such as this one, which selects an address with a house number, a street, a city, and an ID from the database. And we can send that query to the database. We can read the contents of the rows into the structs. But as you can see, this big block of Go code is quite a lot to do that very simple task. There's quite a bit of things in there that make it quite difficult and error-prone, and we can do better than this. So what is the obvious solution? A ORM. So an ORM is a library that takes your SQL database and manages it for you. You just ask the ORM what you want from your database. It generates all the SQL queries, it does all that for you, and it returns the results in the language you ask them for into Go, in like Go objects. But there are problems with this. The fact that it generates the SQL queries itself means that they're not necessarily optimized, and they're not necessarily exactly what we want. We want to write queries that are sympathetic to the database that we're using. So what we really want to do is write our own SQL queries and get all the benefits of an ORM. And we had an idea at Canonical how to do that. We looked around, no one else had done it, so we implemented it. The core of this idea is that instead of writing the columns of your SQL query out, you instead write the struct, the Go struct that you want to put those columns into. So here we've got the address struct, and the dot star means that we want to fill all the fields of that address struct and fetch those from the database. And instead of writing a positional input placeholder, we write the field in a struct, in this case also the address struct, that we want to take that value from. And we've done it. It's called SQLair, this project. There are quite a few other features. I'll just show you some example code. So, well, this is how you tell SQLair that the columns, which columns correspond to which fields of the database. So the number field corresponds to the house name column in the database. And here is the code from earlier, but rewritten in SQLair. So here we have the query at the top, and then we're getting the results from the database directly into a slice, a list. So we're taking, instead of manually scanning each column into each field of the struct, SQLair takes care of all of that for you. It makes your life a lot easier. Admittedly, this code may not look particularly simple, but if you take some time to look at it, you'll realize once you've had a proper look at the library that it is a lot better. So the library has other features as well, such as automatically preparing the queries on the database, support for transactions and things, but it's still a project that's very much in the alpha phase. So if any of you guys are Go programmers or are interested in databases, please check this out. We're on GitHub, and yeah, we would appreciate your support. Thank you very much.
Came in before the cuckoo. Next up is Amalith.
Hello. Oh, did not mean to go that far. There we go. So I'm Amalith, and I work at MBOA on a project called JMP. I've been running nixnet.services mostly solo for about 6 years. And I co-host a couple podcasts, I'm a musician, and that's where you can find my contact info. The especially pertinent part of this slide is the Nixnet part. It's a collection of open source web services that I've been operating for all that time, 6 years, but I provide them publicly without charge. I do it for free. But in all that time, the most painful part of running Nixnet has been keeping up with the releases, because all the different platforms where that software is developed and collaboration happens, they all have different capabilities for keeping up with releases. Some of them have insight notifications, some have RSS feeds, some have APIs, some have nothing, and for the custom front ends you might see around, there's no way to know what they support and what they don't. So on the surface, tracking releases in a unified way is not possible. But that's not quite accurate, because they do all have one thing in common, and that's the version control system, Git. All of them, the release functionality on all of the different platforms are lightweight abstractions on top of Git tags. Sometimes those are annotated tags, sometimes they're lightweight tags, but to track releases across all of those platforms, all we have to do is understand Git tags. So Willow is a piece of software I've been developing that is an implementation of that idea. It's still in proof of concept stages, alpha quality, but it does work, and I've been using it for a few months. This is the home page. We can track a new project. There's a list of them. It indicates what we're running at the moment, whether there's a new release, and it also embeds the release notes for that release in the page, so you can see whether you want to apply that update without ever leaving that one web UI. And this is an example of a Git-only piece of software. It's not on GitHub, it's not on Forgeo, it's not on any of those. This is an annotated Git tag. Because Willow speaks Git, it understands that the annotation is the release notes, and we put that in the web page. And for projects developed on platforms that have RSS feeds, we can ingest the HTML from the RSS feed, sanitize it, and then put it in the web page. And this is the, again, proof of concept form we have for adding new projects. We have the URL, the name, and we have to indicate the type of forge it is, because there's not a great auto-discovery system at the moment. There are some specifications around, but all of the forges do not implement that specification. And then this is an example of SQL Boiler. We are adding a new project. We indicate that we're one release behind the most recent release. And as soon as we click that button, we see it is the second one down. We have our currently running version, there's a new release, and we have the embedded release notes. Development is primarily happening on SourceHut. There is the short URL there if you don't want to memorize the SourceHut URL. Contributions happen over email, but I also want to set up a GitHub mirror where I can merge PRs locally, push to SourceHut, and then syndicate to GitHub for people who prefer the pull request workflow. There are a couple of instant messaging platforms. There's also a mailing list through SourceHut. So if this idea excites you about being able to track all your software releases from one centralized location, please come help me make that happen. Thank you very much.
Next up, we have Gregory. Gregory.
Hello, everyone. My name is Grigory, and I work on the distributed storage
and data processing system, which is called Thesaurus. And today's talk we decided to make on problems that usually arise in distributed systems. And we thought for a long time about the format, and firstly we thought that it will be a song. So I started writing a song about the problems in distributed systems. I wrote a couple of verses. I sent it to my colleague who told me that they are good, so I wrote the third verse, and after that I understood the small issue. The issue was that we both are terrible at singing. So no songs for today, and I'll just tell one story from my job. Not that one. So it was nice Friday evening. I was ready to leave the work and go to get a beer with my friends. And well, you know, these Friday evenings, I got an alert that one component in our cluster crashed. It was 9 p.m. and I decided just to have a look at what happened, and the stack trace really scared me. The stack trace told me that our sorting algorithm is wrong. It was some operation that was distributively sorting some big table, and after the sort result, it was not sorted. Okay, so I started the investigation. And firstly, let me tell a little bit about how our sort algorithm works. For that case, it consisted of two stages. During the first stage, the data was split into some parts, and each part was independently sorted. And during the second phase, these sorted streams were merged into one sorted table. And the system crashed because the result of the second stage was incorrect. The rows were not in the proper order. So the bug was either in the first stage when we were sorting rows, or in the second stage when we were merging the sorted streams. It was really surprising because this code was quite simple. The sorting of the rows is just a call of the sort from the standard library, and the merge is just a simple algorithm with heap. So it seems quite weird. After that, I spent an hour or two trying to figure out where the bug is, and just by looking into the code, I didn't find anything. So I needed to go deeper, and firstly, I tried to understand which part of the algorithm was wrong. And to do so, I tried to get the data that was the result of the first stage and check whether it was sorted correctly. Unfortunately, it was hard because the operation failed and the intermediate data was removed, so I had no idea what is the result of the first stage, and to figure it out, I spent another hour or core dumping some processes and trying to get some rows from caches. And okay, it was like a midnight, no more hopes for a beer with friends, and I figured out that most likely the problem was in the merge stage. I was not 100% sure, but it seemed quite likely. So I was reading and reading the code again. I was looking into the core dump, and I didn't find anything. Everything looked fine. It was, I guess, 1 a.m., and I'm starting getting crazy because I didn't understand how is it possible. So finally, my last hope, I opened the core dump and started looking at the rows that were sorted incorrectly. And the rows that were wrong were just some URLs of sites that have been sorted. And all of these URLs belong to one site, say, I don't know, ubuntu.com. And all of these rows were started from ubuntu.com, except for the one, which was ubuntu.co.e. Seems strange, how is it possible? I had no idea for, I don't know, a half of an hour, and after that I got my last hope. I opened the ASCII table and looked for codes of M and E. Oh well, the difference was 8, so it was a bit flip. Thanks, Cosmic Ray, for no beers this Friday.
All right, we will have closing remarks in 10 minutes, but before I let you go out and get some coffee between that time, I want to remind everybody that our closing party is at 7 o'clock, and it is just 1 block northwest of here, which means you leave the hotel and you make a right and just go 1 block. It's in a place called the Digital Art House. Looks like it's going to be amazing, and you do need to bring your badge with you. So see you back here in like 8 minutes.
small and so useless. Will you save me from falling? See the rain covering me, and my tears are like ocean. Will you save me from falling? See the smile upon your face, and I know there is true now.
All right. Hasn't it been memorable and exciting in the past few days at the Ubuntu Summit? Woo! The energy and participation I've seen here has been such a standout experience. Thank you for really bringing the absolute best to the table at this event. Looking around and seeing so many of you smile and laugh and talk with each other and learn and listen is telling me that our mission for this event is accomplished. Just 1 year ago, we had quite a few folks in Prague. But this year, there's so many more of you, so many more that are ready to be inspired, enjoying open source with Ubuntu. Even after 2.5 days, I've already heard about some amazing stories that will be great for next year. Ailo, where is she? There she is. Ailo would like to get an Ubuntu Flavors design squad off the ground to promote more non-code contributions that cross all of the flavors of Ubuntu. You know, certainly not every flavor of Ubuntu needs a dedicated designer, and this is a great way for everyone to get together, establish their skills, and really make an impact. Also to urge more non-code contributions. That's something I've really heard repeatedly. There's a bunch of folks. Ariel, where are you? In the plane. Ah, okay. Well, you know, they've been sharing their experience on getting designers and engineers together, and I think this is a really great way because, you know, sometimes we think about non-code contributions on the one hand and engineers on the other hand, but really having that cross-knowledge is a great way to create that mutual benefit. Elio, Anna, and others would also like to create the design community together and get more people involved. There's so many of you here with a common interest around design. It sounds like we might already have a new community group. Walking by, I overheard conversations between Mikhail and Sergio. Where are you two? There's one at least. Sergio is from Sweden and would like to bring together the local community in Sweden and really, you know, getting more people talking about Ubuntu. There's a regular event called Linux Fika, which translates to Linux Coffee Break, and you might see a talk or two from Sergio there in the future. Noah, where's Noah? Noah, who you may know from the Ask Noah show, he was super excited to set up a local community in his state as well. I've also seen people running after each other saying, hey, wait, I have an idea. Really, no matter if it's a collaboration between companies or individuals, this is a great place to get that kind of thing started. There's the folks from the Ubuntu Hideout Discord, also somewhere around here. There's one, there's two, there's three, awesome. I've heard you've been thinking about ways to channel the contributions and make it really easy for people to get started and share that with your community, which I think is a great way to focus on the many ways that you can contribute to Ubuntu. Thank you very much. Also, you know, there's been profound thank you messages on Telegram, social media, Matrix. You know, if you like a session, you kind of go out with a smile, but spending some time to really thank those speakers in the channels that we have, that means excitement is going beyond. So let's get a first round of applause for all of these amazing people so far. The Ubuntu Summit this year has held over 130 presenters, and this is just a subsection of all the amazing people that have been on stage or in the rooms with you. They speak about their passion, craving not only to teach you what they've learned, but also to take you with them on the journey of open source. There's so many more sessions. If we had given you the chance to see them all, we'd be here for almost 2 weeks. I'm very much looking forward to the recordings, to keep those memories going. So there's something for all of you to take home with. If you were a speaker at this event, could you please stand up? Ah, look at that. Round of applause for that. Next up, this is not something that I just kind of did alone in my room. There's a bunch of people involved in this event. If it's around registration or traveling or helping speakers get here, or talking to one another, there's really a lot of people involved in this type of thing. So I wanted to spend some time to thank you. Our moderators of the days, there's 3 of them. Where are you? Not moderating anymore, apparently. So thank you, moderators, for being here. On a scale of 1 to 10, how entertaining do you all think the moderators were? Yeah, that sounds like an 8. Can we get a 10 maybe, or is 8 the thing? All right. EA and support teams, these are the unsung heroes of the event. If you're saying, oh yeah, this event is really running smoothly, that is because there's so many people keeping the parts moving. So on the corner over here, we have the support team. And hopefully no longer sitting outside, but a way that we can give them a round of applause. Otherwise, you're just going to have to clap a little bit louder. The EA team of Canonical. Also, the Latvian community. There's Pataras, there's Kangaroo as nickname, there's Leo, Alina from the Student Council. Really many more people who've brought so many interested open source people here. And I'm really enjoying this enthusiasm. There's a bunch of people that kind of came up and said, oh yeah, I want to create and recreate the local Latvian community. So I think we're going to see a lot more from the Latvian community. So stick to those people if you're from around here. Applause for that. Finally, saving the best for last, all of you. You have been such an amazing part of this event. If you feel you've played any role whatsoever in putting this conference together, please stand up. Wait, that's it? No, come on. So you were at this conference, you get to stand up. You were at this conference, you get to stand up. Everyone was at this conference and it was a major part of this event, so everyone gets to stand up. All right. So, by taking part in this event, you've been part of that friendly and welcoming conversation that Nathan so eloquently talked about in the opening plenary. You are now part of the Ubuntu community. So this is your opportunity to take that next step. How can you use that knowledge that you've gathered here and make it your Ubuntu? I am, because we all are. Can you say that with me? I am, because we all are. All right. So before we head out to a few other things, I'd like to introduce Marilyn from the Ubuntu Community Council. The council leads the Ubuntu community and is made up from volunteers elected every 2 years. They delegate to a number of subgroups, such as the Local Communities Council, an initiative that I've talked about on Friday in the opening as well. So, round of applause for Marilyn.
Hello, everyone. So, as you all know, Ubuntu local communities are quite important to have this face-to-face connection without having to fly to the other side of the world to meet at the Ubuntu Summit, for example. We really want the local council to become a place to empower and support local communities. We want them to connect the community council and Canonical together and coordinate across local communities. As the local workshop showed, there are a lot of issues that multiple local communities are all struggling with, and they can build solutions together. But we need people in the local council. And that's why we actually have a call for nominations, a call to find people to help out with the local council. So what we're looking for are people who want to help out and who want to get recognized for their contributions to Ubuntu and to the Ubuntu local groups. It's important that you're a good communicator, so you can be the bridge between the different local communities, Canonical and the Community Council. And you need to be an Ubuntu member. Now, some of you might ask, what is an Ubuntu member? Some of you might say, I'm not actually an Ubuntu member, but I'm interested in this. Well then, you can become an Ubuntu member in only 3 easy steps. Well, they're not so easy, but still, we can summarize them in 3 steps. The first step to become an Ubuntu member is to contribute to Ubuntu in any way you want. Are you an organizer of local events? Do you moderate our online spaces, or do you write code? You can contribute in many different ways to Ubuntu. That's the first step. If you've already done that, congratulations, you've succeeded in the first step. The second step is to create online a list of your community contributions. So you can show other people, look, this is what I've done, this is how I put my stamp on the Ubuntu community. And then the third step is to apply. You can scan this QR code to go to the easy guide that shows you how you can apply to become an Ubuntu member. It's a process that's quite easy and that's that goes quite quickly. But the issue is that a lot of people who are actually contributors are not Ubuntu members because they don't feel as if they've contributed enough to become an Ubuntu member. Well, almost every single person that became an Ubuntu member, the membership board, who decides who is allowed to become an Ubuntu member, the membership board said, oh, wow, are you not an Ubuntu member yet? You should have done this a lot earlier. So, if you made some contributions, please become an Ubuntu member. And so if you're already an Ubuntu member, or if you're becoming an Ubuntu member, then you can nominate yourself for the local council. If you want to help out, build the local communities, if you want to help be the bridge between the local communities and the different parts of our community, either you can send an email to the Community Council mailing list to nominate yourself, or reply on our discourse post. The only thing that's important that you do in your message is that you add a list of your contributions on discourse so that people can see what you've done. This QR code sends you to the discourse post where you can nominate yourself. So, thank you for your attention, and I hope to see you as a local community member or as an Ubuntu member.
All right, just a few small things. The closing party was already mentioned, but I wanted to give you a brief insight into what that might look like. This is from their website. And, in case you're thinking, oh, it's been a long day, but I think this is going to be a really cool party, so I'm looking forward to seeing you. It's actually right around the corner. So that building right there in the front, that's the Digital Art House. That building right there in the back, that is this hotel. So I think that's going to be a pretty cool party. Now, if technology is working, we have one more thing that we're excited to show you. Technology? I don't know what's happening. Okay, let's give it a moment. I'm going to pretend to have a conversation. The microphone. Lights can go back. Lights down, video up. All of this is only possible thanks to you. Thanks, everyone. See you this evening. See you somewhere on a conference or at latest at the next Ubuntu Summit. All right, that's a wrap. Thank you.